Hello everyone, assalamu alaikum. So here I'm very excited to share with you guys, this is our new BLoC TDD with clean architecture course. Now we are almost done with this project and we are at the last phase of doing the coding and restructuring, and after that we'll be doing our course. Now if some of you wants to have this access to this code ahead of time, you can definitely get it from the link below. All right, so we're going to make the course, and now I'm going to introduce it, that how it works. So of course, there are three simulators over here. And why three simulators? That's because we are going to do a group chat very soon. Well, one of the simulators that I have already logged in, so this is the other one. Now over here, I would like to log in, but I need to create a new account first. So this is where actually I'm going to go ahead and create a new account over here. Now I'm going to give it my name, and email address could be over here, dylan@dbesttech. And now for now I'm going to use password. It could be any kind of password that you want, and then I'm going to confirm password. Now the whole thing has been done using BLoC TDD and clean architecture. Now most probably I need to, over here it says that okay, the email address is already used by another account. All right, so it might ask me to do an email verification, and we are waiting for it. So here we are, and this is here we are at the front end. Now, of course, this emulator is very different. If you do come over here, you will see that, of course, we have front end and user section. And here we also have user section. Now over here, the UI is a little bit different because this app also has admin panel. If you sign up as an admin, which I already did, so we have extra features like add video, add exam, add materials, and add course. Now over here, I'm going to come over here and log in as another new user. But of course, before that, I'm going to go ahead and do registration. So let me go ahead and sign up. Now, of course, for signing up over here and logging in, we are actually used Firebase. The whole backend has been done with Firebase because looks like it's the most popular one out there. So over here, we do see that, okay, we have three different users. They got three different names. And of course, these two users, they have the same role. And there is an admin panel as well as also a user. So same app actually works with different modules. So now over here from the source code over here on the side, you can see that we have this admin panel section. Now before I dive into this app features, of course I would like to show you from here that okay, actually we are using clean architecture. So we have over here like auth sections, we have data sections, we have domain sections or domain layer, and presentation layer. Now inside this, if you do know what is called presentation layer, domain layer, data layer, you would be very familiar with this. And if not, it's okay, you can take our course later, which we are going to release very soon in 10 to 15 days. And inside this, you see that inside domain layer, we have entities, repos, and use cases, which normally a clean architecture should have. And pretty much same over here. But of course, presentation layer is different than domain layer. So the folders, the structure could be different, and it goes same over here. Anyway, so in our app, we're going to definitely explain them step by step. Now back to our app features. Anyway, so over here, you see that when you come over here on the home page, you like to see there are notifications. So you can get notifications. It will be visible when we add a new course actually, then we get notification, which means the users. Now if you come over here, you can also delete a notification if you want. It cleans up itself. If you come over here, actually you can mute all notifications or clear all notifications. So I'm going to clear all the notifications. Okay, now let's see. So I'm over here and I'm going to add a new video. Now for video itself, actually we can pick a course. Now say for example, I'm picking React Native and I'm going to insert a video URL over here. Now for video URL React Native, I'm going to check one of the videos from my channel. Now I'm going to put the video over here. So what it would do, it would actually grab the URL from here, and looks like I have pasted it twice, which we don't need. Okay, right. And then we'll fetch the video. Now, of course, this app, you could also fetch video from your local storage. Okay, now we fetched it and then we can submit it. All right. So now, as you see, as I have submitted, the other user get the notification immediately. Of course, notification also has sound, but because I'm on emulator, the sound is off because I have to set it on Android emulator. Anyway, so as a user, other users would get it immediately, and you'd also see that for this user, we also have a notification. Now you can go ahead and click on this, and it says that over here we do have a video that's React Native, but I think the time also has a little bit problem, which we need to actually work on this, the time format itself. But apart from that, everything else is good. Now here we do see that we have two videos because previously I have added two videos. Previously I have added a video, and just now we added this video. Now you can go ahead and play it. So it will take you to YouTube directly to play this. Okay, of course you need to allow this. So as you can see, it's already started to play, but now this is what we are playing on YouTube. Okay, all right, it opened up YouTube for us. Now let's come over here, click on this. We'd like to go back to our app. So this is our app. So we could do the same over here. Now as you can see that the best tech has uploaded few videos. Now, of course, we could also add exams from here. You can pick a course. You can pick any of this course from here, and then you can just simply go ahead and add an exam. Like, for example, I could say, well, I'm going to have Flutter, like select an exam. Okay, now exam itself should be JSON file format. Now, I'm not going to do it, but actually we have tested that you can definitely go ahead and select, and it would upload automatically. So I'm going to go back, because now if you come over here on our home page, actually, so this is our home page, and let's come over here. We do have different buttons. Now over here we also have exams. Now we might have exams for Flutter, and let's go ahead and check. Now previously we actually have uploaded a few exams, but now of course the title is different because we are still doing tests. It's not really Flutter exams, but we just uploaded randomly some files from our JSON folder or from JSON. Now of course you can go ahead and work on the exam, start exam, and here you will have a basic understanding. All right, so here we actually started the exam, and you can choose and go to the next one like this, and here we also see we have a timer, so it goes on. So a lot of features actually the app has covered. So I will say okay, yes, exit. Now you can go back. All right, so this is where you can choose exams. You can see whether you have passed exam or not. Well, if you submit it, you'll see that it's been passed or failed, because it does the scoring as well. So if you do the scoring over here, you get to see that someone has done this. All right, anyway, so yeah, a lot of things goes on. Now one of the other thing that I would like to show you, and which we actually wanted to cover in this course, which we are going to release very soon. Now here you'll see that as a user you get to join group. Okay, so now you can select few of the groups. Now these groups are created as an admin, where admin actually upload courses, like as you can see over here. Each time you upload a course over here, from here, like add a course actually from here, when you add a course, then a group is automatically created, and users, they are able to join the group. For now, users can join the group automatically, but in future, if they want to join, you can also add a subscription model, which we are also working on it right now. Now let's go ahead and click on this. So over here, you are in the group. Now let's see what do we have. As an admin, I would be over here, and I can also join this group. All right, so we have groups over here. Joined group successfully, and you can send messages. Hello there. Let's send message. All right, so we see that it send message here automatically. And is it about the group? No, it's not about the group. Now I would see the groups and I would join this group. Actually, you can join any groups for now, and we do see that someone has already sent messages, but once again we need to work on the time. All right, so Ahmed has sent messages now because we are doing group chatting. So let's go ahead and take a quick look. How are you? Let's send it. So, well, we see it over here in this device, in this device, in this device. Remember, there's 3 different users. That means that it's a group chatting. Wow, a big group. So everybody gets it. And as you see over here, we do have different names, but of course, user profile, the file could be changed if you want. This is a default picture. And in our user center, actually, we get to change our picture. If you come over here, you can edit profile and a lot of the stuff. It's an amazing app that actually we worked almost months, 2 months to work on them. Anyway, we gonna be Flutter ambassador. All right. Okay. Everybody gets it. It's a yes. The best tech is so cool. All right. Anyway, so yeah, that's how it works. I mean, it has a lot of other exciting features. I wish I could cover everything. And a lot of other features are actually coming. So anyway, if you want to get early access to the code, definitely you can go ahead and buy it. And once you buy the code, you will have free access to the course as well, because you are buying the code. And you will have free access because we have your email if you buy it. Anyway, thank you for supporting.
Hello there guys, my name is Paul, I'm here with the best tech, and today we are going to embark on a journey that will unlock the secrets to building robust, scalable and maintainable applications. In this tutorial we'll dive deep into the clean architecture principles and explore why they are crucial to developing industry-grade applications. Right, so the challenge of software development, especially today, right, creating complex applications can be very daunting. And as projects grow, code bases become basically harder to manage, and bugs begin to creep in, and making changes become even risky. And this is where clean architecture comes into the scene. Clean architecture comes to the rescue, providing us with a blueprint for designing our applications, making them flexible, testable, and easier to maintain. In this project, we are going to be looking at more than the clean architecture. We'll be looking at how to use the clean architecture and how to combine all of that with the block pattern. At its core, clean architecture follows the principles of SOLID, S-O-L-I-D. If you've heard about SOLID, these are stuff that we learn in engineering classes and software development classes, but we never actually know how to implement them in when we actually start working in the software development field. But in the clean architecture, in my experience in Flutter, embodies these principles. So we have separation of concerns, and we have dependency inversion. We have a lot more, right? By dividing our applications into distinct layers, we have this clear separation between business rules, presentation logic, and data handling. You might not understand what I'm saying yet, but as we start building the application, then you will understand better what I'm talking about. So basically, as you can see here, we've got these layers, right? These 3 layers. This is what we do in clean architecture. We have 3 distinct layers. We have the domain layer, which sits in between the data layer. So at the top we have the data layer, and we have at the bottom the presentation layer, or you can swap them, right? But then I prefer to have the data layer. I prefer to imagine the data layer being outside, right, being at the top, because it faces the external sources, right? So in between the data layer and the presentation layer, we have the domain layer caked up between that, right? So the domain layer will be where our business logic will reside, not the block business logic. The business logic of our application would reside in there, right? So it doesn't have anything to do with any framework or any external dependencies. It will contain purely Dart code. Clean architecture comes in handy as well as our application grows over time, right? It enables us to adapt and add new features without actually messing with the stability of our code base, right? And also, it's also easier to understand and modify our application over time, because everything is structured following the principles that you know for clean architecture. So when you come back later and you want to change something in a particular feature, you know exactly where to go to change that, because the architecture defines that. And finally, if you're working in a team, right, it helps also with collaboration for the teams. For example, you could have one feature, for example, if we have the authentication feature, so we can have 3 different people working on one feature, but then separation of concerns, meaning that they will be working on these different layers without worrying about what the other person is doing and how it affects them. Because at the end of the day, it will all come together like bread and butter. So I hope you're excited. Yeah. I'm not going to waste your time too much on the introduction. Let's dive right into it. So, in this section, we will be diving into the essential concepts and techniques that will help you creating your clean architecture ridden application. So first of all, you can see we have 3 layers: the domain layer, the data layer, and the presentation layer, right? So let's start from the domain. So in the domain, we usually have 3 sub directories, right? So we have, first of all, the entity. The entities, as it says here, will represent the core data models of the application. They will be the blueprint of what objects you'll be passing around in your application. Take, for example, if we have a login feature, right, and when someone successfully logs in, what data do we need from the server? We need the user's data. So for that reason, we will have a data model, right? But not a model, sorry. We have a user entity, rather. So we will have an entity, meaning the blueprint that defines what structure the data will be in, or what properties a user's data will carry when it's coming from the server, right? So how is it stored on the server? What does the server give back to us? So if the server gives us username, age, and whatever there may be, I don't know if they're an admin or whatever, the entity will have all of that written inside of it to show what a user has, or what a user is meant to be. So the repositories, what do? They define the contract between the data layer and the domain layer, right? So this is basically usually done in the form of an interface, right? In other languages like Java, you can define interfaces. In Dart, we don't have interfaces, so we can mimic the functionality of an interface with something called an abstract class. An abstract class, we will see that in the course of the application, right? So these repositories in the domain layer define, so this is mostly what makes clean architecture so beautiful, right? It will define that structure. It will define basically the structures of how stuff is supposed to look like. So this is basically the blueprint of what functionalities we will be carrying out in the application. And then finally, inside of the domain layer, we have the use cases. Like I told you before in the previous session, the use cases will represent the business logic of the application, right? So they also depend on the repository, right? So they depend on a repository. It could be any repository. This is where clean architecture shines, because it makes everything so loosely coupled, right? You could literally give it any repository, that is a subclass of this repository contracts that we have over here. All right. So again, you don't have to understand these now, but this is here in case you need better understanding after the course or midway into the course or whenever you need to understand what we're doing. You can always come back to this session as a reference in order to better understand a particular session. So they will depend on the repository as it says here, right? And then they will call the methods from the repository to perform data operation, right? So they enforce the SRP principle, which is single responsibility principle, right? And they focus on specific functionality. So the use cases are actually the only modules in our entire domain layer that we will be testing, because at this point they're not interfaces, they're not contracts, so we have to test them because they will depend on the contract being the repository, this repository over here, and then they will embody or implement or carry out, not implementing really, but carry out the operations of that repository, right? So and then finally we are done with our domain layer and we're moving to the data layer. Now, similarly, in the data layer, we have models. Models are entities, but with extra features. So models are simply going to be extending, or I don't know, they're going to be a child of whatever entities. So if, for example, we had the user entity inside of the domains entities, and we also had maybe a buyer entity or something, a customer entity, whatever. Maybe you're building an e-commerce app, right? And we have maybe a customer entity still inside of the same entities from the same domain. Inside of the data layer of that same feature, we will also have two models that will extend those two entities. So we will simply have a user model and we will have a customer model. Right, and these models will extend the functionalities of the entities. The entities are the blueprints, the models are the implementation, right? The extension of these blueprints, and then they actually add more functionality to a user. What can a user do? We have the toMap, fromMap, the serialization basically. We have the copyWith method. In there we have whatever we need inside of the model. So, and we will also be testing the models. Now moving on, the repositories in the data layer will also be implementations of the repositories in the domain layer, right? So these people over here take these contracts defined here, right, and they then implement those contracts, put them into practice. Imagine a building and construction company where an architect has drawn the plan, and then the engineer will take that blueprint and then build out the structure based on that blueprint. This is what the repositories do. So this will define the way or the format, the contract, how it basically defines how the data layer and the domain layer will interact. So basically, somehow the domain layer needs to interact with the data layer, right? So this person will define the contracts that tells us how these two layers will interact with each other, right? So in this person will finally implement that interaction. This person will carry out that interaction between the both of them. So this is where we handle essential CRUD operations, right? So over here we'll learn how the repositories manage data consistency, and it will help us also improve our code reusability. So what does this mean? Essentially, this means that the repositories depend on a data source, right? So they depend on getting their data from a data source, and the data source will in turn fetch that data from the external sources, right? So HTTP from our server or from our database or even from local storage. It could literally be anything, right? So this is why there's that great separation of concerns, because if in your data source you decide to fetch data from a different API than you were already using, right, then you won't have to change any code in your repositories, right? You will only have to change that code in your data sources, and your data sources will still return the same entities or the same models down to your other layers, right? So if we had a login feature and we're talking to a server, and at the end of the day, the data sources was meant to get a user data from the server, convert it into a model, and then pass it down to the repository, right? If you change the server that you're talking to, right, you would only have to change the code in your data sources, because your data sources will still have to return a user data and also still pass it down, and create a model out of it, sorry, and then pass it down to the repository. So that process is untouched. It doesn't have to be, you don't have to modify your code. You can only extend on the only in the module that you have to extend in order to get your new feature working. Right, so and then we continue on from here, and then we get to the data sources. Data sources are they bridge the gap basically between our application and the outside world, right? So they query databases, APIs, even your local storage. When you store stuff on the user's device, on the user's local device, the data sources will handle getting and fetching all of that basically. So these data sources will basically depend on the external source, external packages. For example, the HTTP library. It would depend on that. If you're talking to your server using HTTP, if you're talking to your server and your server is Firebase, it will depend on your Firebase instances that you're going to be using for that particular data source. And then finally, we get out of the data layer and we move into the presentation layer. Right, inside of the presentation layer, we have our block or our cubit, and these will manage the state of the UI and our business logic. Right, so the block will actually depend on the use cases that we've defined over here. Right, so the use cases are link to the presentation, to the UI. So the block will listen to the use cases. The use cases will rather listen to the repository, this repository, and in our implementation, we will link that repository. Remember, the repository is defining a contract of how to communicate with our data layer. So the repository that we will depend on in our use cases will simply be from the data layer, right? Which will implement that contract over here. So in turn, that repository will talk to a data source. The data source will get the data, come back to the repository, bring it back to the use cases. The use cases will bring it back to a block inside of our presentation layer. And finally, the block will emit a state to the UI, and the UI finally listens to it and updates accordingly, right? So this might sound a lot more confusing right now because it's just spoken word, but once we start implementing, you will find it a lot easier than it sounds. It's a lot easier than it sounds. It sounds like a task. It might be a lot of boilerplate code, but it's worth it on the long run. So finally, we have our test-driven development. Now, TDD, when we're following TDD, it means we test before we implement. So if we were going to implement, maybe in the data source, if we're going to implement a data source, before actually writing the data source implementation in your test, you define how that implementation should work. So if this data source should return a user, you write a test that makes sure, or that defines, look, after this function runs, it must return a user. When you run your test for the first time, it will fail, obviously, because you have not implemented it yet. But then after you write that test, you then write your implementation based on that test in order to make the test pass. If you follow this rule, then surely you will have less bugs because you're writing in a test-driven way. You're writing to make sure that your tests pass. And if you're writing to make sure that your tests pass, meaning that your code is quality, like it's got quality, it's going to pass tests, right? So because tests are there to test us, they're there to make sure that we're following what we're expected to follow, right? So finally, how do all of these layers get connected? Right, remember that the block will depend on use cases, use cases depend on repositories, repositories will depend on data sources, and so on. Data sources will depend on external packages and external sources. So the question is, how did they get linked? Remember, the main purpose of this is to have a loosely coupled, we call it loose coupling, loosely coupled architecture, right? So in order to have these loosely coupled architecture, um, all these loosely coupled layers come together rather, we use something called dependency injection. And this is where we have the term in the principles of solid, right? We have 5 principles of solid, but then I'll talk about them later. But then this is where dependency inversion comes in, right? Where we invert all of our dependencies and we inject, basically, we inject the dependencies into each other the way they want them, right? And it also helps because we don't have to do instantiate classes more than once. We instantiate them one place, and whenever we need them in our application, we can easily get access to, right? If you are confused by what I'm saying heavily, if you don't think this course is for you, if it's too heavy, by the way, this course, I don't think it's beginner friendly. It's not beginner friendly. You should already have some grasp of how Flutter works, of how widgets and all of the basics, you should basically have the basics of Flutter down. This is the next step in your Flutter journey. If you already have the base down, then this course will be for you. If you don't already have it down, there's already a course that's beginner friendly on this channel. Link in the description below. I'll also put it up on the screen when I'm editing. So the link will be there for you. You can visit that course and follow that course in order to learn the basics of Flutter. By the time you're done with that and you're comfortable with Flutter basics, then you can come back here and learn how to write industry standard code. Alright, so now we're done with explaining the clean architecture. Let me tell you how clean architecture embodies the principles of. So the principles of solid are SOLID. S standing for single responsibility principle, the SRP, and for clean architecture embodies that in the use cases, right? It means that each class or module should have single responsibility. Actually, every module in our clean architecture will embody that principle, that S principle, the single responsibility, because they will only be focused on one thing at a time. This is actually why the clean architecture is notorious for having so much code. Like, in order to actually implement clean architecture for a single feature, you have to write a bunch of boilerplate code, right? So this is because it's actually following the principle S, single responsibility, where you don't have everything put into one place. You have to separate these concerns, right? So in the use cases, for example, we could, right, no, I'm not going to confuse you. I will show you what that does, how that works, or how that applies in the use cases and in other layers as we build the application. The next principle of solid is the open close principle, OCP, right? So it's where we're saying that basically each class or each module should be open for extension, but also closed from changing or modification, basically, right? So when we're abstracting and using interfaces and contracts, like I already told you, the repository is a contract, the entity is a contract. Use cases will also have their own contract, right? So when we have so many contracts and abstraction, right? If we wanted to add something new, for example, if we wanted to add a new data source, right, we don't have to modify our existing code or go back and change our repository or whatever, modifying it. No, we just add it and just pass it down. It just works by just like plugging it into plugging a charger into your phone. It just works that way. It works so easily. You don't have to modify anything else, right? So in the time when you're doing it, it might seem like a lot of work, and you might say, what is the use for this? Why am I doing this? It's too much work. I don't want to have to go for this trouble. But then later down the line, for example, if you're building a big application, like I already said, it would come in handy, because what if later down the line you have to change a feature somewhere, right? You don't have to go back and write lines and lines of code. You just have to create a new data source or a new repository, whatever you need to add, and just simply add it in. So on the long run, it comes in handy. Clean architecture is one of those things where it doesn't, it's like an investment basically. It doesn't, at the beginning, you're investing a lot. You're investing capital, your time, your energy, right? Your mental, it's mentally torturing, right? So your mental health, you're investing all of that. But then at the time, there's nothing, right? There's no clear use for it. You have to wait till the end of it before you can see any results, right? So we also have the principle L, the Liskov substitution principle, LSP, right? Simply, I think it states that, I don't remember, I wasn't paying attention in class, but basically, like, superclasses or something can be replaced with objects of their subclasses. You can Google the principles of solid, but then in our clean architecture, in the way that it embodies that is that we can create multiple implementations of the same data source, right? And they will all conform to one interface, right? We have different interfaces, and we can have different implementations of the same interface, right, doing their own thing, but at the end of the day, they are still the same object, right? We can pass them around as the same object, basically just dependency or something like that, right? And then the I is the interface segregation principle, right? It means that we basically don't force our clients to depend on the interfaces that they don't use. For example, if we have an interface that we have an already defined interface in our use case or in our domain layer, and we know that the repository doesn't need that interface, that repository does not have to use that interface. It doesn't have to use it. It can create its own interface and use it, and it would still work with other repositories in the same feature using a different interface, right? So everything is loosely coupled. Once again, I'm throwing that word around. It simply means everything is they're not tightly knit together. They're not connected, but then in some way they're still connected. So they're connected but loosely, right? So finally we have the D, the dependency inversion principle, DIP. All right. So this simply means that our high level modules can depend on the lower level modules, right? And both depend on abstraction at the end of the day, right? So when we use dependency injection right over here, when we inject our dependencies, we loosely couple them. So you can see this, they're joined together but not strongly. They're just loosely coupled. You can pluck this out and this entire thing will still work. You can pluck this one out and this entire thing will still work. You can pluck this out and this entire thing will still work. This is the principle of clean architecture. So you can see we have these three main layers, right? So we have these 1, 2, 3 at the core. If I remove this entire thing will fall apart. If I remove this entire thing will fall apart because these will go away, these will go away. If I remove this, this wouldn't really fall apart. So this is our data source, right? So we can't remove the domain and the presentation layers, but we can totally remove the data source and the entire application will still work. But then even at the ends of them, we can remove the extensions of them. For example, inside of the domain we have entities and so forth and so on. We can remove anything and the entire application can still work. So let's go in and see a simple demonstration of how clean architecture would work in an authentication situation. For example, this is a simple login demonstration. So this is our user. Our user wants to log in. Let's call her, I don't know, Amanda. So Amanda is really ready to log into the application. She's ready. So she clicks on that login button, just like I've done, right? So what happens is the UI will dispatch an event, right? So the UI will take in that click that she's done. Tiny Anne's going to click on that login button. She clicks on that, boom. It takes that interaction that she's done and it sends the signal to the business logic, the block basically. So it sends it to the block still inside a representation layer, right? And the block will, which remember that the block depends on the use cases, right? So the block, which depends on the use cases, will handle or call the use case function, the related use case to that functionality. So Amanda has clicked on login. In the block, we will have a function or a method that handles login functionality. And similarly, we will have a use case that handles the login functionality, right? So the block, right, will go into its function that handles the login functionality. In there, it will call the use case that handles the login functionality and pass in the required information to that use case, and then let the use case carry out its work. The use case, in this case, which is also carrying out its own sort of business logic, will take that request and send it over, hand it over to the next layer. So now we're exiting our layer, right? We're exiting the domain layer and the presentation layer, and we're moving into the data layer, basically. So depending on the contract of the repository that we've defined in the domain layer, the use case, the related use case, in this case the login use case, will simply take whatever data, hand it over to the data layer. That we're moving out from the domain layer and now we're in the data layer, right? It hands it over to the repository in the data layer. The repository will simply take it and make a call to the data source and say, hey, data source, right? They're trying to log in and they've given me these bits of information, right? And this is the contract that they define on how to talk to us, and they've done it correctly. So now let's move on from me, and hand it over to you. It hands it over to the data source. Data source plugs into the server, right? Look at our little data source sat on the server, plugging into the cloud, or wherever we need. It can plug into your local files or whatever we need, right? It will fetch that data from them, and then it will bring it back. So now we're done. The server, the data source has spoken to the server, right? And the server has said, Rav, I don't have your data, right? You're on your own. I don't know what you're talking about. So this is the response. It can be a successful response. It could be a bad response. It doesn't matter. The server responds either way. Or it could be silence because you don't have data. You've run out of Wi-Fi. I don't know what reason. But you can continue since we've received it. So the data source will take that data and start passing it back down to the layer. So you can see we have the repository. It's passed it down to the repository, right? The repository was also the last bit before we got to the data source. The repository passes it back to the use cases and so forth. So we'll get the information back to the user. So we hand it over to the use cases. Use cases hands it over to the block. And the block will simply take it and give it to the user. 504, 505 server error. Horror. ChatGPT is no longer working. What are we going to tell our boss? We're going to call in sick because ChatGPT can't help us write our code anymore because there's a 505 error, and this is how the clean architecture will work along the line. So, yeah, that's it. And we come back and do the same thing for every other functionality, right? So that's it. That's it, lads. Now let's go into building out the actual application. Boom. So, due to the nature of the application we're building today, we will be using Firebase and writing tests. Because of where I'm doing test-driven development, writing tests for Firebase for a project that uses a Firebase server is slightly different from writing tests for projects that use normal REST APIs, right? And I know most of you might be working with REST APIs. So in order to cover all of everything, right, I will first of all, before going to the main application, create a little application. We will create a little application using a fake HTTP server, a fake HTTP REST API, and then build a very short, just a one feature application around it. Alright, so basically with clean architecture, it's usually going to be too much work anyways if your application is very little. So if you've maybe got only one or two features, you don't plan on expanding the application later on, then clean architecture might be too much, it might be overkill for your application. But if your application is going to be industry standard, if it's going to production, if it's going to be a huge thing, right? It's not maybe just a little personal project that you're building, then yes, go ahead, use clean architecture. But for that reason, I'm going to create a little. For that reason, I'm going to create a little Flutter project. Next, TDD tutorial com.besttech. We're going to start off with an empty project. TDD tutorial, yes, create project offline, and then we create our project. The project started now. Let's go ahead. I'm going to go to mockAPI.io. You can visit that. MockAPI.io, or you could just follow along. The endpoints that they are going to create for me or should work for you as well. So I'm not going to take down the endpoint or shut down the server. But then preferably, I think you should just do the same thing with me. It should be, we just have to do a few steps. So go to mockapi.io, log in, right? Once you log in, you can log in with a Google account. It should bring you in here with project to the project. We can start by creating a new project. Right, so let's go ahead and add a new project. I'm going to call this TDD tutorial API prefix. Let's just go with test API, right? So by name, we can create our API. That's done. So let's go ahead and add a new resource. For this, we're going to add users. So we're just going to simulate a simple login, or no, a simple, let's see, creating a user and fetching the user. Should we do users? No, do something different. Yeah, let's just do users. Let's just create and fetch the users. So this is the schema. It has an ID, created that, name and avatar. Yeah. I think this is enough. And we can see over here, we can do a get request. So when we're requesting for a particular user, we can do users / the user's ID. And when we want to create a user, we can post / users. So these are the two endpoints we'll be using. We'll be creating a user and also be fetching our user and displaying our user. Or no, let's fetch all users and display all users on the screen or something. So let's go ahead and do that then. So let's go ahead and hit create. This should create it for us. So you can actually drag this to generate fake users. So if I drag this, it will generate fake users for me, but I don't want that yet. I want us to be able to create the users ourselves from our Flutter application. So let's go ahead and get started. So in our Flutter application, first things first is to create our layers, right? So inside of our lib folder, usually I personally create maybe a directory called src, right, source. You can call it, you can use features because basically the features will be in here. So our application, when you get an application, you have to split it into different features, right? So for example, we have the authentication feature, we could have the chat feature, we can have the hosts feature or something like that. We just break them down into different features. I spoke more on this in the video that I referenced at the beginning. The video link will be in the description. We'll also put up on the screen as well. So let's go ahead and create our features, right? Or you can create source, right? As almost every public project does. So inside the source, we start by creating our first layer, new directory. Let's create our first feature will be the authentication feature, right? Inside of the authentication feature, we're going to create a new Dart file. I'm just going to do this at once so I don't have to waste time creating all the layers. So remember that we always start from the domain layer, right? So this is what we're basically going to do. We're going to create a user and then fetch every user that we've created and display them in the UI. So on tap of a button, we can add a new user and so on and so forth. All right, so let's go ahead and add the domain layer. So in the domain layer, we will have our entities, right? In our entities, we will have the user data. So we have the user entity. So let's go ahead and see what our user has. So let's try and create a new resource. So you can see that a user has ID, created that, the name and the avatar. And these, I think these will come in the same format when we're fetching them. So ID, created that, name and avatar. Right, so we will have the class user. The class user will have I think the ID is an integer. So because I think they're using an SQL database, so yeah, it should be an integer. So integer ID, we have final string created at. I think it's a string because I mean it looks like, I know it's a string. So name. Let's go ahead and also add the final string name. And finally, final string avatar. Alright, so after that, let's create the constructor. In here, we will require this .id, required dot create that, required this dot. No. We can make this to be a date time object, but this is just this is just a simple setup. So let's just keep it as a string instead of changing it to a date time. Let's just keep it that way. And then we finally have name and avatar. Right, so this is it. So this is set. But now there's an issue, right? So usually for test-driven development, even without test-driven development, we will need to be able to know when a user or equate users or equate our objects, right? So in Dart, generally Dart uses referential equality, right? So which means that when you check if a user, so if in here, if in my void main I had final user 1 as a user and I created ID this that right, and the ID, let me change that to 1, and I can do the same for user 2, right? If in Dart I said I wanted to check for this and say, do you know what, let's go over to dartpad and do this so that we can dartpad.dev boom void main. In fact, let me copy this entire thingy. Right, so yes, so let me move this below. Format. Yeah, so if I went ahead and said print user 1 equal to user 2, because we know that this isn't equal, right? User 1 isn't the same as user 2, right? Because their IDs are different. I mean, everything else is the same. But let's go ahead and check that. You can see it says false. And what if we actually change something in here, right? So what if we changed user 1, right, and checked, we change user 2 to have the same data as user 1, and we hit run, we can see it's true, right? Now that's all great because it's detecting that these two are the same, right? But then what if, let's imagine, what if we had a different data type? So this actually works, the equation actually works for objects that have simple Dart data types. For example, these They have an integer and strings, so there's nothing else, there's nothing complex. But what if we get something like, I don't know, what if we get something like a date time, right? So required this dot created that. Let's make that date time, right? And we create the same time, right? Final now will be date time dot now, and we in here use now, right? We make that final, replace it with final, and now we hit run. So now we can see this failing because we have something that's not really equatable in the, it's not a simple Dart data type, right? So in this case, what Dart will do, let's go ahead and find the operator class. Yes, so over here we can see that how the equality method or the equality operator works in our Flutter project will be that by default all objects will return true if and only if that the first and the second objects are the same object. So basically, how computers store stuff, right, is when we create this variable, it takes this, goes to the computer's memory, and then goes to an address, maybe, I don't know, maybe some address like this, and it saves it in there. It saves that value, this user, in there, right? So this variable name, whenever we take this variable name, we're basically saying, so in turn, it actually stores the user's data. So it stores this, no, not that. It will store this in there, and then inside of this variable, it will store this address in there, the address's data in there. So whenever we do this, we're essentially giving Dart the address of this variable in the computer's memory. Alright, so that's, you can imagine it that way. So if that is the case, then whenever we do user1 equal to user2, we're basically checking if they are pointing to the same object in the memory. Alright, so in cases such as these where we have non-constant objects, it uses what we call referential equality, meaning that it checks if they're referring to the same object in the computer's memory. If they're not, it will return false, as you can see over here. In order to make it use something called value equality by checking its values, we can then override the equality operator in our Flutter class. I don't know if I'm making sense. So, like I said, this isn't going to be totally beginner friendly. You should already have some grasp of Flutter. Then this is what we're talking about, right? So these two objects, we have to be able to know if an object is the same based on their values, not based on their reference in the computer's memory. In order to do that, we can override the bool operator, right? It has the double equals and it takes the other, right? So what this essentially means is whenever we call an object, any version of this object, for example user1, and we add an double equal sign in front of it, and we put in another object on the right hand side of that equals operator. So in this case user1, right, and we put in these right here, and then the other will be user2, right? This should return true if they're identical. So Dart has the identical function. It checks whether two object references are to the same object, right? So you can read through the documentation, but we can see here Dart values what is stored in variables or object references, right? So I told you what is stored inside of these variables are these the references to the objects, right? So let's go ahead and read. They can be multiple references to the same object, so even one object. So there could be cases where if we did user1 is equal to user1, and it could return us 4. Wait, let me comment this out. and it could even still return as false because there's two different references to that same object. So there are cases like that. In this case, we don't have that here, right? So let me go ahead and change those out. Let's go back to reading what we were reading. So that could be the case. In this case, that's not the case because our case is pretty simple, right? So if an identical call returns true, it's guaranteed that there is no way to distinguish the two arguments. If it returns false, the arguments are not only known to not be the same object. Alright, so this is the default way that Dart does it, referential equality. So we are checking if the object on the left hand side is equal to the object on the right hand side, which is the other, right? If that is true, then return true, right? If that is not true, then we go ahead and check if the other is the same object, if they're the same type, right? So if the other is also a user, so we check if the other is user, all right? So this is the start of a different check. This is how value equality works, right? So this is referential equality, and then now we're moving on to, so we check if they're referentially equal, right? If they're not referentially equal, then we check, or are they value equal? So let's go ahead and start with value equality. So we check first of all if they're the same, if the other is the same as the same type as what we have, right? So if it's user and the other the runtime type is equal to this dot runtime type, right? So if their runtime type is the same and other dot, let's use the ID. So in this case, what we're essentially saying is, right, check, what is the problem? Unnecessary disidentifier. So that's unnecessary. Yes. So what we're essentially saying is check if they're referring to the same object in the memory. If they're not, then go ahead and check if the second thingy, right, this is a user, right, which it is a user in this case, and also make sure that its runtime type is the same as my runtime type, the runtime type of the left value of the left operand. And then finally we check if their IDs are the same. So what this simply means is if all of these pass, return true if they have the same ID. So whether they have different names and different dates, so far as the ID is true, then it's the same person. All right, so we will see how that works. So now this also requires us to override the hash code. So after overriding this, you must override the hash code. Right, so integer get hash code. You can go into the Flutter source code to see how they've done it. This is simply how they've done it, I think. So we can go ahead and say id.hashcode. Right, so I'm using id.hashcode format. Yes, I'm using id.hashcode because the ID is the only thing that I'm using for an equation over here. All right, so over here now we can actually change this thingy to, I don't know, Deborah. We can change this to Lee, right? And we can do run. And we can see it returns true, even though they've got different names. But so far as their IDs are the same, it will work. Right, so if we went ahead to also check if their names are the same, so we say don't only check if they're the same using their IDs, check if they're the same using their name as well. Right, so sorry. If name is equal to other.name, you could also make it if other.name is equal to name, whatever. I just prefer to have that convention is equal to my name, right? And then over here, I can also add, with this, we add the superscript symbol, and we can say name.hashcode is the same as mine, and we can go ahead and do that. We can see it will return false this time because their names are not the same. So in order for two objects to be equal, for two user objects to be equal, we're essentially telling Dart to check if their IDs are the same and if their names are the same. If any of these are not the same, then please return false. Alright, so we can go ahead and keep adding whatever properties. So usually for server data, servers cannot have two different datas. They're usually unique datas. Alright, so if you know anything about SQL, you know if they're unique. If you don't have any idea what I'm talking about, you can watch the other video. We used an SQL database in there, and I explained a little bit, I think a little bit of what it means. You can read up on SQL database, but basically these IDs are automatically generated by the database, and they cannot be repeated, alright, because they're unique, always unique, alright. So these can never be the same. So usually I'd use only the ID to check for my value equality. So even if their dates were different, right? Even if we created the first user, say now, final tomorrow will be date time dot. Do we have a tomorrow? I don't think we have tomorrow, so I'm just going to use now dot add. Sorry, dot add. I'm going to add a constant duration. Does duration have days? No, it doesn't. It has hours, right? Come on, mate. Don't tell me you don't have days. Because I know you do. Let's say 24 hours. Yes, so tomorrow is 24 hours. So, right, so let's go ahead and say run. We can see that they will still be the same user. Even though they were created differently, they have different names. But then since their IDs are the same, this will be true. If we change this to 2, it would change. Right, so in our tests in our application itself, we will be checking the equality of these things over and over. Now we don't have to worry about writing these over and over, right? Defining this stuff over and over now in each class, right? So in order to make it easier, we already have a Flutter package called Equatable. Let's go over to pop.dev and we can search for the Equatable package. We can see that package over here, 2,000 likes. So it basically carries out all of, you can see, right, exactly what we've done, right? It carries out all of that for us, right? It does all of that for us implicitly. So all we have to do is pass it the list. We have to pass it a list of every property that we want to use for our value equality. Alright, so if we wanted to use ID, we will pass only ID in here. We override this props and we pass it in there. If we wanted to use ID and name, we will also pass in the ID and the name in there. Alright, so let's go ahead and also do that in here. Let's start by adding Flutter pub add equatable and Flutter pub get. If you're on VS Code, the Flutter pub get will be run automatically after you add a package because it listens to your prospect YAML whenever there's a change. Alright, so let's go ahead and close this bit up. And in here, in order to use it, we can see in the documentation, you can go ahead and read this, but I'm just going to talk you through it. So in order to use that, we can make that class that we want to change to use value equation, I don't know, right? We can change that class and make it extend the Equatable. We can see it's screaming at us. It needs to overwrite something, the props. We can click on that to create it, remove the to do, and finally pass it the things we need to use for equation, in this case an ID. Alright, so we want, whenever the IDs are the same, we know it's the same person, no matter what name they carry or what avatar they carry. If their names are different and their avatars are different, so far as they have the same ID, it's the same person. Alright, so this is it for our entity. Right, we have our user entity. Let's go ahead and create the next module. The next module will simply be our repository. So remember, we have the entity, which hosts the blueprint of the data will pass around the layers of this particular feature. In this case, the authentication feature. After that, we create the repositories, so it could hold more than one repository, right? So in here, we can call that authentication. I dislike typing. Oh my days. Repository. Dislike typing them out. I normally just do auth repo, and that's it. But for just to be a good boy. Right, so repositories, authentication repository. Let's go ahead and create that. Now this is meant to be a contract, meant to be an interface. It should define how or what this layer, this feature, what functionalities it carries, right? But it doesn't actually implement them. It doesn't give a body to its function, right? So in that case, we will use an interface. In Java, we have interfaces. I think we also have interfaces in Kotlin. I'm not sure. But then in Flutter and Dart, I'm sure that we don't have the interfaces, but we have something similar. We have abstract classes, right? So we can create an abstract class. We can call that authentication repository, right? Boom. And then we can have the constant, oh my days, constant authentication repository. And in here, no, we don't take anything. We just make a constant. We make that a constant, and what do we want to do? So first of all, we want to create user using the post endpoint. And to create a user, I think we should pass in the user. What three things do we need? I think we need the username, the creator, that, the name, and the avatar. All right. So this will be automatically generated by the server. So we can use the creator that. So for that we can use required string. Is it string? It could be a date time, but let's make it string because we're basically using a string. Created at, we can do required string name, required string avatar. Alright, so this is what it looks like. Alright, so now we have to add the type. What type is it going to be? Right, it's going to be a future void, because after we create the user, we don't need any information from the server. We don't want to store its information, right? It will give us back the user, but we don't need it. Alright, we only need the users when we're fetching all users in our use case. Right, so and finally we also have future lists. We need a list of all users. So when we fetch the information from the server, we get all users from the server. We want to store that in the list and create users from it. Right. So we import the users. So list of users. Right. And we're gonna call that get users. So this is what we're expecting. So we're defining the contract. What are we gonna give to it? Nothing, because we can just query the server and say, give me all users that you've got. Right, so this is what we have. All right. Now, here comes the. I think it's a little difficult to wrap your head around, but let me walk you through it. So normally this is great and all right. So this is great, but then what if there's an error from the server? What if the server does not this function does not complete successfully, whether from the server or from Dart? Maybe you passed in something wrong here, and your Dart is screaming, "Oh, something wrong's happened." Right? What if the server does not actually complete successfully? How do we know? All right. So, in order to know, I really try not to confuse you, but in order to know, we can use two data types. All right. So recently, Dart has implemented records. Right. So we could have over here, I don't know, exception, and still have void. So Dart has made this possible. All right. So Dart has made this possible. We have records. If you go to the, I think, Dart 3.10 records were added to the Dart SDK. I don't know what particular Dart version it got added, but it was 3 point something, right? So we've added records so we could know. So now we need to know that this can either return a failure or void. It can complete a void. This one as well can either return us an exception or a list of users, right? So they have two return types. But this isn't the way we do it in clean architecture. Clean architecture, we need to use something from functional programming. It's not only in functional programming we use this, but we just need a type that returns two types. So I don't know if you get what I'm saying. So let's see what that means, right? So we could have, when we go over to the pop.dev, we can search for a package called dartz. There's other packages that also do this, but in our case, we're going to use dartz. So we need to be able to return both a failure. I think my internet is really slow today. We need to be able to return both an exception and the actual type that we need. All right. So in that case, we will use a package called dartz. Here we are. The dartz is opened up. So you can see it adds a bit of functional programming into your Dart project. All right. So this is dartz. Let's go ahead and copy this. Let's go over here and add the dartz package. Dart. Now Dart exposes a data type called either. You see, so it has a left and a right side. So it can have two types. So we basically have two types in one. Right, so we have a left side. In this case, the left side can return an exception. We can have a right side which can return void. So when we save this, we can simply say the result of this function dot left or the result of this function dot right. So if we check and the left is null, then we know, right, that the exception wasn't thrown. If we check and the right was null, then we know that there was an exception. So meaning that this side didn't complete, it was this side that completed. So either one of them must be returned, right? So when it returns the left side, we know there's an exception. When it returns the right side, we know there was success. All right, so let's go ahead and use that. So it will be future either. Over here we can have an exception, but then remember in clean architecture we have to separate our ideas. We have to separate the interfaces. So in this case, we will not directly be dealing with exceptions in the domain layer. All right, in the domain layer, we will be dealing with our own custom type called a failure. All right, so we will create a failure. So a failure will contain the message and the status code from the server. All right, but then an exception will live in the data layer because the exceptions are things that we get from the server from Dart. Remember, the data layer is there to interact directly with the external services. So these external services will throw exceptions at us, and we expect the data layer to catch those exceptions, convert them into a suitable failure for us, and then return them here. So for that reason, we're going to go into our lib, create a new file. We're going to call, right? And let's go into errors. Let's create an errors folder, and in there we'll create failure.dart. Right, so we will also start by creating an interface first. So this interface will be called failure. All right, and failure will extend Equatable. All right, because we want to know if a failure is the same as another failure. With exceptions, we can't really know if two exceptions are the same. Right, so when we're testing, we can't really know if two exceptions are the same. So there's no way to know. This is actually why we need to create a separate class for our exceptions so that we know how they work. Right, so let's go ahead and do this. So constant failure. It will have required this dot message and required this dot status code. Final string message. Final integer status code. Alright, so and then we can override I think it's a list of objects get props is equal to, we want a failure to be equal to another failure when the message and the status code are the same. So, and the status code are the same. Now, this is an interface, alright? So in order to actually create our own failure, what types of failure are we expecting? We can expect a server failure, a failure from the server, right? So remember that data sources, we can have different types of data sources. We can have data sources from servers, we can have data sources from APIs, we can have data sources from the local storage or from the local cache, from the user's device's cache. Maybe we're trying to get something from the user's device, right? And then that doesn't work, then we can get the information from, we can get an error from that cache. So we can call maybe that a cache exception. Sorry, a cache failure, right? And we can know, so whenever that happens, we know the problem came directly from a cache. In this case, we're using an API. I'm going to call that an API failure so that we know that it came from the API, and that will extend the failure, right? And in here, we can have a constant API failure, and it will required super.message. So it simply takes the same thing that the super class takes, super.status code. Remember, if you don't understand this, go take our simpler Dart course, simpler Flutter course. Courses, we have a lot of courses on this channel. You can go ahead and take any of them that are beginner friendly. This is for, I think, intermediate developers. So, but then I'm just going to explain, just in case, right? So, what's happening here is we're basically saying collect a message from this constructor when we call that, right? And then pass it to the superclass. So we basically have a failure at the end of the day. So if we call that failure dot message, this message, it will be passed from here. All right, so we have an API failure. All right, so over here we're expecting either a failure, type failure. So these things all are principles of solid. Instead of directly stating over here that we have an API failure, we state that we have a failure rather. So these are I think this falls under dependency inversion, I think. Don't really know all that stuff. So over here we either return a failure or void. Alright, so but then just remember, do not state the actual failure that you're expecting, because in this way, when we do this way, if the type of failure changes, we don't have to go into all of our repositories to change them. Alright, so this is why we call it loose coupling. So if eventually the type of failure that CreateUser expects changes, maybe if we rather want CreateUser to get a server failure and we have a server failure inside of our failure, maybe we create a server failure and stuff, and then we want this to rather use a server failure. Simply in our data source, when we're returning this, right, we will return a server failure instead, and this can actually still use this. Alright, it can actually still work. This class will work. We don't have to touch this class or change any of its existing functionalities. We only extend its functionalities and add whatever feature we want to add. I spoke about this in the previous session. Alright, so let's go ahead and do the same thing for you. So over here we have either a failure or a list of user. All right, so now in all of our repositories, so if we had a big application, each repository will use this format, and we will use this same format in our use cases inside of our data, inside of our repository implementations, and a lot more places. In order to avoid all of that repetition, we can simply extract this type because it's long. It's really long, so in order to get that to work, we will extract this into a separate new Dart file. In the call folder, we create utilities. Inside of utilities, we can have type definitions. So type devs are a way to create one short generic name for a type, right? So we can create a type dev by saying type def, and we write the name of the type. So in this case, we can use result future, right? And we can say that result future, whenever someone says result future, we want to know that they're talking about this, a future either failure, import. What is the matter? Import dartz. Right, so we want to have a future either failure. But then remember that this part is going to be different for each person. So this part is basically going to be the same. Alright, so this is why also another good strength of clean architecture. The clean architecture makes sure that there's harmony in your code base, right? So with that harmony, we can do stuff like this. Create one type definition, knowing that every single person who wants to use a future either will be sure to have a failure on the left side and then the actual successful return type on the right side. So in order to do that, to make that generic, we can add a generic type over here and call that T, and then we can pass that T over here. So whenever we call result future, just like either, we can open and close these angle brackets and put in the types. In this case, we only want one type, and that's going to be the type we pass here. If you want to also make this place generic, you can also maybe add another type and just add it here instead. But we're not going to do that, right? Let's go ahead and do this. All right, close that up, and let's see. Right, so over here we can just remove all of this, and we can say result future. It returns a failure or a list of users, right? And over here we can do the same thing. Result future. We can even make one for void, right? So for every function that returns void, let's go ahead into our type definitions. We can make one called typedef result void, and then we can just make it to be the result future void. All right, so its other type will be void. So it's basically the same as this, but with void in here. All right, so we can go in to our repository and rather use result void. Right, so that's that for this. Let's go ahead and move on to the next module. So we have our entities, and we're using our entity in here. You can see we're passing them around inside of this layer. So next we have our use case directory use cases. Now inside of the use cases, we will create a file, we will create a module for each functionality inside of the repository. Alright, so if we have the CreateUser functionality in here, meaning that we will have a use case for the CreateUser. Alright, if we had one for getUsers, we will also have a module for that one. Alright, so let's go ahead and do that. So CreateUser, we will call that class CreateUser, right? And this CreateUser will be CreateUser. And now this is where the fun part comes in. So how is this CreateUser going to work? The CreateUser will be depending on the repository. Will be depending on the repository. All right. In this case, we have our authentication repository. It will depend on it, and it will call the CreateUser from it. All right. So this facilitates the single responsibility principle. All right. So in this case, we're depending on this dot repository. All right. And in our repository, I'm making that a private because I don't want someone else to be able to access it, some other class to be able to access it. Remember, single responsibility. So this use case only has one responsibility. In this case, this person, this contract doesn't have one responsibility. It has more than one. It has CreateUsers, getUsers. But this isn't wrong because this is just a contract. All right. So this is actually where we bring in the actual single responsibility. So authentication repository, and we take that, and we can create the function again. I think the function we're doing is CreateUser. So it will be result void, right? The same as result void CreateUser. It will take all of these. So let's go ahead and paste that in here. So it will take all of that and it will simply async, and it will, because the other one's a future, all right? A result void is basically a future. You can see right here. So we can do that and say async. We can just call the repository.createUser, and we pass in everything into it. All right. So this is basically how the use cases should work. But now every use case, right? Every use case is going to follow this same pattern. All right. So again, we're going to do another abstraction by creating an interface. All right. So this is how all of your clean architecture project will be structured. All right. So every use case will simply carry this out and carry out the actual functionality that's related to it. All right, so what is it implementing, or what functionality is it implementing, or what is it going to call? CreateUser. So we will always override it. So let's create one interface in order to make sure that every single time we create a use case, that use case will follow the same pattern. So this is what the point is with clean architecture. We want to make sure that everything is going to be exactly how it's meant to be. We don't want to leave any room for mistakes from ourselves. So clean architecture is basically you saying, I don't trust myself as a developer. I know that I'm prone to mistakes because I'm human. So I'm going to create ways to stop myself from making mistakes. All right. So we create a repository, and we know that every time we want to call a CreateUser, we know that by force we must pass in these three things, and by force we must pass them in. And we know that by force we will always return a void function. So this is what we're doing. So in this case, we will do this repeatedly for different use cases. So in that case, we can go into our call, create a new Dart file, put it in UseCase, the UseCases folder, and we can create usecases.dart. All right. So now we could have two different types of use case, right? We can have a use case that has parameters, and we have use cases that don't have any params, right? So let's go to our repository. So we can see this use case has params, and this one doesn't. So if we go ahead and say we have a class, let's make an abstract class use case, all right? And we go ahead and do this, and we know that each time a use case will return a result future, and it will take some type T, right? The type, right? We don't know the type, so this is us creating an interface. The interfaces use generics, right? Generics meaning we don't hard code what they return, because a lot of different modules will be using them, so we don't know what those modules might want to return, right? So result future has a generic type T, right? And then it will have a function called call. So in Dart, the call function exists almost in every function. All right. So for whatever function you have in your Dart file, all right, you can say that function dot call, and there's this in there, right? So for example, let me show you what I mean. Let's go over to the Dart pad. Let's see that I had a function, right? A function, you know, let's say that I had a function void create user, right? And it does something. Over here, we can simply say create user dot call. You can see, so this will actually call this function. All right, so this is most useful in such cases where, for example, in your widget, if in your widget you're taking an unchanged property, you know these unchanged stuff are functions implicitly, right? So it's a void function, or it could be a string function, or whatever type of function. What if you don't give it an unpressed? Then the unpressed is nullable, right? So how do you know if unpressed is nullable? If you did this and you said if it's null invoke it, if it's not null, don't invoke it, then that wouldn't work with the question mark, because this isn't how Dart works. This isn't a correct syntax. In that case, what you would do is this. You say CreateUser.call. So if it's null, call this. If it's not null, call this. And you see that it tells us that the receiver can't be null because this is a nullable, right? So if we're passing it as a nullable value, then we can do this simply. So basically, all I'm trying to say is implicitly, every function has a callable, a callable call. I don't know what to call this. It has this little thingy. So now that we know that every function has the call functionality, this is what happens, right? The call functionality simply tells Dart that this is callable, that whatever object has it inside of it is callable, right? So also for our classes, imagine that we had a class, right? If inside of this class we had a class, let's see, callable class, right? And inside of this class we had a function, let's see, void print hello. And this function will simply, not async, sorry. It will simply print hello world. Right, so if inside of this callable class we said callable class dot print hello, right? This simply will print hello, right? Because of this would work. But if we went ahead and changed this function's name to call, then do you know what it means? It means that this object, this callable class, is now callable, right? So whenever I invoke this class this way, whenever you do this, right? Whenever you do this to an instance of this class, rather, yeah, that instance of that class will simply call the call method, the call function in there. So we can see if I save this, final callable class is equal to this, and when I do this callable class and I do this, this would work. This works. You see, there's no errors, right? An instance of a class is callable. We can run and we can see that this will actually print hello world. Alright, so even if it takes stuff like string message, I'm going to say this dot message. I'm just simply passing the best tag. And we can see that, right? So the instance is callable. So we want similar functionality for our use cases. Why? We want such functionality for our use cases because we don't want to have to say use this use case dot call, or sorry, this use case dot create user, or this use case dot do this or do that, right? So but conventionally we will use the callable object, right? So we make it a callable object by doing this, right? So also remember that some of our use cases need parameters and they need arguments or whatever in them, right? So how are we going to take care of such cases where some need it and some don't? We can create two different use case interfaces, right? So you can say use case with params, right? And we can take the type in the constructor, in the declaration, and the params in here as well. So this will be the type, and this will be the params. So let's go ahead and make that type, right? And then the params will be params. So the type is a params type, right? So it will be of this type params. The return type will be of type. The parameter type will also be of type params, which is just a generic type we've defined, right? So we can call that params as well. So we have this, right? So we have a use case that has parameters and it returns the type. We can also have another version, use case without params. We have only a type in this case, and we can have So my days result future type. We can call. It doesn't have any params, right? So we can also make these constant. I just love making everything constant. All right, so we can make these constant as well. Use case with params rather. Yes, we can make these constant. We can copy that, paste that in here. No, sorry, without params. Let's format the file and we can come back here, and inside of each use case we can append use case. In this case we have params, so with params, right? So in here we can override. When we copy this, then now we have to override that functionality. So this way all of our use cases will follow this same pattern, right? So it has a result feature, and we have to pass in the type and the param type. Alright, so the return type in this case will be void, and the params type will be, we have so many params in this case. If we had only one param, then maybe a string, and we can just simply put string in here. But since we have a lot, we can create a custom type for our parameters. Alright, so this is how it works in clean architecture. I know this is a lot of boilerplate code, but please sit through it. It will benefit you on the long run. So when we have more than one, what we usually do is we create a custom type for it. Alright, so we can come down here and create a class. Right, we can call that CreateUserParams. And we also want to use Equatable. Right? Boom. And we can simply say void CreateUserParams. And that's a type for this one. Right, so we can have here CreateUserParams, and we can just simply async, do an arrow function, and simply do the params dot created at. Alright, let me not confuse you. Let me not rush through this. Alright, so in our CreateUserParams, we know we need 3 params. Right, so we need 3 of them. And what are they? Created at, name, and avatar. So we go ahead in here, we create final string created at final string name, final string avatar, and then we can create a constructor. Let me go ahead and generate a constructor. Stop it, generate named argument constructor. If you're wondering how I got that, that's from a plugin. I think that's from a plugin. Let me see. It's from either from you. Yes, named argument constructor. It's from this person, from Andreas Ferenc. I hope I'm not butchering that, mate. Probably am. It's from that person. Don't want to ruin his name, so I'm going to keep quiet. Let's move this below, following linting rules. So, since we're subclassing Equatable, we have to create that missing override, and over here it will be the same params if we have created at name and avatar. Alright, so created at will be the params dot created at, the params dot name, finally params dot avatar. So this is essentially what we've done so far, right? We started out by checking what is our server going to return to us, right? The server is going to return to us the user data after we authenticate this user. So this is one of the things we need, the user's data. So in order to collect that user data into Dart, a Dart object, we need to create a blueprint for that object. Right, and the blueprint is this. What does a user data include? A user's data will include their ID, when they were created, and the name of the user. Finally, the user's avatar. Alright, so after that, we move on to the repositories. We define how we want to communicate with our data layer later down the line. We're saying whenever we want to do anything, right? Whenever we want to implement any functionality, we must follow these rules. We must have a CreateUser, right? We must create a user. We need to create a user essentially. And when we're creating a user, it must return void. It must take 3 parameters being created at name and avatar, right? And when also we're doing that, the same thing for get users, it must return a list of users. And if it fails, it must return a failure, right? So it's essentially saying this could either return a failure or a void. It could either return future or a list of users, right? So when it fails, when there's a failure, when the result from this is a left result, we will understand that later down the line, then we know there was a failure. If it doesn't return a left and it returns a right, then it was successful. Then we collect the data from that successfulness and we do that, right? So clean architecture is basically forcing you to be a good developer. It forces you to be a good programmer, forces you to handle cases, right? Cases where this has happened and that has happened. It also makes it possible to test these things. So the way these things are, testing them will be pretty easy, super easy basically. After that, we want to go on and create a use case for this person as well. Use case with parameters. No, without parameters. So without params. And we only give it a type, and its type will be a list of users. Alright. So we go ahead and create a constructor for this. Users will be this dot repository. And we can say final authentication repository. We can override the result future. I think for our CreateUser we didn't even specify the type for this, so it has to be a result void rather, a result future. So over here we've got a result future that uses a list type. So not a list type, a list of user. How this forces us will be like second call no params. We simply say async call the repository dot get users. Right, so how this would force us to use to be basically consistent with ourselves is that when I actually change this out to maybe return a string, just scream at me, right? It will scream because this is in the same. So you can see get users call isn't a valid override of use case params parameters call, because this one is looking for either failure list of users as I specified at the top. So when I put a different type here, we know that that's wrong. So you can change that back to users and have that there. So this one is a lot simpler than the previous one. Alright, so now in the sense of test-driven development, you would usually write the test for this before you actually write the implementation for it. But I only wrote the implementation for it first because I'm teaching, right? So for tutorial purposes, I'm writing this first, but usually you'd write the test first and say that the test should make sure that these get called before writing the actual implementation. Now, in order to write the actual test, in order to test for the use case, remember, in here, this is a contract, right? It's an interface. We don't test them. The entities is a blueprint as well, so we don't need to test this. The places that have actual implementations in the domain layer would be the use cases, right? So we have to write tests for each use case, right? So we can go in here and create a test folder, test, right? Inside of the tests, we can create a new Dart file. Now we have to follow the same path for this. Why? So that we can easily find our tests. So if we're testing for CreateUser, we can go ahead and copy its path. Let me find that use case CreateUser. We can copy its path. Let's copy from the lib source. We can remove the lib as well. So Dart file. We can paste what we've copied. CreateUser test. Right. So if our class was if our module was CreateUser, we simply add underscore test at the end of it. Right. So that's how it goes. That is the convention. We want to start from the source, not from the lib. So we go and create that, right? So we have our file, right? So there's an easier way to do this, right? You can install a package known as Dart test. Let me see plugins. We can see Dart test, this one. All right. So you can simply just right click on your file and then say create new test file or something like that. Create a new Dart test file with the same path in mind. So let's go ahead and test that. I'm going to delete the source and then go ahead and say, no, I have to do that here. New test file. And we can say create user and it will follow the same path and create this for us. So let's go ahead and delete this. So now you have to understand why we're testing and what exactly we're doing in this so-called test. Alright, so why are we testing? Oh my days, I'm so sorry guys, I forgot about this. Font is small. Then make that 16. I think that's overkill, but whatever. Right, so what are we testing and why? Right, so in this case we're testing this use case, right? This is so big. Alright, so the reason why we actually want to test this is because we want to make sure that this functionality will function the way we want it to. It will carry out the assignment that we're giving to it as expected. Alright. So each test should focus. So the reason why we call these unit tests, so currently what we're doing is called the unit test, is because it focuses on a small section of your code, a small piece of it, right? A unit. So for example, this class is a unit. So when I say unit, I'm referring to the class that contains whatever functionality we're testing. Alright, so inside of this class we have functionalities. These functionalities are the methods, the functions, alright? So we're going to be testing the functions inside of a unit. Alright, so inside of this class we have several. If we had even more than one function, we'd have to write tests each of the functions to make sure that each function carries out the whatever we ask it to carry out. We can test if it returns what we want it to return. We can test if it accepts what we want it to accept. We can test the process that it takes in order to do that. Alright, so this will prevent any bugs. Alright, it will basically catch almost every bug, right? The only bugs you might encounter might be widget tests, widget bugs, Flutter UI bugs if you don't write unit tests, if you don't write widget tests, that is rather. So basically, the unit tests will be like a safety net for us, right, and for our code basically. So telling it this is how I want you to function. If it's not going to function like that in every case, please throw an error for me now that I'm running a test. Right, so let's go ahead and do that. So inside of our CreateUser test, what is the first thing we have to know? So first things first, when you're testing a unit, when I say unit, I mean a class. When you're testing a class, we have to first of all ask 3 questions. The first question is, what does the class depend on? When you ask this question, we're basically saying, what does this class take in its constructors? Right, so if we're going to test this class, then we're basically going to be initializing this class. So class, we initialize class name. we initialize that class. But if it takes anything in the constructor, it depends on that thingy, right? It means that that class depends on that thing. And then the next question we have to ask is how can we create a fake version of the dependency? So basically, for example, if our class is depending on an HTTP library, right? We don't want to use the real HTTP library. Why? The reason for this is because we want that dependency. We want to be able to control that dependency, right? So for example, let me give you an example. For example, with HTTP, we can do HTTP.get request. We can send a get request, right? When we send that get request, right? What happens? This will go talk to the server. Server gives it back a response. It saves that response and it brings it back to us. And now we're writing a test. We want to make sure that whenever we call the HTTP library, that it returns something to us. Right? But in order to know and make sure that it returns something to us, we have to call HTTP get in our test. But this is a test, right? So if we go ahead and use the raw HTTP library, that will actually want to make a true call to a server somewhere and then return you its response. Now we don't have control over that. We can't stop it. But when we create a fake version of the HTTP library, then we can then have control over what it returns, right? And we can also control who it talks to. We want to make sure that it doesn't talk to any server, that it's only talking to us, right? Because we don't want to involve any real world dependencies. We don't want to invoke any real world, any real external services in our cases. We don't want to do anything with the real implementations of these things because then we don't have control over them. And that's where the final question comes in. How do we control what our dependencies do? How do we control everything that it does? This is where another package comes in. And this package, we have actually two packages that can handle this. We have mocktail and we have a mocktail. I prefer to use mocktail because it doesn't have as much boilerplate as mocktail, right? Mocktail, you have to actually define a template and some long stuff. You can look into that later on, but I used to use mocktail before I switched over to mocktail because it was easier. I mean, clean architecture's got so much boilerplate already. I don't want to have to add my own more boilerplate to my code before it works. So this is what the three questions we have to answer, right? So now let's go ahead and see what does the class depend on. The class depends on the authentication repository, right? So let's go ahead and create. So now we know what does the class depend on. Answer authentication repository. How can we create a fake version of this authentication repository? Answer use mocktail. Boom. So now let's go ahead and install mocktail. But when we're installing it, we want to install it as a developer dependency. Alright, not an actual dependency because we're only going to be using it in, for example, our tests and so forth. We're not going to be using it in the actual, you know what. So let's go ahead and do that. Flutter pub add dev dependency. You can type out --dev, or you can just do 1d and that's it, and you can say mocktail. So you can see mocktail has been added. So mocktail, you can go online and read its documentation, but essentially what it does is it creates a fake version of this. It hijacks all of its methods and then it lets us control them. Right? It exposes APIs to us that lets us control them. Right? So let's go ahead and do that. This is where we answered this question. How do we control them? Right? Using the mocktails APIs. So let's start with our test, right? So now we know what our class depends on, right? The second thing is how can we create a fake version of the dependency? We use mocktail, right? So let's go ahead and do that. In order to do that, we start by creating a fake version of the class. So we can call that fake auth repository, fake auth repo, but more conventionally we say mock instead of fake, right? So mock auth repo. I'm gonna just write auth repo because I don't want to type out that long stuff, but you can do that for, I don't know, better practice. Good practices, best practices, or whatever. Always type out your class names in full. I think everyone would understand what auth repo is. Just for a test. Class mock auth repo extends, so this will extend mock, right? Mock is from the mocktail package. This is basically saying this class will be a mock version of what? It will implement, what is it a mock version of? The authentication repository. Alright, so this is what our class is mocking. So this class is going to be a mock version of this authentication repository. Right, so now we've mocked it. We've created a fake version of the dependency, which is the authentication repository. Right. Next thing we want to do is void main start. So the entry point for all of your tests will be the void main. When you hit this, then your test will run. Right, but we don't have any tests yet, so I think that's not gonna work. So see, yeah, that's taking too much time really. There's no test. I'm just gonna stop that. Yeah, no tests were found. Great. So now we start, right? How do we control what our dependencies do? Right, so we will answer that question later when we need to control what our dependencies do. So let's first of all start by writing our test. In order to write a test, you can use the test from the Flutter test package, which is also automatically added in every Flutter project by Flutter themselves. So you can run test, right? And it needs a description. So the convention for the descriptions are usually this test should, or this unit should, it should do what? It should in our case we want that it should, and what are we testing? We're testing CreateUser. So it should call the let's see, repository dot CreateUser method. Right, I'm putting this in square brackets, it's just something I like to do when I'm talking about class, right? So because I'm talking about the auth repository, we can say auth repository, auth repo. I don't want this to be too long, so auth repo.createuser. We want to make sure that it always calls the auth repo dot createuser, right? And we can add an async because we have to await a function, a future function, right? So now we want to make sure that it should always call the authentication repository.createUser. How do we do that? Right, so when we're testing, we follow 3 simple steps. We have the arrange, that is the first step. We act, and finally we assert. No, stop. So we arrange, we act, and then we assert, right? So what does arrangement mean, right? So it's AAA, right? So arrangement means that we're putting together everything we need for our function to work, right? So what function are we testing? In this case, we're going to be testing the use case. So we're testing the CreateUser use case. So we want that use case, and we want to call .call. So each use case has .call inside of it, but because it's a call, we can just invoke it directly, right? So we just want, whenever we're calling that, does it need any information from us? Yes, it does. What does it need from us? It needs a CreateUserParams, right? So we can go ahead and add a CreateUserParams and instantiate it and whatever, right? But then where's our use case, right? So first of all, we need to get code of our use case. So let's go ahead and save that here. So we start with late create user is our use case, right? And we can, now it's late, right? Late means we're promising darts that before we use it over here, we must have instantiated it. How do we instantiate stuff in tests, right? We can't just do use case is equal to something, right? Because if we do that, then we only have one instance of the use case living throughout this. So if we actually used that use case in here, right, and then maybe change its value somewhere along the line, then the subsequent tests, the tests that follow, will also be using that same modified instance of the use case. But we want a case where for each test, if we had 3 tests in here, for each of them, we want a new use case to be created. So we can do that in something called a setup. Right, the setup is also from the Flutter tests library, Flutter test package rather. So in the setup, it simply means do this every time that we start a new test. You can read it here. So it registers a function to be run before each test is run. Right. So if we had three tests here, and then in the first test we actually changed something. Maybe we arranged by saying that the use case dot whatever, maybe the use case dot, if it had a name, is equal to something else. Then when we do that, when we get into the next test, it will instantiate a new use case for us. All right, instantiates a new one, so that way we don't have to blare out or whatever. Right, so we also have the setup all. Right, so this will do this once for everyone. Right, so this is it. Registers a function to be run once before all tests. So this will actually run once before anything else is done, right? And it will not be run again and again after each test, right? So after this test completes, it will still be the same use case instance that goes on to the next test. So in the spirit of all that, let's go ahead and continue with setup. We can make our use case to be equal to CreateUser. We instantiate a new use case. Now, what's the problem? The use case wants a repository, right? So we've already mocked our repository. So why don't we go ahead and also create a repository? So the reason why I'm creating this repository separately and not just creating it in here is because when we're arranging, we're actually going to be using it, right? So late authentication repository repo or repository. Let me just follow those syntax, and then we can say repository is equal to the mock auth repo. We don't want to use the real instance of it. We want to use the mock version, and we can say that that will be our repository. Right. So now we get onto arrangement. Right. So if we had a function, right, we're trying to say call our function, right? Our function is the use case, right? When we call the use case, so when we call this, it will be an act. So we're acting on something, we're carrying out an action, which is invoking the use case. It needs some params, right? So what params does it need? It needs the CreateUserParams. So we can go ahead and create a CreateUserParams, and we can give creator that name and avatar, right? I'm going to go ahead and make that a constant, right? But then this shouldn't be here. This should be in the arrange. So we arrange everything we need before we act, right? So we can say final params is equal to this. So this is what arrangements do. So we arrange whatever we need and we put it in here, right? Params. We can save that in there, right? But then in clean architecture test. So this is how normal testing a normal function would work, right? We arrange everything in there. But in clean architecture tests, remember the third question. We want to control what our dependencies do. We don't just want to act and give it these params. We actually want to control what it returns, right? Now, how does this use case return something? The use case does not just carry out its own function and return something. The use case actually depends on the repository. It calls the repository's function, and then it returns whatever the repository's function does. Now, what who does the repository talk to? The repository does not talk to anyone. Right, so meaning that the last person in our chain of command is the repository. So the repository is the main dependency. Right, so we can then arrange what that repository will return. Right, so let me go over that again. We want to control or arrange what maybe the parameters that we use over here, or what this use case will return. This is what we want to control. We want to control what it returns at the end of the day. In order to control what it returns, we don't control this person, because this person isn't actually doing anything. Right? This person is actually listening to a higher up, someone up in the food chain, and then they're getting their command from them. So if we want to change something, we actually go to the higher up. We go up there to the presidential level and we talk to them. We say, listen, whenever this happens, you do this. So the use case is listening to the presidential. If we get to change the presidential, sorry, I'm getting into politics. I'm no politician. But then if we get to change or control the president, then we essentially are controlling the constituents, basically. We are in control of everything, right? So now that's what we're going to do. We're going to be evil cabals and control the president. Who's the president? The president is a repository. So we will say, sorry for not telling you about this, we will say when, right? So we're trying to, so it's basically like simple English, right? But the when is from the mocktail library, mocktail package, right? So we can say when what? When a function, so this is simply saying when we invoke, or when a higher order function calls, when someone calls what? When someone calls the repository, when someone calls the president, when the use case calls the president and says president, create user, right? But for what? Create user. Now we have to put in the arguments that it wants, right? So now that's the problem. How do we create these arguments, right? In mocking, when we have a class that we're mocking, right, in the when block, when you're creating these, you can use a keyword called any, right? And you can invoke that. Any simply means find a null value and use it for this, or sorry, find a generic value and use it for this. So first of all, checks the type. So the type for created that is a string. If it's a dartz data type, so for example, string, integer, and the rest of them, it will create a default value. So if a string, it might create a generic string called created at. It might just do this and put it in here, replace it in here. You can read the documentation for an argument matcher that matches any argument passed in. So it will simply just create and find out the type for it, and then create a string that will match that. All right. We're also going to do the same thing here, and we're also going to do the same thing here. Now, if for any reason one of your my day, yes, let me try do this. No. So if for any reason any of these was not a generic Dart data type, so for example, let's say we had a date time object over here, then when we created that was actually a date time object, right? What would we do? Since I told you that any only works when it's a date time object, right? So in that case, we would have, any only works when it's a generic Dart object. So in that case, if we wanted our own or a different Dart object, right? So maybe this was some object that we've created. So maybe we've created something like class football, and one of these properties had football as its class, right? How does it know to create a fake football for this, or a generic football for this? It doesn't, right? It only takes into account Dart types. So in that case, we would actually have to go here and register. So we use register fallback value, also from the mocktail package, register a fallback value, and we create a fake version of that generic type, so that when we call any over here, then it will simply check if you've registered any fake values for it, and then it will use that. If you don't, then it will throw an error. after that's done, now we have to come down here and correct this, right? So using any would work if this was a positional parameter, right? If it was a positional parameter, then it would work with any, right? But we don't have a positional parameter. We have a named. We have a named one. So we have a named param that we need to pass. Now, when we're doing that, we have to come inside of the any when it's named and say named, right? And we put in the name of the param. In this case, name. In this case, avatar. This is how it works. This is just convention. You don't have to beat yourself up over it. If you don't remember it, come back and look the format for it again. So now we're saying that whenever someone contacts the president, says, listen, sir, I need it to create a user for me, right? What should the president tell them? Now, Mr. President, we want to hijack your response and we want to say .then. Now we have three versions. We have then throw, we have then answer, and we have a then return. The then throw will come in handy when we're trying to force the dependency to throw an error, because we want to test what happens when an error occurs, right? But this isn't the case. We want to test what happens when it's successful, basically, right? So when it throws, when it's successful, right, then answer, right, it should then answer or then return. Then return works when this function is not async, right? So because of this function is actually an asynchronous function, we can see it's a future function, right? We need to use then. We need to use then answer, right? So then return would be for a function that is not. We're not expecting or we don't want to wait for it, right? If you want to wait for the thing to complete, like a future, and then we simply say then answer, right? We use then answer, so answer after. So store a function which is called when this method stub is called, right? So it hijacks this method, so whenever it's called, this answer will be given, right? So now what type of answer is CreateUser given? CreateUser is given a void, right? So how do we mimic void? So we need to put this. So this takes an invocation. This is some high level stuff. We're not going to be needing it, so we're just going to put in that. And then we'll return something. So we can return void. But then now you have to remember async. We're going to put async before this. So now we have to remember though, right? Oh, is the problem? It's your problem. Done. Hooked what identifier? Let's see. Yeah, so you can see that the return type null, so it's actually returning void, right? So the return type null is not a future either value. So this doesn't just want one value, right? So we're expecting an either right or left value. So in our case, because we want to mimic success, right, we will rather use the right, because the right, mostly conventionally, we put the success on the right and the failure on the left. So when it's the right hand side, so we want to return a right hand side answer. The right hand side is from the dartz package, right? So right hand is a subclass of the either. So an either can either return a left or a right. So when it's a left, we know it's a failure. When it's a right, in our case, it's a failure. When it's a right, we know it's successful, because in our case, we've put failure on the left and success on the right. So when this gets called, we want the president to say, you're right, you have success. And what type of success is the right expecting? It's expecting a void. But we can't put void in here. So whenever you have a void function, inside of your right, you put null, right? Because it's void. So we can't just put void in there. So we put constant right null. So whenever someone calls CreateUser on your repository, we want you to give them back a right answer. All right, so now that's us setting up hijacking. This is called stubbing. So for our arrangement, we stub. We're hijacking the president's response to whenever this function gets called, this particular function gets called. So now we act, right? So we can say that our use case, we invoke it and we have to act, right? We have to pass it the params. Now we have to create the params. We have to come here, final. No, let me create that right here. Final params is equal to CreateUserParams. Now we have to do this over and over if we have multiple stuff. So in order to just make this simpler, for every class, what I personally do is, for every class that I create, I add an empty constructor. So constant CreateUserParams dot empty. All right, and what does this do? This will return this class, right? You can just do this. You can change it to a factory constructor and do this, and it returns CreateUserParams, and then you pass in the default values. But I prefer to do it this way. So I will return this, and this will have created that, and I will pass that I don't know, empty string. The name will also be an empty string, and the avatar empty string. You can name it anything, you can do anything you want with them. You can just put them and just leave them empty, or you can use their names, empty.created whatever you want to do, but it's up to you. But I'm just creating these because I don't want to have to always invoke create new versions of CreateUserParams each time I'm writing a test for whatever uses it. So I'm also going to do the same thing for my user. So where's my user? So I'm going to go into entities. For my user, I'm actually going to create a constant user.empty. This I'm going to do ID will be 1. Created at will be empty.created at. I'm going to do the same for name. Right, so let's go back here. And here, so my params will simply be CreateUserParams.empty. Right, so that will create a user params for me. I don't have to always instantiate it with empty values anymore. So we can just simply take those params and we can pass them here, right? So now that we've acted, we've carried out this. We have to wait for it because it's a future, right? We wait for this to complete, and then we assert. What are we asserting? We're asserting to make sure that this got called, that that when this got called, that it returns the right data, and also we actually want to test that it actually even called the auth repositories CreateUser method, right? So how do we do that? Let's start by making sure that it returns the right data, right? So what data are we expecting? We're expecting a right null, right? A right void function. So let's go ahead. A right the void result rather. So let's go ahead and save it in a variable called result. Right, so what do you return? You return a future either, whatever. Right, so and then to assert that the values, so if you want to assert values and make sure that they're the same, assert two values or equate two values in the test, you use the expect function from the Flutter test package, and now it's asking for the actual thing we want to test. We want to equate something again, so we're expecting that the result. So this is basically like simple English, right? When the president gets called, So when that happens, the president responds to this for reasons best known to him. And then we go ahead and test the president. We say, I've told you, you must answer this way if he calls you. And then we go ahead and make the use case call the president. We say, hey, use case, why don't you call the president and see what he says? So we go ahead and call this, invoke it. It gets invoked. And now we're checking. We're going through the president's call history to listen in on his conversation with this person. And we're saying, all right, now we've got the result of the call that you made with him, Mr. President. Better hope that you told him what we told you to tell him, right? So what do we expect that the president told him? We expect that the president told him something, so we expect that the result equals. So you can totally do this without equals, but I prefer to wrap in equals, right? It makes sure that it's equal to this. If you leave the equals out, it actually does the same thing. But I don't know. I just like doing that. So we're expecting that the result, or whatever the president told you, is equal to a right null. Because this was what we told the president to tell you, right? So usually this is great, but personally, for best coding practices, I prefer to state the data type. So what is it? It's a right. It has a left and a right. So what were we expecting on the left? We're expecting a failure. So right failure, and on the right we're expecting void, right? But then remember that this is fail. I don't want to have to import it each time. So what I usually do, if I'm using the right type, on the left I put dynamic. If I was using the left rather, right, on the left I will put the actual value, and on the right I put dynamic. This is what I do, right? So that way it's easier for me without having to import what I don't need, because I don't need this in this place. So I don't have to import that. And then so this is what we're doing. We're expecting that Mr. President said what we told him to say, being a right null, right? Forget about this long stuff. What it's just, I don't know. I just like doing that. And then we verify, right? Now this is where we're verifying that this little guy actually called the president. We should make sure that this person called. So now we've got the call log, right? So what if this passes and it tells us yes, the president actually told them a right null, mate. Right? Then how do we know that that call even actually went through? How do we know that the use case made the call that we asked him to make? Right? What if this person is lying to us? What if the histories were fake? What if the history was doctored, basically? Right? So we would have verified that that call actually went through. So we have to use the verify function. So similarly, the same way we do this, we want to verify that the repository .CreateUser got called, and it got called with these same values. We want to make sure that the use case told the repository, told the president exactly what we asked it to tell the president, right? So what did we ask it to tell the president? We gave it params. These params are right here, right? So we want to make sure that when the president asked for a created@, it told the president params.created@. When the president asked for a name, it told him params.name. When the president asked for an avatar, it said params.avatar. So we want to make sure that this call went through. And we also, you can actually leave this way, but for scrutiny, but personally, this is what I do. I prefer to say .called once. We want to make sure that you didn't call the president a second time and tell the president a lie, or tell the president, look, he's threatening me, please answer this way, so that it goes into the call history. Right? We want to make sure that exactly the call went through exactly once. You call the president only once, because we want you to only call the president once. We don't want the call to be repeated. So when we come here, we don't want a case where this thing gets called twice, because we want it to get called once. Each time that person gets called once, because we're actually calling it once over here, right? So now for that, after that's done, there's one last verification we have to do. We have to verify no more interactions with the president. after that call went through once, we have to make sure that he didn't send any letters, he didn't do any hand signals to the president to say, sir, he's threatening me, or whatever, right? We want to make sure that there was no more interactions with the president. The president was not interacted with, right? So this is our test. We're saying that whenever the president gets called, we're arranging an answer for the person that calls the president. We're saying, Mr. President, you have to tell them this. When they give you any value for your creator, that when they give you any value for your name and any value at all that they give, so it doesn't matter what they give to you for creating that name and avatar, always answer this way, no matter what they give to you. So even if a different use case calls the same function and gives different values for this than we gave in here, right? Always answer with the same answer. Say, right, no, mate. Right, so we then go to the use case and we say, you, listen, call the president right now and only call him once and tell him this. Tell him empty. Tell the president that creator.dat is empty.creator.dat. Tell him that name is empty.name. Tell him that empty. Your avatar is the avatar. And finally, we check if the answer that the president gave was correct. Then we check to make sure that he called the president, and we check to make sure that he did that only once. And for extra security, we want to make sure that he never interacted with the president after that, right? So let's go ahead and run the test and see if the test passes. So this is our first test, and let's see what happens. Hopefully it passes. Fingers crossed. So we can see the tests have passed. So we have one passed test, right? If we go ahead and where is it in our CreateUser? If we go ahead and do something differently here, right? So if inside of this place, where is it? If inside of it, oh my days, stop. If in here, instead of giving the creator.dat we were passed in the params, we decided to give it a different creator.dat, maybe something different, then the test will fail, right? So let's see what happens. The test is going to fail woefully. Do you see that? So no matching calls matches exactly what we wanted because they went and called something different. Oh, creator.dat, you really did that. Now you're in trouble, mate. So now we know exactly what he did wrong. We know that he's not doing the right thing that we want him to do, right? He's a bad person, so he doesn't listen. So let's go ahead and correct him. So you must use creator.dat, and now it works, right? So whatever we do wrong here, the tests will fail. So that way, there's no bugs in our end application if all our tests are passing. So let's go ahead and do the same for getUser. Was a get users rather. So let's go ahead and create a new Dart file. No, should I do it that way? New Dart file. Dart test file. Get users. Now we have to do the same process again. Let's go copy our code from before. We're not basically copying, we're just peeking. Oh, also, yeah. There's this. When you write a test for a class and you right click inside of that class and go to, if you want to find the test for a particular class easily, you can do this, go to and go to test. It will take you to the test of that file, right? It simply finds that file at that particular path with an underscore test in it. Alright, so you can also see the icons are different because they're in the test directory. So now also, let's go to your tests, go to tests. We can see the process that we've done, right? First of all, what does the class depend on? Auth repository. How can we create a fake version of it? We use mocktail. How do we control it? Use the mocktail's APIs. In this case, we control it using the when API, right? So now that we know how that works, let's go ahead and do the same thing for getUser. Now getUser also depends on the same repository, so we could either copy this, right, or we could simply copy this and paste it in there. But then if we had 10 use cases, then we'd have to copy and paste this repeatedly. So in order to prevent all of that, I usually do one thing, right? I come here and I say new Dart file inside of the test, and I use the name of the repository. So authentication repository.mock.dart. So you can see it has a different icon. You can see it over there. It has a different icon. By the way, I'm using the material 3 icons. Let me show that to you. It's atom rather. So it's the atom icons. This is what I'm using. So that's why I've got these beautiful things in here. So I could just paste that in here, import mocktail, and import the authentication repository. And in each file, we can just simply import that authentication stuff. So in here, we can go ahead and say that the void main, right? Remember what we did. First of all, we need the repository. So authentication repository, repo repository, and we also need the use case. In this case, we need to get users use case, and we do the setup. We need setup async. No, we don't need async. Give me father. So we come in here. We say repository will be equal to, we're instantiating the repository first because the use case depends on it. So the use case would take that in its constructor. So before we create the use case, we create the repository. But let's go ahead and do that mock auth repo. This is what I mean. So when we do the use case, will be equal to get users. It will ask for a repository. If we hadn't already instantiated it over here, it will throw an error. Let's see. If I go ahead and pass it that repository, you can see it says the late local variable is definitely unassigned at this point, meaning we haven't assigned it a value. So else we assign it a value. So now that that's done, we can go ahead and say test. Right, its description should. Remember that in the previous one we were saying it should call. Where is it? Where is it? Where are you? Where are you? It should call the authrepo.createUser. In that case, we weren't returning anything. It was returning void. So that was why it left it with just one functionality. So over here, we're testing that it should call the, no need for the authrepo.getUsers, right? And it should return lists user. So after that's done, let me go ahead and format this. Right, so now we start by arranging. Let's arrange by stubbing. Let's stub and hijack the president's response to this time the get users. So whenever, let me tab that so it imports mocktail for us. So whenever a higher order function calls you, Mr. President, repository.get users, it doesn't take anything, right? So we can leave that empty. But then answer with an invocation, which we don't need, we don't care, Mr. President. But we could go ahead and say, what do we want the president to tell them? We want it to give them an empty list of users. Or since we've already created an empty version of the user class, we can just simply create useStat then. So let me go ahead and final test response will be equal to a list of user.empty. Right, so now we don't have to instantiate them, so we can go ahead and say return a right, because it will return a right version of it, so t response, which is a list of users. Now we can act, and for our act of the day, we're going to be forcing this person. We're We're going to be blackmailing this person result. Await Mr. Usecase. We're saying go ahead and make the call, Mr. Usecase. Don't use anything, Mr. Usecase, and we can expect that the result of that call will be a write. Now, you might think that equals const write dynamic on the left, and on the right we have a list of user, right? And in here we will have the T response. Now we want the result to be equal to that, and you might think that this would work. Let's go ahead and run that test. That works, so we are getting the response that we're looking for. So let's go ahead and verify that this man did in fact call the president. So repository.getUsers actually got called, and it got called once. We don't want it to get called more than once. We also verify no more interactions with the president. Have you reported me to the president? Use case. Let's go ahead and run that. That should work perfectly. Beautiful. So now we're sure that both of them are working perfectly. Both the create users and the get users are working exactly as we want them to. Right, so that's it for our use case. The use case is done, its test is done, the domain layer is done. And now finally we can move into the data layer. Alright, so let's go ahead and create a model. So the first thing we want the data layer. Inside of the data layer we have the models. Inside of the model we have the UserModel.dart. Boom. So you can make this part easier, but I'm gonna write out the code by hand first, and then I will show you how to generate this code easily. You might already know how to do that if you're already a Flutter guru. So I know that some of you are. Let's go ahead and do that. Class UserModel extends. It extends the user entity, right? So it extends the user entity. All right, and then now we have to say constant user model, create a constructor for it. Now because it's extending the user, we don't have to collect the information as properties, final, username, final, because the parent class is already collecting them. We simply have to collect them in our constructor and pass them to the superclass. Right, superclass.avatar required super.id required super created that required super.name. Alright, so now that that's done, let's go ahead and start creating or extending the functionality. Remember, the entity is the blueprint and the model is the extension of the blueprint. We're building upon that blueprint, right? So let's go ahead and do that. So the first thing we want to do is to add serialization from JSON and to JSON. In this case, fromMap and toMap. FromMap and toMap, I prefer to call them that because JSON means JSON, right? If you know what JSON is, it's usually in the form of a string. It's different from a Dart map, right? So in our case, we're gonna have UserModel.fromMap, right? And this would take a map string dynamic. This is too long because we're going to be using this over and over, so I'm going to create a type definition for this right here. Utilities type def. I'm going to put this here. Type def. I'm going to call this a data map. Right, is equal to that. So whenever we say data map, we mean map string dynamic. That's good laziness, really. Good laziness. So we have a data map, and we can call that map. I mean, in here we can say this, and it will return this. It will return a user model, right? We can add constant over here, and in here it wants the avatar. The avatar, where I'm gonna simply give the map at avatar as a string. for the, what else have we got? For ID, we're going to give map at ID as a integer. For the created at, we're going to take map at created at, let me put that in there, as a string. And finally for the name, it's going to be map at the name as a string. What have we done here? What is wrong? Oh, invalid constant value. I'm so sorry about that. So what are we doing here? So we've gone to a server and we know that the server, this is what the server returns. So whenever we make that call, right? Whenever we go over here and we say get me a user, get me users, right? Where is it? Get users, whatever. Whenever we come here and we say get users, it will return us a list of these users, right? If you want to test this, let me show you how to test, right? You can go ahead and copy this endpoint, right? So copy this and paste it in your browser. We can paste that and we can go to endpoint users, right? Users, and we hit enter and we can see an empty list. So let's go ahead and let's create a fake user. 2 users, no, I want only 1 user, please. No, only 1 user. Alright, mate, let's create 1 user. Can you not just do 1 user for me? No, it doesn't. Alright, I'm just going to do 2 then. So data generated, when we refresh this, we can see 2 users, and this is the form that the users come in. I think we can also see this when we click on data. Yeah, we can see, but this is a mess. I don't like looking at this. If you want this endpoint to, or if you want this whenever you visit an API and it has to display JSON for you, normally it would display them in ugly format. If you want it to be formatted this way on your browser whenever you visit this, you use an extension. I have an extension, I've forgotten what it's called. I will find that extension later, or you can just search for JSON extensions or something. So you can just Google Chrome JSON extensions and you can see JSON view. I think I'm using this one, and you can install it into your Chrome. And whenever you visit any endpoint that will return a JSON, it will format it this way and it looks pretty. Let me go ahead and change that to Dart mode. Dark. Yeah, a lot of ambiance. No, I prefer this one. So let me save that. Alright. Let me go ahead and reload that. You could see. Right, so yes, this is what I like to see. So this is what we have. So when this happens, we will be getting a user data. We'll be getting user data in a list when we're getting the users. Now each user data contains created at, name, avatar, and ID. Oh, and the ID is also a string. So let's go ahead and change this to be a string. So over here, a string. So you can see. So we have to structure this as it is from the server. So in the server, this will also be a string, right? So over here, we also have a string, right? So everything's fixed now. So now we're saying when we get that data from the server, we actually want to take that data and pass it to our UserModel.fromMap, right? And from that map we can extract the avatar ID created at a name, right? So when that's done, how about if it was received as a JSON, as an actual JSON, right? As an actual, because this will come in the form of a JSON, and JSONs usually come in the forms of a string. They usually come in forms of strings, right? So let's go ahead and create one for that. So UserModel.fromJson, right? So what would this do? This will take a string source, so the source of the JSON, and it will do what is it going to do? It's going to return the UserModel.fromMap, right? And what is it going to give it as a map? It's going to do JSON decode, right? JSON decode, and it gives it the source, and it will return it as a data map. Isn't that brilliant? Let's go ahead and save that much. And what is your problem? Dart convert. And what is your problem again? Constructors cut. Oh, sorry. This has to be a factory constructor. Right, so finally, let's go ahead and create the rest of them. Oh, I'm getting tired. So use them. No, this time we actually want to create the two. So when we're sending data to the server, how do we want to do that? We want to do two. So data map to JSON, to map rather, and this will return a map version of what we have. So the ID will simply be the ID that we've got. The avatar will simply be the avatar that we've got, and the created app will simply be the created app that we've got, and the name will finally be the name that we've got. Right, so that's it for the date for the toMap. What about a toJson? Data map, sorry, string toJson will simply do what it will take the toMap. So we're gonna do a JSON encode toMap. So we're going to call the toMap and then code it into a JSON format. Right, so this is it. But now remember that our class is extending Equatable, right? And each of its fields are final, meaning that we can't change them. So what if we had a user and we wanted to update the user's data? So in this case, the user's name. Right, what are we going to do to the current user? We can't say user.name is equal to user.name. Maybe we can create void final user is equal to user.empty, and we want to change their name. We can't say user.name is equal to Bing or Google. Right, we can't do that. Why? Because here you go. Name can't be used as a setter because it's final. So in order to fix this, we have to add a copyWith method in our user model. Right, what does copyWith do? CopyWith gives us a way to recreate a new version of the object with the new values that we've passed to it. Right, so this is how it usually works. In a constructor of the copyWith method, in a signature of it, we take each property of that class, but we make sure that they're nullable. Right, so let's go ahead and build it out so you don't get confused as I speak. Let's go ahead and do this. So we can see it will return a user model. Right, so we want a user model after we copy the data over. Right, so we will copy with. Right, so what do we want to copy across? What do we want to copy across, or what do we want to change? What properties do we want to change? So what properties do we have then? We have the string avatar. We're making it nullable because what if what the person wanted to change was only the name? We can't force them to change the avatar ID and create it as. So if they give the avatar, then we know they want to change the avatar. So we keep the rest of them the same way, and we only change the avatar. So let's go ahead and do for the rest of them. ID string created at string name. We want to make each of them nullable, because what if that's not what we want to change? And then we can simply do this, and we can return a new user model, right? And that new user model will have, let's go ahead and format this bit. All right, so now that user model's avatar. What avatar are we going to use? We're going to use the avatar that we've got here, and if they haven't passed that avatar, we will simply use the already existing avatar of the object, right? So if we already had the user, then that user already has an avatar ID created at a name, right? If they didn't give an avatar when we're copying with, it simply means that the avatar, they don't want to change it, they want to keep it. They want to copy the existing user model by changing the name, but then copying the new user model along with the old values kept. I don't know if you understood what I said. I don't even know what I've said, but this is basically what we're doing, right? So we're simply saying, for example, we want to change the name. When we say, let me go ahead and do this. Void main final user is equal to user.empty. No, let's go ahead and do it with the user model, because the user itself does not have this, remember. So when we want to do extensive stuff, we want to do so. This person also needs an empty function, so I'm just going to copy this one over. Copy that one over. It returns a user model. Beautiful, beautiful stuff. So we have a user model.empty at const modifier. Change this version to constant. No, stop. We want to change this to a constant. Remove the constant over here. Right, so if we want to change the user's value, this user's value, then we have to save it to a new user. So final new user will be equal to the old user dot copyWith. So we're simply trying to change their name alone. We want their name to this time be Paul, right? So this is what we're saying essentially. We're saying take the old user and copy all of their values, all of its old values. In this case, the avatar, the ID, and the creator. That copy all those with this new value, right? So copy the ones that I haven't changed here with these ones. So if it was only this one, then we would say with this one that I've changed. If it was more than one, so for example avatar, then we're copying with these ones, right? So with the new avatar as well. So this is essentially what we're going to be doing when we want to create new versions of our stuff, right? So if the ID is empty, use this.id. We're going to do the same thing with creator.that. We use this.creator.that, right? So if you want to know how I did that, I simply did Command D. So I copied this. Sorry. I copied this and I did Control D. It just gave me that. So I'm saying this is not use this.name. Right, so this is our copyWith. Now, if you don't want to have to go through the stress of writing all of this yourself, you can simply go over to your user, right click on it, and say generate. Why don't we do it in the user model? Because it wouldn't work. Because the user model doesn't have any properties. It only takes stuff in its constructor. So for the generator to work, it needs to know the properties. In this case, we have the properties defined here. So this is why we're doing them here. So you can go ahead and say generate. You can generate copy, and you select everything, right? Select everything because we want to copy with everything, right? So copy with for us. We can go ahead and generate a toMap and fromMap. We can also do that, and it generates them for us and so forth. But I prefer writing them by hand. Right, so we can either do that, and after doing that, we copy them. Make sure you cut them. You don't leave them in here. The entity is just a blueprint, and then you put them in here. You come and paste them here, and that should work for you, right? So you can see now that this has become a parent, right? It's a happy parent, and it's proud of its children, right? So it's telling us, look, I have a child. Do you want to see my child? When I click that, it takes us to its child, right? So that's the beauty of that. Now we have something sending this. And now for the user model, we also have to write tests for the user model. We have to test every single class in here, every single unit, every single method in here to make sure that they work the way we want them to. So that's what we're going to do next. Model testing. And now for the model test, we're going to do the same thing we do. This is new Dart test file, user model. Boom. Now, do you remember the 3 questions that we had for each unit test? We had 3 questions. First of all, what is our dependency? What does our unit depend on? Secondly, how do we fake the dependency? How do we create a fake version of it? We use mocktail. And finally, how do we control what that fake version does? Still using the mocktail APIs, but in this case, we can go over to our user model. The user model does not have any dependencies. It does not depend on anything at all, right? So there's no external stuff that it depends on. So in this case, our unit doesn't really have a real dependency. The user model does not really depend on anything at all. You can see there's nothing that we're collecting in the constructor that has to do with a dependency, basically, like something that we take it in the constructor that we have to use across the other functions or in even one function at all. So in that case, we can just go ahead. We don't need to mock anything at all. And go ahead and start, right? So in this case, we're going to introduce something called a group, right? So first of all, you've seen the test, right? The test is this. It will give you the ability to run tests on a particular unit or on a particular method, right? Now we have a group. The group lets you group tests, right? So you can name the group. So for example, in this case, we have the fromJson or fromMap. Let's start with fromMap, right? And inside of the fromMap, then we can have different tests, right? Test 1, and we can have a second test and so forth. Right, so but then first of all, let me remove this. The first test that you always want to run for your models is to make sure that the model is a subclass of the entity, right? So test should be a subclass of user entity. So let's go ahead and arrange. So we can arrange by saying final the model is equal to UserModel.mt. So we have an empty user model. We can go ahead and say that model. So we can expect. So we're going straight to assertion. So we don't act because we don't need to act, right? We don't need to act because there's no functions to call. So we just go to assert. We don't have to act on anything. We just want to make sure that the T model is a. So when you want to check that something is a something, you put is a, and then you put angle brackets, and then you tell it what you're expecting that it will be a type of. So we expect that it will be a user, and then we invoke the isA function, right? So we want that to run. Let's go ahead and see. We want to expect that the T model is a user, and we can see that passes. It's a subclass of the user entity, right? So let's go ahead with the next test. So what unit are we going to test? What method are we testing this time? The first one is fromJson, but fromJson depends on fromMap. You can test this first totally because they're loosely coupled, right? It would still work, but personally, I just love to follow the conventions. I don't know, just like doing that. Group, boom, fromMap is what we're testing for this group. Now, what is the first test going to be? The first test should make sure, or we're expecting that it should return a user model with the right data, with the correct, or we can just say right data, it doesn't matter. Now we're going to arrange, right? What is our arrangement? Our arrange is to create a T model, but I don't think it's crazy to just have to create that in every single part. So we could just create that up top and use it generally for everything, basically. So we can simply make sure it asserts that arrange. So what is our second arrangement? We want, all right, let's go, first of all, go to act. We can act and say that the T model, final results will be equal to UserModel.fromMap, right? And what map are we going to give to this person, right? So what the map, let me go ahead and remove this as well, because we already have that generally for everyone who needs to use it. So what map are we going to give this person? So now we can see that this person depends on a map. So its dependency is a map from the server or something. In order to create this map, we can go ahead and create it up here, right? But then for convention, right, for JSON testing when they're JSONs, we have to go ahead and create our own JSON instead of creating a Dart map. Because in this case, we want to mimic the server to the core of it. We want to see this to the very end of it, right? So inside of our test folder, we're going to create a directory called fixtures, right? And inside of the fixtures, we can create a new Dart file that we're going to call that a fixture reader, right? Inside of our fixture reader, first of all, let me show you what we're going to do. So first of all, in our fixtures, we're going to have a fixture for all of our models. So a JSON file. So it's going to be a .json. So this is how our server will actually return it in the JSON format. And then we have to read that JSON, convert it to a map, convert it to a JSON, and finally, do all of that. So first things first, let's go ahead and create this one. This one's going to be a user.json. What is a user going to contain? Let's go ahead and copy our example, right? It's going to look something like this, right? So this is what our user is going to look like. So let's go ahead and change these thingies, right? So inside of our user model test, inside of our user model test, we can see that we have that little JSON in here, right? So how do we get this JSON from here and convert it into a Dart map in here, right? For that, we would have to do this. Where should I do this? Maybe here. Should I arrange it here? Let me arrange it in here. We can take that out later when we need it somewhere else, right? So tmap, well, first of all, the tJSON, first of all, will be equal to, the JSON file itself will be equal to file, right? And the path will simply be test / fixtures / user.json import .io dot read as byte sync. We want it to be synchronous, right? So now we've got a JSON file, right? Let's go ahead and print out that and let's see if it actually reads it properly. So let's see. Sorry, I haven't printed that. Print the tJSON. Right. Oh my days. No. My bad. So we can see I mistakenly read it as bytes. So we can see that it gets us these values right here as a JSON. Right now we have to convert this into. Now this will be a string at the point when we get it. You can see it to string because we're reading it as a string. We want to convert it into a proper Dart map. In order to do that, we have to JSON and decode blah blah blah, and we pass in the JSON, right? But now we in our application where I'm gonna have several models, not only one. So when we're testing all of them, we want a generic way of converting our JSON fixture files into actual JSON strings, right? So for that reason, we're gonna come into our fixture reader and we're gonna create a string fixture function. It will take the path, let's call that a file name rather, because we know the path is going to be test fixtures and then something. So file name or something. Let's file path or file name. Let's go with file name. Means that, and we can go ahead and return this, right? So test fixtures file name, and that's it. And for you, my friend, we return the .io. So we generally wouldn't be able to use this across our tests. This is why we're creating a new file for it called fixture reader. So inside of our data, this place we can create. Let me go ahead and create this up top because a lot of other people will be using them. Like a lot of other functions will be using them. So up top, I'm actually just going to create this. I'm going to call this final tJson will be equal to fixture, right? And we're going to give it user.json. And we have a map, final tMap will be equal to JSON and decode the tJson as data map. Right, so these should work. So this one would be a map string dynamic, and this one would be a raw JSON. We can go ahead in here and say, and start by acting, right? So because we've already arranged, so our action will be final result will be UserModel.fromMap. What map are we giving to it? We're taking the tMap, right? tMap, where we're going to expect that the result equals the T model, the test model. So we want to make sure that it's equal to the test model, which is actually going to fail, right? So when this is what we're saying essentially, do you get me a user model from the map that we've given to you, this map, right? This map right here, right? And when you get that, expect that its result is equal to this model over here. But then remember that this model's values, it has created that to be empty, created that, it has empty name to be that, empty avatar, the rest of them, right? So when we actually run that test, it's going to fail. Let's go ahead and run that because they're different, right? No, I think I've run the wrong test. Blah, blah, blah. No. No, it's actually going to pass. I'm so sorry. The reason why it's going to pass is because over here we're only using the ID, right? So let's go ahead and use everything else. So the name and the avatar. Yeah, so all of them must be the same. So remember, the reason why it was passing is because over here we have in the empty we have 1, and also in the fixture we have 1 as the ID. So when their IDs were the same, it was passing. The test was passing even though it was in the same thingy. So for that reason, we're going to change that, and we want to make sure so we can see that the first one passed, this one, but this one isn't passing because they're not the same, because the name is actually Lucille Dooley. We've got Lucille Dooley and we've got empty avatar, and over here we've got some avatar from Cloudflare. Oh, I don't know, I don't want to open that up, I don't know what's in there. Might be Santa. So we go into equals and we now try to change this. So it means that our JSON, we're not going to give it these generic things. We're actually just going to go into our user model. Where is it? User model. Copy these over. Empty creator that. Empty creator that. That's the wrong one, mate. This one's going to be empty avatar. And you, my friend, are going to be empty ID. So for the creator that, I'm actually going to leave the empty creator that as that. Sorry. Control Z. Copy. The ID will be 1 because in our user model we've got 1 for the ID, so I'm going to close that out. Right, a bot. Oh. So inside of our test, this test is actually still going to fail because over here we've got this date. Then inside of our user model we've got a weird date. We've got empty date, empty creator that. We don't want that, so we're actually going to What do we do? Should we copy this over? Let's just copy that over. Let's copy this one over as well. Boom. Paste. And that's done. So let's go ahead and run the test again. It should pass this time because everything's the same basically. No, there's a problem. Empty name, empty avatar. So, oh my day. So this is the problem, right? The order. So when we call a fromMap, we're actually expecting that. Let's go ahead and see. So the name, what is this one? What's that one? the ID, the name, and the avatar. So the name for my expected, in this case, the expected is this. The expected is this one, this, and the result is this one. So basically, my name was my name was rather created that. So let me go ahead and change that. Yeah, it should be name rather. So the name is name. So we want to make sure that whatever we receive from the server is going to be the same as what we have in the model after we're done. So this is essentially what we've done. We've got the data from the server, and this is the data we get from the server, right? And we're simply saying, create me a user model from that map that we got from the server, right? And expect that it will be the same as do you know what? Let's just go ahead and create a user model from that. So we can say that we expect it will be the same as this, as the data from the server. Right, this is what we're doing. The reason why I was trying so much to match the data on the server with the user model's empty data was because I didn't want to have to create a user model in the equals in order to get it to match. I just wanted to have one T model and make sure that they match, like whatever data we get there matches this. So I don't have to create this to match, create a new one to have to match the server's stuff, right? So this way we just have one generic T model and we just make sure that the server's data is equal to that. And when we call the equals expectation, right, the result will turn out to be equal to the T model, because in our user we've actually created an equal, and we've actually overridden the Boolean operator, in this case using the ID, the name, and the avatar, right? So when we do that, we're expecting that the user model that we've got over here will simply be equal to whatever we have in the results that we got from here. I don't know if you understood that, but hope you do. Group. Let's go to the next group. The next group will simply be the toMap. No, the fromJson rather. We're essentially going to do the same thing, so I'm just going to copy this over because I'm lazy. Return a user model with the right data, and this time it's going to be the fromJson, and it's going to be tJson. We run that. Once again, we pass the tests because it works, because we're expecting that the results we get from this will take the JSON that we've got over here and create a user model from it, right? It will create a user model by taking its avatar ID created that name and giving them to these. And then finally we check if the thing that it created is equal to the empty one, right? And it will work because in our server we're making sure we're hijacking the server response here and making sure that it's actually the same as the other thingy. So again, I hope you understand that. Let's move on to toMap. So we have the group toMap, and for this one we're going to say final results will be equal to tmodel.toMap, and we can expect that the results equals our tmap, because the user model's empty. The T model is actually empty, and the tmap, we're expecting that when we call toMap for it, it will simply match exactly what we have in the test map from the server. In this case, which will be this. Where is it? The user.json, because we've actually made sure that it's the same thing. But this test is going to fail. Watch how it fails. Search. Yes. So this test is failing because oh, sorry, what's the problem? Go ahead and run. So this test is failing because what is the problem? It failed to load user model test instance of an outside test exception. Oh, we haven't put this in a proper test. I'm so sorry. I was expecting this to fail, but not that sort of failure. Return a map with the right data. Yeah, so once again, this is going to fail, right? Let's see. it does not fail. Really? Are your maps equal? Let's go ahead and see if the maps are equal. I was actually thinking the maps weren't equal. Whereas the user models map, it's going to be ID avatar created at name. ID. So the reason why I thought that was going to fail was before, when I wrote tests like this, the map equality, so checking if the maps were equal, would fail if the order of the keys and the values of the order of the entries were different than the order in the other operand. So in this case, we have two. We have this toMap, the map from this, and the map that we derive from this. It usually was failing whenever they had a different order. So if ID came first in here, and in the toMap ID came last, then they wouldn't work, right? It would usually failed for me. So somehow it's working. I think Dart fixed it. They fixed the map equality. So let's go ahead and also do one for toJson. Let's be happy. toJson. Should we just copy this one over? toJson will basically do the same thing, but we just copy that over. No, copy the entire test. Should return a JSON string with the right data to JSON, and then this one, the result will be equal to the toJson. Let's go ahead and run that test. It should pass. And there we go. There's a failure. It expected creator that. So you see what I mean. So it wanted. So in this case, yeah. So this was where it used to fail in the toJson section. So because it wanted their order to be the same. So if ID came first, it expected ID to be first in this one. In this case, it's different because ID was created at. Right, so let's go ahead and change that. Let's make sure that we follow the server model. So the toMap model. So it's ID avatar created at a name. ID avatar created at a name. So let's go ahead and run that once again. And let's see. So this time they fixed the map quality. Now we're struggling with this one, with the JSON equality. So ID avatar created that. Finally name. So what's the problem here? Different at offset 1. Really? Really? What's the problem? Equals tJson. Let's go ahead and see. So the tJson will simply encode the map. What is your problem if it has next lines? So the expected actually had next lines. The expected is this one, a tJson. Yeah, that's not working. So let's go ahead and just create our own JSON over here. So let's go ahead and I'm going to copy this over. Right. Go over here. Final tJson will be equal to JSON encodes this object. So that way you can get your new lines. So we can expect that it's equal to tJson. Let's hope that works. Let's hope that works. And now it works because it wanted new lines. Dart, you're asking too much of me. So no, that's not all. That's not all. Why am I closing up my file? Let's go over to copyWith. So now we've done 1, 2, 3, 4, 5 tests. Group copyWith. copyWith is going to have an arrange. I don't think we need to arrange anything, do we? We've already got a T model. So now we're just going to skip that and go to act. T model final result is equal to T model.copyWith. right? What are we copying? Well, let's change the name to Paul. So we're going to expect that the results.name equals Paul. Or you could even add another expect. We also want to expect that. Oh my days, what's the problem with you? Yeah, whatever. Because I was typing when the test was running, so it's gonna fail. It's gonna fail me. Fail to load outside of a test. I'm so sorry. I keep forgetting about this. Test should return a user model with different data. I'm going to paste that. We're going to expect that's the case. And then finally, we're also going to expect that the results are not equal to. Alright, do you know what? Let's expect that the result no. I have an issue with my test. Failed to load compilation failed for this person. Why would your compilation fail? Expected. Have I made any grave errors? No, I haven't. I don't think I have. Have I? Why would you do that to me? What is the problem? .js utils. Have I imported some? Oh, I've imported something crazy. Dart JavaScript library. Alright, so that's it for the model test. Right, so next up, we're going to create our repository implementation. Let's see how that goes. So now, in order to create the repository implementation, we are still in the data layer. I'm going to go into the data layer, create a new Dart file, and I'm going to call that the name of our previous repository. Right, so the previous repository in the domain layer was authentication repository. So in here, I'm going to call that one authentication repository implementation. Right, so this one is a contract that defines that every time we want to create a user, we need the creator that, the name, the avatar, and we will always return a future either failure or a void. Right, and this one, whenever we need to get users, we always never take anything in the signature, no argument, right? But then we always return a list of users, right? So this is what we're doing. Now we have to write the implementation of that. So you can see these contracts don't have a body. There's no body in here. It just defines how this should work, how it should look, basically. Sorry, I messed that up. Yes, so that is how that works. Now let me close up these tests. Now the implementation thereof would be a class with the name repository implementation, right? And it will implement the authentication implements authentication repository, this one. Now in here you can see that it's asking for override. So we've written the contract. Now inside of the implementation, we have to override the interface. The interface that we've created, we have to use. Here we go. We have to use polymorphism. I think that's what we're using. We have to use polymorphism and change the behavior of the parent. Or we could leave it that way, but we're not leaving it that way because the parent is simply an interface. It doesn't have any functionality to it. So we are going to implement the functionality of the functions. Now, as I already told you, we're basically going to be following the principle D, dependency inversion. Dependency inversion isn't anything scary. It's simply this. So in here, we actually need to talk to the server. When we're creating a user, we need to do maybe http.get request to the server, and then we get the response. Final response will be equal to that, and we can then return JSON decode the response or whatever. This is how the HTTP requests work normally. I know you should have already done some API stuff, right? You should already be familiar with consuming APIs at this point, right? But we're not going to be doing that in here because that is not the function of the repository implementation. The function of the repository implementation is to talk to the data source, right? So the data source will then talk to the external HTTP library or whatever external service we're using, and then it returns that response down to this person. This person in turn takes it back to whoever's calling the repository. So for that to happen, we will need a data source, right? So our data source will be equal to something, a data source. So let's go ahead and create that data source. Data, new. Oh, sorry, I created this in here. We have to create a new folder for this. Call it I usually call them repos, but since it's the tutorial, let me make it full repositories. We push that in there. Then we finally create a new one, new Dart file, where I'm going to put that in the data sources. It's going to be the authentication remote data source. So it's a remote data source because it's talking to the remote server. If it was speaking to the local server, like the cache on the user's device, then we would say something like local data source. But in this case, it's remote because it's talking to the remote server outside. Now, for this one, we also will create an interface before actually implementing it. So let's go ahead and do that. So we are creating a lot of interfaces. By the end of this lesson, you should be familiar with creating these interfaces. So I'm going to call that authentication remote data source. And I'm going to invoke that abstract class. Then we have our, now remember that in our repository, this one, we were using this functionality where this functional programming functionality where we're either returning a failure or a void. However, in the remote data source, you will only be returning one value, right? So if an error occurs inside of your data source, you throw the error. You throw a custom error. You can throw the error you already have, but for industry standard code, it's best practice to create your own error, your own exception, and then throw that exception because it helps you define, helps you have more control over the message that you're putting out down to the other layers. So basically what I'm saying is inside of the remote data source, we do not do either failure or. When there's an error, we will throw that error. If there's no error, we will return the actual value. Now, when there's an error inside of the repository will catch the error that we've thrown and then return either a failure or the value. So if there was an exception thrown from the remote data source, this person will catch that and then return a failure rather. But if there was no exception thrown, then it will rather return the actual value. So in here, we're not going to do the either or. So what do we have? We have the CreateUser, which takes these three. So we can do that. CreateUser. Now it takes these three. Let's go ahead and put that there. Now remember that this is a contract because it's an abstract class. It's an interface, right? So we don't need to create a body for it. What does the CreateUser return? It returns either failure or void. In our case, we're returning a void. If there's an issue, we will throw an exception. Let's go ahead and do the same for this person. So we have get users. So for this time, future get users, and it doesn't take any params. So there's no parameters, but there's no parameters, but there's a return type, and the return type is a list of user. Now, instead of doing list of user, we want to do list of user model. Where's my model? I think my computer froze. Oh my. So we want a user model. So this is the catch. In every other layer, we're going to be talking about the core entity. We're talking about the entity. But then in the actual data source, when we get that value, whenever we're returning something, we want to return the model version of it, because later on we're going to be using values like serialization, fromJson, toJson. We're going to be using copyWith because our classes are basically final, right? These are final. They can't change. So we need a way to mutate their values, and that is where copyWith comes in. So we need these values. We will need these values further down in our UIs when we're changing stuff, when we're sending stuff around. So for that reason, we will need to always remember in your remote data sources, you don't return the entities, you return the models. This is how it works. However, in the other layers, you do not explicitly state the model, you state the entity. Why is this? Why are we doing this? Why don't we just do, where is it? Why don't we just do list user models, since we know we're going to be returning user models along the line? This is because we want it to be as loose as possible, so that if there's another class that implements user, imagine that if we had a different type of user, an admin or something, so inside of user, we had also class admin extends user. Imagine we had that. If we made it to be, if we came here in our remote data source and we made this to be user, if a person was an admin, after we logged in and the server told us they're an admin, how then would you tell your application that this time it's going to be either a user or an admin? That doesn't make any sense. That is bad practice, right? So because we want it to be as loose as possible, this is also another principle of solid, right? We want it to be basically implementable by anything. So every single interface or every single entity should be able to be subclassed. So we want it to be so open that we can take any class at all, any other subclass of it, and replace this version of it with that subclass. So if we had to return an admin, we can return an admin. If we had to return a normal user, we can return a normal user. So that way we always, in the other layers, always make sure that we're taking the generic entity instead of the actual model implementation of it. So let's go ahead and leave this way. Let's leave this way for now. Now, for our remote implementation or repository implementation, we will simply come over here, create our authentication remote data source. This is how it's simply going to work. We create that data source, and we remember that our data source is going to be throwing exceptions at us when there's a problem. So we will take the data source dot CreateUser, and we pass in these things in there, and then we do stuff with the result. We return it here. If there's an exception, we handle it as well. Now, that's all great and well, but remember, I'm trying to explain what dependency inversion is. Dependency inversion is simply what we do when we take the dependency in the constructor. It simply means that we're creating a space for injection to occur. If we wanted to inject something into this class and there's no space for us to inject something into it, then there's no way for that injection to happen. But if we wanted to create a space for injection, we do that through the constructor. So whenever you take something from the constructor, for example, a remote data source, which is a dependency of this class, because we know that this person will need a final data source, and then it will use that data source to call CreateUser. This person will also need that data source. Instead of creating that multiple times, we simply inject it into the class. So that way, we can use it without having to instantiate it multiple times, and also it helps us when we're testing, so it makes our class testable. You might have heard it a lot of times. Can you write testable code? What does it mean to write testable code? This is part of what it means to write testable code. This is a major part of it. If you don't inject your dependencies, then when you're writing a test for this class, how do you control? Remember what testing does. When we ask 3 questions, and those 3 questions, part of it is, how do we control what our mock? How do you even start mocking your dependency after you create a mock of your dependency? For example, a remote data source. Imagine that we're not taking it in the constructor, and we have our final data source in here equal to, and it calls CreateUser, and we also have another final data source in here. And then finally, in our test, when we're creating our test, we create that mock data source, extends whatever. After doing that, how then, when we're testing these functions, are we going to pass in that mock version into this? How are we going to do that? You can't do that. So in order to make your code testable, we need to make it so that our class is injectable, so that we can inject our mock dependencies into the class. This is the entire reason why we're using a dependency inversion. So dependency inversion is simply, instead of taking this dependency in here, we invert it and inject it into the class directly. So in here we do this dot remote data source, and I prefer to make all of my dependencies private. So that way, because dependencies are meant to be dependencies for the particular unit, right? We don't, remember principle S, single responsibility principle. We don't want other classes or other units to control or control whatever happens inside of this place, except we're in a test. So we don't want other people to be able to control what the remote data source inside of this class does. So we're going to make that private. We're going to take that in the constructor remote data source, and that's it. So in here we will be using that remote data source that we've injected, and we will use it to carry out our functionalities in the method. Now, the principle of TDD. Remember, the course is about clean architecture, the principles of solid, and the principles of TDD. The principles of test-driven development. Test-driven development. Oh, sorry, my fonts is low again. Not plugin settings. Fonts. I've got to put that to 16. All right. Yes. So I hope you can see that better now. I'm so sorry for not putting it up earlier. The principle of test-driven development. Test-driven. It's driven by tests. So we are going to be writing our tests first before we actually implement the functionality. So in order to write the test first, we need to know what we want our method to do. So we're going to be writing the test for the CreateUser method before we actually implement that method, before we write the codes that will do that. So we want to be able to know what we want our class to do. What do we want the method, rather, not the class, the method CreateUser to do? We want CreateUser to, first of all, we want it to call the remote data source. So you break it down. This is usually, you can actually follow these testing principles for all of your repository implementations. This would work across the board. This is why clean architecture is so beautiful. The moment you learn how each module works. For example, this module, right? This module, how this module works and how the test is written. The process that it goes into creating the test for this module. You no longer have to learn a different way to write tests for it. It's simply, you're just going to be writing tests the same way for every repository implementation. You're going to be writing tests the same way for every remote data source. You're going to be writing tests the same way for every module, every use case, and so forth. So how do repository implementation tests work? First of all, you test to make sure that we are calling the dependency, in this case the remote data source. If you have a different dependency, you would also write a test to make sure that you're calling that dependency. Secondly, you check if the method returns the proper data. What does that entail? Let's go deeper into that. So we're on the small, so this is on the larger scale. This is what we're checking, if the method returns the proper data. So, but then what does that actually mean? On a smaller, when I break it down, what does that actually mean? We're testing to check if when the remote data source throws an exception, we return a failure, and if it doesn't throw an exception, we return the actual expected data. This is what we're doing for the test. Let's go ahead and write our test. So where is my repository implementation? There, new Dart test file, authentication, repository implementation. Now, for this, what is our dependency? Remember, what we need to know our dependency. First of all, our dependency is going to be the mock auth repo. I'm just going to I actually prefer to shorten this because I don't know, just it's going to be very long if I write out that entire authentication repository implementation. Personally, I just shorten it. You can leave it as long as you want. So class mock auth repo implementation extends mock from the mocktail, implement the authentication repository. That is really long. So you can see why I prefer to shorten that. And then finally we have our dependency mocked and ready to be manipulated. So let's go ahead and create our void main, the entry point for our tests. So this is where our tests will start. Let's go ahead and do the setup. So for our setup, for each test, we actually want to create a new repo implementation, which will be whatever. So let's create that here. Await authentication. No, sorry about that. Our dependency is not the repository implementation. Our repository is rather the authentication remote data source. I'm so sorry. That is our dependency, not the other thing. So it's rather the mock auth remote data source. I'm going to write src for that source. This is bad practice. You probably want to do that, but don't care. It's not a real project. Authentication. So my late authentication remote data source. Notice how I'm not writing the mock over here and just telling this right away that it's mock. I just prefer to write the actual class, right, so that we know what I'm looking for. And then when I'm creating it in the setup, I rather replace the instance with the mock version of it. So we're looking for the remote data source. We also need our late authentication repository implementation. That's a long name, repo implementation. For this, we're going to call the authentication repository implementation the real version of it, right? Because we're not going to be manipulating or pulling any actual sources in here, so we don't want to mock it. We only mock our dependencies. So in this mock, I'm just going to remove this. It's going to use this one. Then before I actually instantiate this one, I'm gonna create the dependency, so that by the time that this gets created, as you can see, the local variable is definitely unassigned at this point, so that by the time we create this will be assigned. So let's go ahead and do that. Before data source will be equal to the mock auth remote data source. And that's it. We're done with our setup. Now, how does this test actually work? Remember, I told you that we're going to test the functions one after another. So first function we're going to test will be the CreateUser. So remember that inside of the CreateUser, we're going to be testing for two things. First of all, to check if it calls the remote data source. Secondly, and to make sure that if... So we could do this in two different tests. We could also make sure that it returns the proper data if there is no exception. So these are the things we're going to be doing. Make sure that it calls the remote data source. We're also going to make sure that it returns the proper data if there's no exception. This is basically a sub of this. So this is the broader term. We can put this in here. Also check that when it throws an exception, return a failure. And if it doesn't throw an exception, return the actual expected data that was fulfilled over here. So we first of all make sure that it returns the proper data if there's no exception. But then check if there's an exception, right? And then we return a failure if there was an exception. So these are the three things we're going to be doing. But then sometimes I prefer to join this into this. We can put that into one test, and you're going to see how I'm going to do that, so that we don't have too many tests. But then first of all, we have a function, a method to test. So for each method, you want to create a group. Sorry, I'm outside of the void main. I have to be inside the void main. So we want to create a group. This is a group. A group just simply is a group of tests. We're going to be writing more than one test, so we want to put that in a group. We're going to be writing more than one test for a single functionality, so that's why we put it in a group. So what functionality are we writing the multiple tests for? It's the CreateUser. You write the name of the function the way it appears. Where is our repository implementation? This is it. So we write that way. We close this out, and we go ahead and start with our test. So the first test will be a test. The description, remember, what are we trying to do? We're trying to make sure that it calls the remote data source. And remember, I wanted to join this into it as well. So should call the remote data. The remote data source dot create user and return the proper data. In this case, we're not returning anything because CreateUser is returning void. So let's, instead of returning and complete successfully when the call is successful, when the call to the remote source is successful. Let me go ahead and cut that bit. That is super long. Let's go ahead and do that. That should solve that. Asynchronous function. Now we start writing our test. So we want to make sure that we call the remote data source, and we want to make sure that it completes successfully when the call to remote source is successful. How are we going to do that? So if we want to make sure that the CreateUser got called, right, we want to use the verify. We verify that the remote data source .CreateUser got called with what values? With whatever values that we pass. We want to make sure that it got called with the correct data as well. So we're checking for three things inside of this function. Check that remote source is CreateUser gets called and with the right data. So and then we make sure that it got called successfully. So in order to, well, this will actually tell us if it got called. Then passing in these will tell us if it got called with the right data. And how do we know that the data is the right data? We know that because whenever we call the remote data source, we're calling it from the repository implementation. The repository implementation would take these data and pass it to this person. So meaning that in order to make sure that this gets called with the right data, we just want to make sure that whatever data is here matches whatever data that was given to the repository implementation. So this is the assert part. Now we have two parts. We have arrange. I just started with assert because I don't want to confuse you. If I started from, I just want to start from doing this and show you how or why we need arrangements, right? So now I'm going to take care of these later. So this will actually take care of that. We also want to make sure that it got called once, right? We want to make sure that it got called once. Now this will take care of this part. Now we also want to make sure that it completed successfully when the call to remote source is successful. So in here, in our arrange part, when the remote data source .CreateUser gets called with any named created at any named name named so once the remote data source gets called with any of these values, we don't need to mock the values because these are strings. They're Dart types. They're native Dart types. I don't think we need to mock them. We don't need to. So anytime this function, this method, command L, yes. So anytime that method gets called with any value at all, anytime this method gets called, this is basically what we're saying. Then answer. We're using answer because it's a future. Then answer with your invocation, which we don't need. We need this to be async. Always remember for this to be async. Always answer with a right. A right. Right means no. The remote source doesn't return right or left. It just returns void. So always return with the proper void value. So we can't return void. Dart will not let us do that. So whenever you're returning void, you should use future.value instead. So anytime that this gets called, always return a future value. Always return the correct data. Don't throw any exceptions, because in this case we're testing to see if it returns the right value when it's successful. So this is also where dependency injection comes in handy, right? So because our dependency, we can manipulate the dependency and make sure that when we're testing for success, that it's always successful. So this is what dependency inversion does for us. This is where it's beautiful. Now we have hijacked the return type, the return value, or the functionality of dependency, and we're saying whenever you get called, always return success. Now we're also checking to see that whenever there's success, we also want to make sure that the function, the actual repository implementation that we're calling, the CreateUser over here, completes successfully. And how do we do that? First of all, we act. So we act and we say the final results will be equal to, we can say it's equal to await for the repository implementation dot CreateUser with some values, right? We can come back to that later. We wait for that to complete, and then we expect that the results is equal to. So remember that whenever the CreateUser gets called and it returns successfully, right, we always want this to complete successfully. And how does it complete successfully? It will return a right value, because this is either failure or void, and the void is always on the right, so we always wanted to return a right hand user. This might be a lot to take in. If you're confused, go back in the video and start from whatever you got lost at. But then we're just going to make sure, expect that the result will always be a right. A right what? A right in this case is going to be null. Why is it null? Because it's void. And we can't say a right void. So whenever there's a void, your right hand type will always have a null value inside of it. So we can check this and say equals, that the result is equal to a constant right hand type, and that's it. So this makes sure that whenever this completes successfully, which we're forcing it to complete successfully, that it will always return a right hand type. Now back to this. How do we make sure that we get the proper data from the repository implementation? We simply create these. We create these, and then we make sure that those values that we passed in here are the same values that reflect in here. Right, so this is basically what we're saying. We're saying that our final created at will be equal to, I don't know, whatever you want to call that. Whatever. Now, what have we got here? Const, copy that, paste. Now, essentially what we're saying is call the CreateUser and give it created at, this name, and this avatar. Now, when we're verifying to make sure that the CreateUser got called. 1. 2, we're verifying to make sure that it got called with the same values that were here. So if, let me go ahead. So if when we're calling the remote data source.createuser from the repository implementation, if when we're doing that, we're passing the wrong value, instead of passing in the actual value that was from the repo implementation, then this test will fail. And then finally, we want to verify no more interactions with our remote data source. We want to make sure that nothing invokes remote data source again after we use it. So you will understand this a little better when we start writing the implementation. Now we're in the phase 1 of our test, which is what? The red phase, which is where your test will fail, because you haven't actually implemented it. So this is our test. This is what we want to make sure. We want to make sure that this is the case. How do we make sure that that's the case? We can see it's failing because it's unimplemented error. We haven't implemented it yet. So we can go ahead in here, and what is the test that we just wrote? The test that we just wrote is trying to make sure that one, we call a remote data source. And how are we going to do that? Fine, we're simply going to do await, right? Sorry, await remote data source, which is the whatever remote data source that got passed in here. Remember, and now it's important because in our test, in our test, we've passed in a mock version of that remote data source. So we can use, we're basically using this data source that we're controlling. So over here, we're controlling its return type. So in here, whatever data source, when we're actually using this class in our actual application, we're going to be passing in a different remote data source that we've created, not a mock version. So, but then even in this case, look how beautiful this is. In this case, we're passing in a mock version that we're going to be controlling its functionalities. So even whenever this class is running in a test, or whether it's running in an actual instance of the application, it will still work in both cases because it's taking that instance in its constructor. So we can go ahead and say that to make sure that we're calling the remote data source, in order to make sure that that particular test is passing, we're going to do remote data source.CreateUser, right? And also, in order to make sure that the test where we're checking to verify that it gets called with the right data, we're going to pass in the actual data that we have in here. So now this will actually, so for now, I'm going to return just a right null, just for this function to stop screaming at me. So now the first test is going to pass, right? We're trying to make sure that this part, the verified part, works. So I'm going to go back and rerun the test. So let's go ahead and run the test. You can just run the group if you wanted to, but I'm just going to run the entire thing. So let's see if this test passes. So we can see that the test has passed, right? But then imagine that inside of this place, I made a mistake. And instead of passing in the creator that I had over there, I passed in a different creator that. So just a random different creator that. Remember that the actual creator that we're passing in is this, whatever creator that. This is what we're calling, and we're passing it in there. So in here, when we receive this, I'm going to pass in the wrong one. You can see that the test will fail. So if you make such errors, the test will alert you. It will fail, and that failure will alert you, right? So no matching calls. There was no matching calls because we have a different creator that. Meanwhile, in our actual test, we're passing in whatever .creator that, not a different creator that. However, in this case, this will pass. And now we also want to make sure that the return type is correct. So we want to make sure that we return the results, whatever result we get from this. So this person actually doesn't have a result. So we can either say final result or whatever. But since it's void, you can leave this way and always return a right null. Remember, I told you when your function returns void, in here you always want to return a null. So I'm going to make that constant, and the first test passes. Now, finally, remember we have a different test as well. So we've completed the test to make sure that it calls the remote data source. We've also completed to make sure that it returns the proper data, in this case a right null if there's no exception. Now, what if there's an exception? Let's go ahead and fake an exception. So inside of the same group, we create a different test, and this test should return a server failure, this time a failure, or a server failure rather. Let me just call the server failure when the call to the remote source is unsuccessful. Cut that, save that. Now we want to make sure that whenever a call to the remote source is unsuccessful, that the implementation of our repository returns a left server failure. You could actually make that left rather server failure, but I just prefer to write the actual return type of the left or right. So we have async. Now we're actually gonna mock or stub. This is called stubbing. Remember, we're actually gonna stub the hijack the remote data source. So now we're saying that whenever the remote data source .CreateUser gets called with any of these, let me copy the arguments. Remote data source .CreateUser, whenever it gets called with any of these, paste. Then throw. What am I doing wrong? Then throw. What are we throwing? So we're going to be throwing, in this case, a server exception. I haven't explained this bit to you yet, but so for now we have failures. In our data sources, when we catch an exception, remember I told you we don't want to throw the raw exception. We want to convert it into our own defined user-defined exception. So we're going to be defining our own exceptions, which is going to be an implementation of the actual Flutter or Dart exception. So we have inside of errors, we have exceptions. And in here, we're going to have the class server exception. If we also were talking to the cache, we would have class cache exception. But in this case, we're not talking to the cache, so we're going to have a server exception, which will implement, or let's make it extend Equatable, because we want to be able to equate if an exception is the same as another exception. So we extend Equatable, and then we implement the raw Dart exception. And in here we have server exception. In here we will take fired this dot message, fired this dot status code, because the raw exception doesn't tell us the status code, but in our case we want to have the ability to tell the status code. This is also part of why we're creating our own exception. So whenever the server returns an error, we also pass in even the status code. We can take final string message, final integer status code, and we can override the, don't want to type that by hand. We can override this and tell it that for this class to be equal to another class, both of their messages and their status codes should be the same. So now, inside of here, we're saying that whenever the remote data source gets called, we want to throw a server exception. And this server exception is going to have a message that's going to say unknown error occurred. And it's going to have a status code of 500 because it's from the server. So it's going to be an integer rather. Let's go ahead and save that much. Constant. Add a comma. So now we're saying that whenever someone calls the CreateUser for this test only, throw an exception. Now, how do we expect our actual implementation to handle it? This is the arrange. Now we go ahead and we act. How are we going to act? We await. Well, let's save that to a result because it will return a left something. So we await for our repo implementation .CreateUser to be called. So we actually want to call it with these same values. So I'm just going to move these up into this place. So that way everyone can have access to it. instead of only that first test. So we wait and we call. So we're acting. We're calling this, and we're expecting that whenever that happens, that the results that the repository implementation will give us will be equal to a left this time, and it will be equal to a left server failure, and that server failure must have the same message. Sorry. Don't we have a server failure yet? Oh, we have an API failure rather. So because we're using an API, not a server. So over here we can also change this to be API exception. Refactor. We have an API failure and we have a message, and that message must also be the message from this person. So unknown error occurred. And we also have a status code 500. Boom, boom, boom. Pop. Oh my, that's ugly. Add a constant. Save this much. Add a comma. Save that much. Yeah, that looks better. So we're expecting that whenever this person throws an API exception, that in our actual repository, when we get an exception, what do? We return a left API failure using the same message from that exception. If you want to understand this better, we could save this exception. So we could just save this exception up here. Say final test exception. The T means test. Will be equal to this exception. We can make it a constant because it's got a constant constructor. We can just simply then throw that exception, T exception. So we want to make sure that our failure is using the same message from the exception so that our user sees the same message that came from the exception. And we also have T exception. There we go. Dot status code. And over here we use the dot message. We can remove the constant because it's no longer constant. We can add the commas, format that. So now, after doing that, we actually want to verify that the remote data source, regardless of the error, we want to make sure that the remote data source.createUser got called, and it got called with the correct data. And it also got called once. Then we verify that there's no more interactions with the remote data source after the error occurs. Boom. We've got our tests and we're still in the red phase. So let's go ahead and run the tests. We can see that the first test will pass. The second one fails woefully. There you go. So the first test passes, but the second one fails because an unknown error occurs and we don't return a left failure. You can see it's throwing that error right back at us. So how are we going to handle that error? Because it's an unknown exception, it hasn't been handled. In order to do that, we will simply wrap this in a try-catch block. So we do this, else on API exception, we can catch the E. So in this case, we don't need to catch every exception, right? Because whatever exception occurs, no matter what sort of exception it is, whatever exception occurs in the remote data source, it will always return an API exception if it was talking to the server. If it wasn't, it will always return a cache exception if it was talking to the cache, and so on. Whatever it was talking to, we will create a custom exception for that. And in our remote implementations, we know what we're talking to, so we can expect or watch for the exception from that provider. So in this case, our provider is the API because we're creating a user. On API exception, we will simply return a left server failure API failure rather. I'm so used to server failures because I rarely use APIs. And the message will be e.message, and the status code will be e.status code. Easy peasy, lemon squeezy, and that's it. Now our test should pass because we're catching that error and we're returning an API failure that uses the same message and the same status code. Let's see, and we can see our test passing. Now, in order to make this a lot more succinct and shorter, we don't want to always have to do this because we're going to be doing this a lot in a lot of places. I'm telling you, it's going to get a lot. So we always want to find ways to make these things shorter. So I'm going to create a different constructor in here, constant API failure dot from exception. We can say dot from API exception, but nah. Get it. I'm just going to do dot from exception, and we're going to take an API exception. Let me also rename this to API failure with capitals, so we have harmony. So this is our exception, and with this we can return, we can actually make this a factory constructor, or we can do, but today I'm not teaching about constructors, so I'm just going to go ahead and use this constructor and return this with the message, where the message will be exception.message, and its status code will be exception.status code, and that's it. So it's not a constant. Let's go ahead and save that much. So in our repository implementation, we can simply return a left API failure dot from exception. We can pass in the E as the exception. And our test, every time you change something, always rerun your test to make sure that nothing broke. There, our test passed. So now you can pause the video and try to write a test for the get users. Go ahead and pause the video. Alright, so if you were able to do that, then well done. If you weren't able to do that, don't worry. This one's a little bit different because we're returning something and we're not taking anything here. So let's go ahead and delete this. No, I'm not deleting that. Remember, we always write the test first before the actual implementation. So let's go to the test file. I'm going to close everything. Close tabs to the right. Yes. And then I'm done with this group. I'm going to create a different group. Group get users. I hope that's what it's called. Yes, get users. So the first test, similar to our first test, we can just simply come here and see the first test should call the remote data source of CreateUser and complete successfully when the call to remote source is successful. In this case, we're going to do something a little bit different. Should call the remote, what was it? Remote data source dot get users and return a list of users when call to remote source is successful. I'm going to go ahead and cut that. Oh, sorry. Yeah, that's it. I officially can't type. So we take this away. There you go. Now we hijack the president. There you go, Mr. President. Remote data sources are president today, and when we get users, remember we're not taking any params, so there's no parameters, so we can go ahead and say .thenAnswers with the invocation that we almost never need, and it's going to be, I'm sorry, async. What are we returning? We're returning a fake list of users. you can go ahead and create a fake list of users in here with users.empty if you wanted to, user.empty, and create more and more if you wanted to, but I'm not going to do that. I'm just simply going to return an empty list. Remember, the remote data source.getUsers will return a direct list of user model. So now you can write a test to make sure that this gets called. Let's format that. So final results will be equal to await for the repository implementation dot get users, and we want to make sure expect results equals constant write null, not null this time, a write empty list, and we also want to verify that the remote data source dot get users got called, and it got called once, and it didn't get called with anything in its signature. And we also want to verify that there's no more interactions with the remote data source. Ooh, that was a long test. So now let's go ahead and run this test. There will be a few problems with this particular test. So let's start from the first one, unimplemented error. Let's see, go. Come on. Yes, there we go. Unimplemented error. Let's go ahead and implement that. So first of all, we want to make sure that remember, you don't always want to write the full implementation. You want to write as a test. So this time our test is only asking, so you want to write as much as will make your test pass. What is going to make our test pass in this case? The only thing that's going to make our test pass is if we return exactly the list that was returned from the remote data source when there was success. And we also want to test to make sure that it got called with the right data. So we're just basically going to be doing one thing basically. Final result will be equal to await remote data source dot get users, and we return a right results. So tell me, is it going to pass? Fail. So now you can see what is the problem. The problem is that we're expecting, right, a right list of users, and it returned actually a right empty list as we asked it to. This is the actual problem with lists in Dart. Lists are difficult to equate. They don't have proper equality. They don't have value equality. If I can use that, I think that's what it's called. So in order to actually write these sort of tests in your repository implementation, where you have a return type of a list, whether you put something in here or not, this test is going to fail. Even if we put in the same value in here and there, it's going to fail. In order to test that, what I usually do is, instead of checking if it's equal to an empty list, right, I rather check if the result is A. If it is a right, what is its type? On the right hand side, on the left hand side, it's a failure. You can put in failure, or you can just put in dynamic, like I already taught you. So we want to make sure that it's a right dynamic with what on the right hand side, it's a list of user. Right, so that's it. So this test should pass. Now you might ask, how then do we know if the values of the tests of the list are the same as what was returned? What is the problem this time? Matcher is a right list user. Oh, I forgot to close this. So is A should be invoked. So that's how I usually pass this test. You can see it's passed. Let's go ahead and write the second test, which will be testing when there's a failure. So test I'm thinking about just copying this over, but where is it? This one. This one should rather be an API failure. So it should return an API failure when the call to remote source is unsuccessful. Let's go ahead and copy that. And then we return that function. And we can check to make sure that when remote data source .get users then throw an exception, an API exception. Now we already created one, so T exception, and we can act rather. Final result will be await repository implementation dot get users, and we can finally expect that our result equals a list. Sorry, not a left rather. Server fail, API failure. Dot from exception, T exception. We expect that it has the same message. We verify that remote data source. You can just copy these over. That should solve it. Nice. And we can run that test. And we can see we're back in the red phase. So let's go ahead and implement this and put it in the green phase. So let's go ahead and cut that and try catch. Boom, our test has failed. We're waiting for on API exception, catch the exception, and rather return a left API failure dot from exception with the E as our exception. We can go ahead and run the test again. Nice. So we're done testing and implementing the repository implementation. And then finally, for our external layers, we're going to write the test and implement the authentication remote data source. Now, what are we going to do for this one? Remember, this is an interface. We're not going to be testing the interface. We're only going to be testing the implementation. You could go ahead and create a different file for this, but I'm just going to put this in here. Usually we put this in the same place as the implementation for the remote data source. So I'm going to copy this over. Auth remote data source implementation. You can type that out in full. Station, or you can just make it impl extends authentication remote data source. Oh, that's no, it implements because it's an implementation. It will implement implementation authentication. That is a long name. That's too long. I'm sorry, I can't do that. Auth remote data src impl. I'm so sorry, that's too long. I can't follow good coding practices in that case. It's too long. Boom. We make sure that we have asynchronous functions. Always asynchronous functions. And now we have these. We're in our red phase in our test. We haven't written the test yet, but when we write this test, we will be in our red phase because we haven't written any implementations. So now that you've learned how the repository implementation testing works, let's go ahead and learn the structure of a remote data source test. What do we do in a remote data source test? First of all, we check to make sure that it returns the right data when called to the client or to the dependency or whatever, or when called to the server, or when the response code is 200 or the proper response code. So the reason why I'm doing this is because sometimes, for example, for CreateUsers, we're going to be doing a post request. If you know anything about HTTP requests, post requests rather return a 201 conventionally, not a 200. So if you're only checking for 200s for your success, then when there's a 201, your app will rather throw an error, even though creating user was successful. So instead of considering only 201, make sure that you know what method you're calling. If it's a post request, check for 200s and 201s. I think delete has a different one as well. I think delete also has 201s inside of it. I'm not too sure. I don't remember. Or 204s. I don't remember. You can check them on Google, but I know that post requests have sometimes 200s and sometimes 201s. Some people make them 200s. I don't know why they do that, but normally it should be 201. So let's go ahead and no, I'm still teaching you the structure, so let's not write the test yet. So the second part is, so this is 1. For 2, we check to make sure that it rolls an exception, a custom exception with the right message when status code is the bad one. I guess I could call it a bad one. So look how similar the tests are. So for this one, we write a test to check when the remote source. Let me show you the test rather. We check to make sure that when the remote source is successful, we do this, and when the call to remote source is unsuccessful, we do the other thing. But then in here, we're rather going to be doing the same thing, but on the upper level. So we're moving one step higher. Instead of checking on the remote source, we're checking on the response code. So the first one was when the call to remote source is successful, do this or do that. When it's unsuccessful, do this or do that. In this case, for the remote source, when testing the actual remote source, you do this instead. You say when the response code, or when the server's response, which is the same thing as the response code, right? Or you can say when the status code rather, when the status code is this, do this or that, and when the status code is that, do this or that. So let's go ahead and write the tests for these. Let's go into our remote data source and create a new Dart test file. That is a long name. I hope I don't mess it up. Authentication, yes, remote data source. Now, what is our dependency in this case? You can see that in here we've created the implementation. What does this implementation depend on? It will depend in this case on the HTTP library. So in that case, let's go ahead and add HTTP to our Flutter project. I'm going to do this, Flutter bulb add HTTP and Flutter bulb get. That should add me the HTTP library. Now I'm going to import HTTP.dart and I'm going to give it a variable name so that I can reference that variable name instead of using its classes just like that. So what is our dependency going to be? It's going to be an HTTP.client. We're using the raw HTTP client and I'm going to call that a client. Remember, I always make my dependencies private. Final auth remote data source implementation, this.client. We take that in a constructor. In the actual application, not final const. In the actual application, we will be using Firebase, Firestore, Firebase authentication, and the rest of them. So we'll rather be using those in the constructor instead of the HTTP client. but then those ones require different style of testing. So this is why I'm teaching you this, because in most of your projects with your companies, you might not be using Firebase directly. You might have a backend guy who's building it out in Python using Django or Flask or whatever, or maybe Node.js and Mongo. So you need to know how to write tests with HTTP. This is why we're doing this part. So let's go ahead and write the tests for this. So in our auth remote data source test, let's start by creating our dependency. In this case, the HTTP client. So mock client extends mock import auto import implements http .client. http.dart. We have to add that variable name as http so that it will reflect over here. So now you can see we don't only mock the classes that we've created, we can also mock dependencies from external libraries. So now we're going to have total control on whether the HTTP client will return a proper data or not. Let's go ahead and start writing the test. Let me go ahead and close that up. After that, we can start with our void main entry point. At this point, we're always going to be writing void mains in our code. Void main, we can go ahead and start by writing the client. So this time we have an http.client. Remember, I prefer to take the raw object in the declaration, but then when I'm instantiating it, I use the mock version. So that way I can know, I don't know, just feels better that way. You can do the other thing as well. I don't know. Late what? So we've taken our dependency. Now let's go ahead and take our our actual class, our actual unit. So this is the remote data source. We're going to set up async. No, you're not async. I'm so sorry. I'm used to using async a lot. So first of all, let's instantiate the dependency. It will be a mock client. And finally, the remote data source will take the client. It will be an authentication remote data source. Come on, auto-complete it for me. Authentication remote data source. Yes, this is sorry. So over here, this is the abstract class. We can't instantiate the abstract class. So we're rather going to instantiate the implementation of it. So we're rather testing the implementation, not the actual abstract class. So I'm so sorry. But over here, I'm totally just going to put the name of the actual object instead of its implementation. Then over here, when I'm instantiating it, I will rather use the implementation. So let's go ahead and do that. Auth remote data source implementation takes the client. So we're done setting up. Let's go ahead and start our testing. So remember, we are going to be writing tests for two different methods. So for that, we need two different groups for these tests. So let me go ahead and group. Also, you can actually put a group in the group. So for example, CreateUser. I could have a different group in here for maybe a smaller subsection. Maybe I want to break down my tests. Maybe instead of joining these two tests together, like I did here, I joined this test and that test together. If you wanted to break them down, but also group them as one specific, I don't know, one specific group or something. For some reason, it might come up sometime in your coding where you have to write two different tests while in a group, but then those two different tests should have their own, you feel like they should have their own group still inside of that main group, you can totally do that. That's valid. You can have a group inside of a group. That works. You can have a different group. So that all works. But we're not going to do that. Let's go ahead and write a test. Should, let me save this. Data sources, save to dictionary. Right. So we want to check first to make sure that it returns the right data when the status code is 200. In our case, a post request will return 200 or 201. So we want to check for both since we know we're doing a post request. So should complete successfully because we're not returning anything. It's a void function when the status code is 200 or 201. Async L. There we go. So we start by stubbing the HTTP client. So we say that when our client posts, because this is the function we're going to be calling in the client in this function. In the remote data source, we're actually going to be doing a post request. So we want to say that whenever we call a post request and the URL, this time the URL is a positional param. You can see that over here. It's a positional argument. We can instead use any without adding in the named inside of it. So when the post request gets called with any URL, but then remember that we're going to be passing in some data, the body that we're going to use for creating the user. In this case, we're going to be passing in the username. What is it? What are we passing in? What do we need? The creator, that the name, and the avatar. So when that happens, our body, we're going to be passing in any named body. This time the body is going to be a string, so I think it can take care of a string without us explicitly having to give it or having to register a fallback value for our mock arguments. So in this case, it's the body. We can say .then answer. This is a future. A post request returns a future response. You can see. So we're going to use the answer instead of a return. Let me go ahead and close up that invocation. Async. So if you've done anything at all with the HTTP library in Dart, you know that it returns a response. So that's where we can say response.body, response.status code, and so forth and so on. So it returns a response. So we're going to create a fake response. So let me go ahead and do that here because we're going to be using those responses for the two different whatever. No, we're going to be using it once actually in here. So I don't think get uses the same response. So it will be http dot response. It has a response object. Should I put a comma or not? So this response wants something. It wants, yeah, it wants, I think it wants the data and the status code. So I could just put the status code, this time 201. And the response will be maybe user created successfully. Remember, this will return void, but it doesn't mean that the server will not have a response. The server usually returns, sometimes the server actually returns the user's data after you create the user. It will return 201, meaning created, and then it will return the data of that user in that creation, So where I'm actually just going to leave this way. Sometimes it can also just return a statement like success, user created successfully. So we've created our fake response. Now, let's go ahead and act. What is our action? Final results will be equal to await. Our action will be the remote data source .createUser. and it's going to create the user with creator, that name, and the avatar. Let's go ahead and create those final. Do you know what? Let me just convert these to strings. I don't have to go through that stress of creating that again. So now, oh my, stop. Now we will simply expect that the result is equal to, so what will be returned here when the success? It will be equal to nothing, a future value. It will be equal to void. But remember, we can't return a void. That wouldn't work. Sorry, void. That wouldn't work. So you can either return a future value, right? Or you can say this. There's another way to do this. You can do this. You can make sure that the result completes. But you can see now that the expression is of type void, so it can't be used. What does that mean? It means that this actually completes and then returns as a value, and then we're checking if that value completes. But complete actually tells us if the thing on the left completes, meaning that the thing on the left should be a function. So in order to do that, let's just go ahead and save the name, or say the name of the function here. So the method call. So the method call, this is a method call. We're just going to save that method call over there, and we can simply say, make sure that that method call, that when it gets called with these values, right, that it completes successfully. You can go ahead and add this back here. Simply say that whenever higher order function calls this method with these values, that it completes successfully. And then you can go ahead and say verify that the clients.posts actually got called, and it got called with any URL. We don't want any URL. We want our actual URL. And how are we going to get that? Let's go ahead and pop up a Chrome tab, and find here. I've got mine over here. We've got a mock API. So it's going to give us a URL. We have our TDD tutorial. So we can see the base is simply this slash test API / say this is the base. Let's go ahead and create a base. So let me go into utils. I actually want to create a new file. Constant. I'm going to call this const k base URL will be equal to that. So now we can append the base URL and the endpoint. Let's go ahead and do that. So verify that the client.post got called. Verify that it got called with the correct URL. And what is the correct URL? The correct URL will be the k base URL / how do we create a user? CreateUser was / CreateUser, I think. Let me see. If we had users, it would be / CreateUsers post. Yes. User. Where is the CreateUser? We just call post users basically. So post users should create our users, our user for us. So we call post users, and we pass in the body users data. So post users. So / users. This is our endpoint. You can also go ahead and save the endpoint inside of your remote data source, the actual remote data source. So we can come into our remote data source, and at the top of it, in here, outside of any classes, we can see this const k create user endpoint users, and we can, I spelt constant wrongly. Constant k get users endpoint will be equal to / we had users. What would it be for getting all users? It would simply be / users again, but this time as a post request, as a get request rather. So, but then in your case, you might have different endpoints for these things, so you might want to just do that separately. So over here, we're doing that, and we're adding a / no, we already have a / so this time it's a CreateUser endpoint. I think this bit should be in a curly brace to distinguish it. What is the problem? Oh, it wants URI. Yes, I'm so sorry. So we're going to use URI.pass. So you can actually do this URI.pass, and you can do it that way. When we're doing a GET request, I'm going to show you a different way to do this using URIs as well. But then for now, let's just go ahead and use URI.pass. And then for the body, we can actually JSON encode. Remember, the body is expecting a JSON, so we're not going to pass in the raw map. So we want a map where the created at will be equal to the created at that was passed the method call. So we can go ahead and say it's equal to the created at, then the name is equal to name, and the avatar is equal to avatar. Import dart convert, and that should solve that. We make sure that it gets called only once. We don't want to post twice. So this is our post request, and we're sure that that's going to get called. So after that's done, let me save this much. I think this is too long. Yes, that's properly formatted. So we're making sure we're verifying that the client.post got called with the correct URL, and it also got called with the correct body, being that its values were the same as were passed to the function call. Then we verify no more interactions with the client. So we can go ahead and implement this over here. So what are we expecting? We're expecting that whenever this returns the right data, so we're actually gonna go ahead and save this response is equal to, and we're actually sure that its response code is going to be 200 or 201. So let's go ahead and implement it. So where is my implementation? Response will be equal to await a client.post. And what are we posting for? We're posting for URI.pass, the same URI that we had over there, just to make sure that we're posting to the correct endpoint so that this test will pass. We want to make sure that we're posting to that endpoint for the body. Kbase URL, we have to import this. And we have to make sure that the body will be JSON encode. And we want to make sure that it will have the same values as were passed in from the signature. And in this case, created at will simply be created at. Name will simply be name. And avatar will simply be avatar. And yet again, I fail to format. No, stop. Yes, All right, so I think that's formatted now. Let's go ahead and are we returning properly? It completes successfully. Final response. If the response is 200, yes. So at this point, I don't even need to do this. We could save this for later after we write the test for the second part, testing when it's not 200 or 201. Let's see what happens. Fingers crossed. And there we have a failure. Register fallback value. Why? Oh, because URI. Remember, the URL is not a string, so we need to register a fallback value. Because at first I thought it would be a string, but it's a URI. So I'm just going to register a fallback value with a URI, just an empty URI with nothing in it. So let's see. And we have another failure. Complete successfully was not a future. Let me see. I think there's problems from here. Let me go ahead and remove this top level invocation and let's just invoke it and make sure that it completes successfully. Yeah, so now it passes. So we can see in this case we don't need the top level invocation over here. We actually do that when we're saying look, when someone or anyone calls this function on the right side, then verify that this or that or this or whatever we put here is true, right? But in this case, we actually want to call that function because we need to make sure that it completes successfully. So we just go ahead and invoke it without depending on some other outside functionality to call that function. So this is why it was failing. So we go ahead and invoke it. So also remember that I told you that this could work if you removed this and put its invocation here and then checked if that was equal to future value. That's a lie. That wouldn't work. I was totally lying. That wouldn't work. I actually thought that would work, but I'm thinking about it now because this actually has a return type of void. So if I actually went ahead and awaited for this, then this would fail. As you can see, it's a type of void, so you can't check if it was future value, right? So in that case, you would probably just have to obliterate this, pull this, and remove the expect, right? But if you actually want to make sure that it works and it completes, you can use the invocation without the top order calling. So you just invoke it yourself. So that's how this test would work. Let's go ahead and test for when it fails. So when it fails, something similar would happen. So let's go ahead and do that. Let's write a test. We want to make sure that it throws an API exception. Should throw API exception when the status code is not 200 or 201. We can actually go ahead and say when the status code is 400, but what if the status code was 500 or if it was something different? So in order to cover every base, grammatically, I just prefer to say if the status code is not 200 or 201, then we probably want to throw an error with that same message, with the proper message. You can go ahead and add that with the right message, but that's basically what we're testing for. So when client.put, let me go ahead and hijack what we had up there. When the client.post gets called with anything at all, then answer, or we're not answering, we're answering with a response, because when there's an error from the server, the post request does not throw, it actually returns your response, but with a different status code, 400. Invalid email address. So in here we final call, method call. So whenever you're testing for the exceptions, whether it returns something or not. So when you're testing for this one, the reason why we did this way is because it doesn't return anything. When it returns void, you can do this or totally obliterate this and just await and call this function here, like I've shown you before. You can rewind just a few seconds. But then whenever you're testing your exceptions, you do not want to invoke this in here. You always want to save a call. You save the call, and the call will be remote data source dot create user. We don't want this yet. You always want to save the call. Then you use a higher order function. So you expect that when a higher order function, in this case, we'll invoke it. So, but then when a higher order function calls the method call, because we're not going to be using its results because it's going to be throwing an error. This is why we don't need to remove this, because in this case, we had to remove this because we were invoking this in order to use its value to make sure or to check if it completed successfully. In this case, when you're checking to see if it throws an error, you want the higher order function to call this method. So you always want to put it this way. So you can also remove it though, but preferably I'd advise you to use it this way. So when a higher order function calls our method call, what do we want to do? We want to check that throws a. Want to make sure that it throws an API exception with the message saying invalid. We want to make sure that the message is the same. This is why it was important to extend Equatable. Alright, so that way we know that the API, this will be correct only if the actual exception thrown from the create user is the same as this, if their message and status code are the same. And why will they be the same? Because the response that we've just hijacked for the server is saying this. So when it says that, we want to make sure that whatever is happening inside of the create user will return an API exception with the exact same message and the exact same status code. This is why Equatable is important in your fake exception, not a fake exception, but in your custom exceptions. This is also why we want to create a custom exception for testing purpose. So let's go ahead and do that. Save this, comma, format, save this much. That should work. Add constant. Now we need to add second comma and format. Beautiful. So we want to make sure that whenever this gets called, that it throws an API exception. Where does that end? It ends here, and then we want to verify that the client .post actually got called of the correct data. So let's go ahead and copy these over because it's just going to be the same thing. So we want to make sure that that gets called. When we run this test, it will fail because we're still in the red phase. So let's go ahead and put that in the green phase. Let's go ahead and start. No, not here. It should be over here. But bing. So first of all, let's save that response. So let's go ahead and check client post final. Sorry, if response.status code is not equal to 200 and response.status code is not equal to 201, then throw a server an API exception with the message from the response.body, and the status code will be from the response.status code. The body is a string. So let's go ahead. Some servers would return you the message with a map or like a data map. So you have to decode it and then extract the message from inside of it. So in that case, you can just do the same JSON decode and then you extract it. So inside of this place, if your server does that, you also want to mock that as well. You want to be able to pass in a map in here and put this in maybe a key value pair, and then make sure that it extracts the proper thing in here. So let's go ahead and do that over here. If response.status code is that, we want to make sure that we throw an API exception. Let's test that and see if it works. That did not work at all. Let's see what's the problem. Let's go ahead and wait for this to complete. Async. Let me see if that fixes it. Oh my. I didn't invoke this. Oh my. I'm so sorry. I did not invoke that at all. Go ahead and invoke this. Where is it? There you are. Method invocation. Let's see if that fixes it. Yes, so I'm so sorry. That was an oversight. So this is how this testing would work. So now this works. However, in here, imagine if we had a Dart error. So we've totally tested and considered every server type error in here. But what if we had a Dart error? What if something failed in here? So let's go ahead and wrap this till in a try catch block. Let's try this. And then we catch any general errors. So when there's any Dart errors or any general errors, we just want to throw an API exception with the message as the e.toString. Maybe I don't know what could cause an error, but whatever causes an error, we can make the status code to be 505, because if there's an error from here, then it's probably from us, probably our problem. So I'm going to make it 500 rather, not 500, but 505, because the server can return a 500. So if the server returns a 500, we don't want to confuse that with our Dart error. So when it's a Dart error, I'm just going to do 505. So this is maybe something that's broken in our code and we need to fix it. So that way we can know that this is from us. So I'm going to make this specially 505. Now, in this case, this will actually, when we throw it, because we've added a try catch, this will actually catch this throwable that we've thrown here. And then it will actually convert this entire thing to string over here. We don't want that. So whenever you try to catch something and it was an API exception, don't go ahead and convert it to string and then put 505 error. No, we want that exception. So on API exception, just rethrow the exception. Simple. Rethrow that exception. Rethrow that exception, because this will mess it up. So imagine that we had a 404 error. It will simply convert this whole thing to a string, and then in here it will put 505 instead of 404, and we won't know what actually went wrong. So whenever you're throwing something in here, always make sure to override its catch in the catch block. So whenever it gets here, it will just rethrow it and exit the function and throw it back to the repository that's calling it. You can go ahead and write a test to make sure that when there's a Dart error, that it will catch that Dart error and throw this. But I don't think I know of any secret Dart errors to be thrown or something. Look at that little silly mistake that I've made. So let's go ahead and run that test once more. In order to test for this, you're going to have to find out how to fake a Dart error. What could cause a Dart error in this case? I don't really know, but stuff happens. So we're just going to future proof it by catching any other errors. What else do we have? So let's go ahead and write the test for get users. So pause the video and try to write the test for get users. Alright, so for the test users, we have the group get users rather. I kept saying test users. So for get users, we want to write a test. The first test, let's go ahead and copy this. It should complete successfully when the status code is 200 or 201. But in our case, we want it should return a list user models when the response code when the status code is 200 or 201. Sorry, it's 200. Get requests usually end with 200. No 201s. Async so when the in this case we're calling a get we're making a get request when find.get with any URI where we're actually not gonna have a body over here. There's no bodies in here. We only have headers, but we're not gonna be passing headers. So we're not giving anything to it. But then I will show you a trick to use if you had to give your server something in your GET request, because servers use params for their GET requests instead of bodies, or if your server wanted you to give anything at all, and the GET request from the HTTP client doesn't provide a way to give a body, it only gives a way for headers. But I'm going to show you that. But first of all, then answer with HTTP async http.response, and in our response we will have first of all JSON encode. It's usually going to come in an encoded format, so that's why I'm making it a JSON encoded object. So JSON encode the object, and what object are we encoding? A list of users. So I'm just going to create that list of users at the top. Final t users will be equal to user.empty. Let me use the user model because I need to use the toMap version of it. So empty right. Change this one to a constant. So that should work. So in our JSON encode in here, in our response, we actually want the TUsers.first.toMap. Right, toJson. Should I make it toMap or toJson? toMap because we're already JSON encoding it, so toMap should be perfect. And now where am I? Inside of this place, we actually want to go one step in. No, we actually want to go one step out and then have the status code will be 200. Right, am I in the right place? 200. Yes, that's the correct place. So, because this is what the server will return for us, a map of the users. So not the actual user model itself. That only exists inside of our Flutter application. So let's go ahead and act. Final result will be equal to await. Or remember, in the previous place we only used the method call and checked if it completed because it didn't have any return data. So it returned void, so we just wanted to make sure that it completes successfully. That was why we did that. But in this case, we have a list of users to be checking it against. So result will be await remote data source dot get users, and we want to expect that the result equals, when we check the equals the t users, I don't know if the list will malfunction the way it did for the other place. Remember, Dart lists are hardly equatable. So let's first of all try with this. If it doesn't work, then we can simply check if the results dot first is equal to the thingy inside the TUsers dot first. But for now, let's just check with this, and then we verify that the client dot post got called. It got called once, but what did it get called with? We want to make sure that it called with URI. Now we can do URI.pass, but then remember what I told you. What if you had params to pass in to the server? In that case, I'd advise using URI.attts. This is personally what I use, whether I'm passing something to the server or not, whether I'm making a post request or not. I usually use this. So in that case, you can go ahead and put in the authority. The authority in this case will be your k-base URL. Your endpoint, right, will be the k CreateUser endpoint. So now we don't have to do the little string concatenation that we've done over here, because we can just do this, right? We can give it the authority which is the base URL, the unencoded path, which is the endpoint, and then the query parameters. So let's go ahead and give it. If we had some query parameters, we can see that it takes them in the form of a map string dynamic. We can just pass that in and give it whatever we wanted to give it, whatever the heck we needed to give. But in this case, we're not using that, so let's just go ahead and do this. And now for that, that we're using a get request rather. So when that.get gets called, do that, and we don't need to pass in any other things. So let's save that much, and then we verify no more interactions with the client. Now we're in the red phase. If we run this group will fail. So let's go ahead and implement this group particularly. So final result is equal to await client.get, and we can pass in the URI.attts rather. The authority will be k-base URL. You can also use URI.pass like we did here. It would still work, alright? I'm just doing this to tutorial purposes. And I personally use this one because then I don't have to do this k-URL, k-CreateUser. I can just pass them in directly. No, not create, it's get users endpoint. And that's it. And then we can return the results. Oh, sorry. This is the response rather. So if response, we can just return JSON decode the response dot body as a list. So this will return as a list. So now we don't want to directly cast this as a list of map string dynamic. This usually fails, alright, because after it gets it from the server, it sometimes doesn't know how to cast it properly after JSON decoding them. So what I usually do, and what you probably want to do in order to cover every base, is to take this as a list, save it in some parentheses, save it in that little bracket, and then outside of here we want to cast. We want to say list of, in this case, a data map, because we already saved that as a type definition dot from. You can either do this, or you can simply do this as a list dot casts, and you can cast it as a list for data maps, but I prefer to do it the other way because I just think it looks neater. And then we can map. Now we get each data, so user data, and we can get. This is a tutorial to teach how to do deserialization. You should already know how to do this. You could just do user data, and we can do UserModel.fromMap. I think we can even pass in the JSON. We don't need to user data. We don't need to pass in the map. Then in this case, we're already decoding the entire list. So .toList. So this is what I usually do. So this will take the data from the server, decode it as a list, cast a list of data maps from it. You can also do the cast thingy here, remember, and remove the list from the other side. And then we go through each map inside of it, and then from each map we create a UserModel.fromMap in that and create a list for it and return that general list to this person. So hopefully the group works now. The group passes its test now. Let's see. Fingers crossed. No, it didn't pass. Invalid radix at character 1. We've got a little exception. Where is the exception from? First.toMap. What is our toMap doing? Oh, it's my authority. The base URL, when you're using the base URL, you do not put the HTTPS this / because we're already using the URI.https, so there's no point putting in that data thingy. So let's go ahead and fix that. Over here, let me just subscript the base URL. I'm subscripting away 0, 1, 2, 3, 4, 5, 6. We could do that. We could just delete this and use URI.https everywhere. So even over here, we can use URI.https and use the base URL. And use this one. So we can come over to our top part and also use this over here. Come back here and use it here. Yes. And we've got another failure. It doesn't want me to put in the /. Oh my. It just wants the this is the authority. Keep constantly messing this up. So let's go ahead and cut out this part and put them in there. Yes, because this is also part of an endpoint. So we don't want to keep the endpoint inside of the authority. The authority is the boss, the main domain. Alright, so that problem solved. Now we have a different problem. So no matching calls mock client.get. Are we making a get request over here? Yes, we are. With HTTP test user with headers null. But I am making a get request. What is the problem? Verify that client, when I call get users, verify that client gets called with these dot called ones. Result is equal to T users. Let me see what the problem is. Oh, I found it. This is the disadvantage of copy and pasting. I copied this without changing this endpoint to get users endpoint, so it was confused. See why testing is important. If I did a copy and paste in my actual implementation and I forgot to change it, test would catch it. And now our test is passing. Let's go ahead and also handle the case where this test failed, or sorry, where the server does not return anything. I think it should be similar to this. So to throw API exception when status code is not 200. So let's go ahead and so when it should throw an API exception when the status code is not 200. So when this looks wrong, what's wrong? When the client, I'm just going to copy this this bit and change the status code. Oh, all right. For 500. Server down. Server down. I repeat. Server down. Mayday. 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 We are going down. Alright. That's my error. And what's your problem then? Too many positional arguments. Oh, really? And what do you close? You're from the JSON encode. We don't even need this though, this JSON encode. We can just delete this bit. Because now we've got this HTTP response. Nice. Nice. So this is my response. I can finally say that final call, method call, will be equal to the remote data source dot get users. We save that call and we finally say that expect that when a higher order function calls that method call and passes in nothing, that it should throw a AP. Do we already have an exception? Throws an API exception where its message is the same as this message that we've got here. Let me save that message. The message it should be equal to the T message, and then its status code should also be 500 as is over here for our response. Constant save, add commas, format, save. Yes. And then finally we verify that we can just go ahead and copy this. Copy and paste is dangerous, but this is actually the same thing. We verify that the client.get gets called with the correct endpoint, and we verify that there's no more interaction. So we're going to do the same thingy where we check and see if response.status code is not equal to 200. We will simply throw an API exception with the message being the response.body and the status code being the response.status code response. And we can save this much, and we can also catch any Dart errors, for example, a format exception as we encountered when we made a mistake with our base URL. So stuff like that could cause a Dart exception which will not be called within this scope, within this response scope, because it was thrown by a Dart code instead. So let's go ahead and on AP. Do you know what? Let me just go ahead and copy this part, paste it here on API exception, rethrow, else throw an API exception that catches everything. So let's see if we are finally in the green phase. Green phase, yay! Alright. The tests have completed and have all passed. So let's go ahead and implement our block. Oh my, this is so long. Exceptions close, source. I'm closing out everything. So in our source, we have authentication, we have data, domain. Finally, we have the presentation layer. So we have presentation. Inside of the presentation, you could have the app directory. If you have more than one state management solution, maybe for example, I use both provider and BLoC at the same time. So if in that one feature you have both provider and BLoC, you don't want to put them just bare bones on the presentation layer. You want to put them into something. So personally, in this particular example, we're only using the BLoC, so I'm just going to use the BLoC. We can also use cubit. This tutorial, I don't know if I should teach both BLoC and cubit, but whatever. Let's start with BLoC. No, not a file. So delete. We want to create a folder called BLoC. So we can either use a BLoC or a cubit, whichever one you want to use, right? So this is not a BLoC tutorial, but I'm actually going to teach how to use both BLoC and cubit in this example. So let's go ahead and start off with BLoC. So first of all, in order to do this, first of all, you create a folder called BLoC, and then inside of it, you go to new BLoC class if you're using the BLoC, else new cubit class. How do you get these? You can go to your plugins and search for BLoC. You can find this little thingy, BLoC by Phalangel. If you're on Android, if you're on VS Code, you can also search. You can also find BLoC as well. So in here, I'm going to create a new BLoC class, and it's going to ask for a name. I'm going to call that authentication, the name of the layer. So we want authentication BLoC. You can also call it auth alone, and then for the style, we're going to use Equatable and hit OK, and it's going to create 3 files for you: the BLoC, the event, and the state. So whenever the user hits on the button, we actually don't want to call a function. When we're using BLoC, we call the event. We will simply go and say the BLoC, we call the BLoC and we say BLoC.add an event. Then we add an event from in here. We have some BLoC tutorials on this channel, so you can go ahead and go search in this channel to find our BLoC tutorials. So I'm not going to go so deeply into how everything in BLoC works, but I'm just going to give you examples with both BLoC and cubit. But then let's go ahead and start building out. So first of all, with our event, we extend Equatable and we create our event. What event are we going to be handling? What are we going to be doing in this? Event simply means what is the user going to be doing? The user is going to be hitting the create user button. So for that, we create a class called, since it extends Equatable, let's go ahead and override list objects get props from the Equatable, and we equate it to an empty list since we don't have anything inside this class. So let's go ahead and also add another event class, create user event. It will send authentication event, and then in here you collect as properties of this class, you collect whatever you need in order to create a user. So what do we need? First of all, we need a created at. Finally we need a name and an avatar. And that's that. So we go ahead and create a constructor for this. So let's go ahead and do that. Const create user event. We can do this required this dot created at required this dot name required this dot avatar. That's that. We can go ahead and override this. Copy that, paste it here, and taking the created at the name and the avatar. So an event will be equal to a different event if they're created at name and avatar are the same, and also if they're both CreateUser events. Then finally, we also need to get users event extends authentication event constant get users event required. No, we don't require anything at all. Sorry, I'm just speeding through this. We don't need to override this because we've already overridden it in the parent class over here. So this was why I did it here, so that when we have something that doesn't have any properties, we don't have to go ahead and override it again because we already did that in the parent. So in here, what is your problem? We need to import Flutter, BLoC, and BLoC as well. So let's go ahead and import those two. Not import, add them. So Flutter bulb add Flutter Flutter BLoC. We also need to add the BLoC and Flutter bulb get. So we need both the Flutter BLoC and the actual BLoC package. So we've added both of them. So on authentication event, what will happen when there's an authentication event? What do we want to happen? We will be emitting some states. But then first of all, let's go ahead and take care of this. When there's an authentication event, we're not going to do anything at all. But then when there is a first of all, let's do the CreateUser event. When there's a CreateUser event, we don't care about the raw authentication event. If you had one loader, then maybe you could do that. If you wanted, for example, to know when there's two different states, you want to know particularly when there's two different states. You don't need to use the raw event. You don't need to do anything special when or any event at all gets triggered. So when you would want to use this part is when, for example, if we had a CreateUser event, then we would want to show a loader. And if we had a getUsers event, we also want to show a loader. If we had a delete user event, you will still want to show a loader. So in that case, you could do on authenticate user event, then just show a loader all the time, emit loading state. All right. But then in my case, when we have a CreateUser event, I want to know in my loader that we're loading for CreateUser so that I could display the message saying creating user or getting users. I will show you what I'm doing in the UI when I'm done doing that. So we're not going to invoke or create the function in here where let's go ahead and abstract that into a different function. So I'm going to call that CreateUser handler. And also on what other event do we have on get users event? Let's go ahead and have the get users handler. So now after that, we can go ahead and inside of our block, this is where we start taking our dependencies. What does the block depend on? The block will depend on your use cases. This is how clean architecture works. So what are our two use cases? We have two use cases for this particular feature, and those will be the CreateUser. So we have the CreateUser, and we can call that CreateUser. Remember, my dependencies, I prefer to always make them private. Users, get users, and in here we can go ahead and take them in a constructor. So final CreateUser. We're doing it this way because in a named constructor, I'm making them named because there's two of them. I prefer to have named constructors when I have more than one argument to be given. So that way I know what I'm giving, where I'm giving that. So when you have a named argument, a named constructor, you don't, and you have private properties, you cannot say this dot create user and then this dot get users. That wouldn't work. You can see name params can't start with an underscore. So we have to explicitly state their type. So CreateUser. What? Why did I? Oh my. Why am I making it final? It should be required rather than final. Required get users. And then finally we can instantiate that before we call the super constructor. So we can do that by saying CreateUser will be equal to the CreateUser from the constructor, and the get users will be equal to the get users from the constructor. Delete this person. Now let's go ahead and start working. So we have to create our handlers. So future void, they're always going to be void because they're never returning anything. Handler, we can simply say async. Now for the handler, it actually gives us something, or expects something from us. You can see over here an emitter and the state. It gives us an emitter and the event rather. So first of all, let's go ahead and take the event. What event are we taking? In this case, it's the create user event. And we're going to call that event. And then finally, it gives us an emitter of a state. What type of state? The authentication state. I hope I spelt that correctly. And that's the emit. So now when this create user handler gets called, before we do anything, we want to emit a state. And what is that state? We want to emit a loading state. And this was why I wanted to create these two separately and not use a general authentication event for handling every loading state. So for that reason, I'm going to go into my authentication state and create a state. So every state by default will have the equalizer, and they will all be constant. So constant authentications initial. Then we have our class creating user extends authentication state, and we have a constant creating user, and that's it. It's a loading state. We have a second loading state for getting user. Users extends authentication, and we can have constant getting users. And then finally we have the success states. User created extends authentication state, constant user created. And when the user gets created, we actually will be giving the user two things. No, we're not going to be giving it anything when the user gets created. We will be giving something when we get our users. So users loaded sends authentication state, constant users loaded, and we will be receiving this dot users. It will be a list of user. Remember, outside of the remote data source, we do not state that we're using the explicit model. So in here, we're going to say users, and we will override the list object get props. And now over here in our users, I don't want to have to make it check against the users. I rather want it to check against the users' IDs. I think my users have IDs, don't they? Yes, they do have IDs. So instead of doing this users, so it will be a list in the list. So it will basically check if their lists are equal. But remember that Dart has difficulties with checking lists equality. So instead of doing that, sorry, I'm actually just going to take the users and then map them. And instead of equating based on the list of users, we're actually going to create a different list from our list of users. So from each user, we're just simply going to take their ID, user ID dot toList. So when we get a list of users, we take all of their IDs and create a list of user IDs from it, and then we check it against the next user's loaded state if their IDs are also the same as these IDs. So this is essentially what we're doing. Finally, we have one more state, authentication error. And for this one, we have authentication error, and it will have a message, this dot message. And we can override once again the list. This time I'm just going to say string because it's one string. Get props. Over here we can also even change this to int since it's a list of integer IDs. Oh, it's string, so also a list of string. So get props, it will be a the message. So if the messages are equal, then it's the same error state. So in this case, we will emit a constant creating user event. Creating user states, not an event. So we emit that, and then we go ahead and use the create. So the result, we save this in the result. So we call the use case. Remember that the use case has a dot call. Sorry, final result will be equal to await create user. Remember that it has a dot call, but that means we can just invoke that use case. And then we pass in the, what are we passing in? We pass in the CreateUserParams. And then its created at will simply be the event.created at. Its name will be the event.name. Its avatar will be the event.avatar, because the event in this case is a CreateUser event, and the CreateUser event already collects these from the user when they hit that button. Oh my. So save. So this is our result. Now our result is going to be an either failure or void. So this is what happens. The block, the user will hit a button. The button will emit and will send an event, or it will dispatch an event to the block. The block receives that event and it checks what type of event is it. It's a CreateUser event. Then it will go into the CreateUser handler. It will call the use case that's related to it, meaning the use case that we've linked to that event. In this case, the CreateUser, for CreateUser event. Let me add a constant over here. Now, when that happens, it will call that event and give it the proper data. After it gives it that use case goes ahead to call, where is it? Oh no, it goes ahead to call the repository, and the repository will call the data source. So later on down the line, when we're injecting our dependencies, you will see how everything connects. So let's go ahead and continue. So when that happens, remember that the repository rather returns a future either failure or void, or in this case void, because we're using the CreateUser. So this is why we have an either failure over here. So where is it? So yes. So our repository implementation in the data layer will call the data source. Data source returns simple void. It will complete and return a void. However, this person takes that void and returns a write null. So it doesn't just return the void as well. It returns either failure or success. So now we take, how do we now know? So in that case, we use something called folding. We fold, we say results. So we can fold on the either type. So we fold it, right? And it provides us with the left and the right. So this is essentially saying what happens if it's the left. So if it's a left, we want to emit an authentication error state. And its message, in this case, I want its message to be, so I want it to be something like 404 error, unknown, on invalid username, that sort of error. I want it to be arranged that way. So for that case, we would have the status code first. So 404 error, it would be the L.status. I'm going to call this failure. Since it's a failure, so it will be the failure. So instead of calling it left, I'm going to call it failure. Failure.status code. So 404 error. And it will say the message. So in this case, failure.message. This is how I want the message, the final error message to look like. And then finally we have our write. In this case, I'm not using the write, so I'm just going to emit constant user created, a user created state. Emit. And since I'm not using the write, I can simply replace it with an underscore. And that's it. So this is how our block would work. Now, I'm going to create a what do I create? Let me create a cubit also, so that we can see how cubits work. Let me first of all implement the getUsers handler, then we can go ahead and create a cubit. It's basically similar, void getUsers handler. And in here, I'm gonna have a getUser event, and I'm gonna have an emitter authentication state, emit async Alright, so first of all we emit getting users const. Then we can go ahead and say final result will be equal to get users, and we can invoke that, and we can say result.fold. And if it's a failure, we want to emit. We also want to emit an authentication error with this style of messaging. And since this is actually the same way where we're going to format every message, why don't we go ahead and add that to the failure class? So every time in the failure class, where's my all errors failure? Every time in my failures class, we could have a getter inside of failures. So string getter get error message, and we can make this to be this. So in this case, it should just be message. And in this case, it should just be failure. Now it's going to ask for this. I'm going to remove the interpolation braces and then leave it as that. So in here, we can simply say failure.error message. Simple and short. So over here, we can also just emit authentication error. And in here, we can get failure.error message. So we've done one for failure. Let's go ahead and do one for success. And the success will get us a list of users. So let's call that users instead of write. And for the users, we emit. What is the problem of my code? We have to await so that it returns this. Do this and that. And then we do this. Do that. Emit. What is this one for? Yes. So we emit a users loaded, and what does it get us? It gets us a list of users. We can simply emit that list of users because the users loaded already asks us for a list of users. This is how the block would look like. Let's go ahead and do for a cubit and create a cubit. So new directory cubit. Let's create a new cubit class. We're going to call it authentication. Also use Equatable, and it's created our files inside. So we're actually just going to copy over the authentication state from the block because it's the same thing. Similar. Just a problem user. The only difference would be in the actual block. No. It should be part of authentication cubit. And then in here, we don't have to import anything at all. What is your problem though? We import this. It goes into the auth cubit. We come over here at constant, do the same thingy that we've done over there. Close this up, come to the block. Same thing that we have over here, we copy that over. Paste that. Get here. Copy all of this. Put them right before the super and right here. Now we have these. So it's basically the same thing. The only difference is that with the cubit, we don't have events. We can simply go ahead and create the functions that handle these things over here. So instead of saying event.add this, we can simply say, just do this. You'll see the difference in the UI. So let's go ahead and create this. So for get users, I'm actually just going to copy this over from the block. So get users, we simply do the same thing. We just emit this and fold that. This is rather for create users. So for create user, so remember that for the block, we take the params or the arguments from the event. In this case, we don't have an event, so we take it from the method signature. So we have required string created at required string name required string avatar, and that's it. We have an async function that ends this way. We go ahead and paste this. Instead of events dot, we just simply have created that, the name and the avatar. Future void get users async. So you can see how similar the block and the cubit are. The only difference is that one person uses events, the other person does not bother. So the cubit is a simplified version of the block. So if you prefer hard work, you can go ahead and add an event and go through all that process. The event has its pros as well, because with this type you could save or log events. This is deeper stuff. You could track your history, what events were triggered. If you want to track what your users interact with, you can track them through the events, what events they dispatched from the UI and stuff like that. But if you want simpler stuff, you don't care about all that, you can just go ahead and use Cubit. It has other good functionality, good pros, so you can Google that and find out what you can do with the block over the Cubit. So let's go ahead and write a test for our a Cubit, because we're mostly going to be using the Cubit. It's basically the test is going to be the same except when we're doing the act section. But then let's go ahead and start. New Dart test file. I'm going to call that authentication cubit. What is our cubit dependency? Our cubit and our block depend on use cases. Remember, so we're going to create mock versions of our use cases. Mock get users, then mock implement get users, and we also have mock create user, then mock implement create user. Let's go ahead and import those. Then we start. So entry point void main. So what do we need? We need mock get users. No, we just need get users. I'm not going to write the mock version. Get users. We also have create user. Create user. We also have the block itself. So these are the dependencies. We have the block, or the cubit in this case. We have the authentication cubit. Now after creating our stuff, let's go ahead and do this setup. This is coming from Flutter test. So first of all, get users will be equal to the mock get users. Create user will be equal to create user. No, not this. Create mock create user. And then finally we have the cubit, which will be equal to an authentication cubit, and it will take the get users and create users, and we initialize it with that. And that's it. So now after each test, we actually want to destroy the block. I personally just prefer to always destroy the block after each test. Right, crush it, whatever is left of that block, destroy it, and then before moving on to the next test, because this is the block, right? We don't want any live-in instances of it after we're done with it. So we're going to do cubit.close here down. So setup would actually run this function after before running each test. Here down, however, will run after a test. So after a test, what do you want to do? So after each test, we actually want to close the cubit. This is what we want to do. We don't want to leave it open. So let's go ahead and start our test. So the structure for testing your block or cubit, the first thing you want to test, we're still going to be using groups, but then this one isn't part of the groups. So the first thing you want to test will be, what was it even? I think it's the initial state. So we usually test the initial state first. Initial state should be, what is the initial state? It should be, I think, authentication initial, if I remember correctly. And for this, we have async, and we have to say that we expect. We don't need any arrangement or actings because the block already lives, the cubit rather already lives. So we're just going to assert that the cubit that we have, its initial state is a cubit.state is equal to a constant. Should it be constant? I don't know. Yeah, it should be constant, I think. Authentication initial, where is it? Yes. Let's go ahead and run the test. and the test is passed because it will always start off as an authentication initial state. Now we have a group test for CreateUser. Now we can either go ahead and write the test as we usually do when blah 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 blah, but we already have a BLoC test package. We can add that in our developer dependencies. So let's go ahead and find that in public dev and add it. So we can say Flutter pub add as a dev dependency BLoC test and Flutter pub get. Let's wait for that to complete and then we can go ahead and start using it. So you can go ahead and read the documentation for the BLoC test, but I will just walk you through how it works. So this is how it works. So you instantiate, you start by saying BLoC test. You can see there's a snippet. You can hit enter a tab. I don't know if enter works, but I just hit tab and it starts your test for you. And you can describe it. It should. What should be the first thing that we test for a particular? In this case, it's a cubit rather, but then you still use the BLoC test. We're testing a cubit, but you still use the BLoC test. If we're testing the BLoC, you still use the BLoC test. So the tests for the BLoC and the cubit are basically the same, except in a particular part, in a particular section, the acting section. So the testing for BLoCs and cubits without the BLoC test package is it's a little bit different. But then using the BLoC test package, it allows us to test it the same way we'd test other units. Else we'd have to be doing some stuff like converting the BLoC to a stream and then listening to that stream inside of a test and all of that. So it's actually a little longer. I used to do that before I found out about the BLoC test package. But right now I don't think you even need to know how to do that, because the BLoC test package makes it super easy and it's basically doing the same thing and it's handling all of the boilerplate behind the scenes for us. So the first thing we want to test for our particular functionality, CreateUser, is that it should emit. What does it emit? It emits creating user, and lastly it will emit, after it creates the user, it will emit user created, I think, when successful. Let's do it that way. So now we have the description, just like a normal test. Now for the BLoC test, you actually have to state two things over here. The first thing will be, it should be the state or the event. Let me see. First thing should be the state. B extends BLoC base. So the BLoC, the type of the BLoC. So in this case, it's the authentication cubit. And then finally, it's authentication date. So this is just the syntax to make it work. Now finally, you have to give it the build. What to do. So this is where you arrange. So normally, if you don't want to arrange anything, you can just go ahead and return the cubit. All right, the cubit that you've created up top. Then we actually want to do something. So I'm going to open this up. Now we actually want to say that when the use case, so we want to hijack the dependency, in this case the use case, and what use case is that? The CreateUser use case. So when CreateUser gets called with anything at all, and for that any CreateUser, we're actually going to register a fallback value because it's not a Dart type. What the CreateUser uses is a CreateUserParams. So const the CreateUserParams is equal to CreateUserParams.empty, and that's it. So let's just use the empty version instead of creating that from scratch. And we create user with any, it will just hijack this and put in there. Then answer. invocation async go. It will answer with a future.value because it will answer with a void, but we can't return the void. So let's go ahead and add a const. Is that the problem? No, const is not the problem. What is your problem? I think it wants us to state the type. Future value shouldn't be called for non-null argument for the non-nullable type, either void. Oh, sorry, it doesn't return a void. It returns an either right or left. So in this case, you want it to be a right null. So let's go ahead and import dartz and add the constant. Now, after we stub in the build, we always want to return the cubit because it will use this cubit to build out the rest of the functionality. And now finally we act. So you can see it follows the principles of testing. So we have arrange in the build, we have the acts. How are we going to act? We will act by. So it gives us the qubit that we return from here. It passes it back to us over here. And we use that qubit to act. How do we act? We call CreateUser. So this is where the part where testing for a qubit and testing for a block would be different. Because when we're testing for a qubit, we can just go ahead and call the CreateUser. And we can CreateUser with whatever things we need. Oh, sorry, comma. But then if it was in a block, if we had a block rather, what we would do would be to say that that block, let's imagine that we had a block. It would have been the block dot.add, and we add a create user event, and then we adding those things, and that's it. This is the only place where it differs. This is the only place where there's a difference between block and qubit and testing using the block test package. So we act by calling the cubit.createUser, and finally what do? We assert. And for our assertion, I think we say expect. So what do we expect? I saw something else. So never mind that, it's errors. So we expect and when we expect, we want to return a list of the states that we expect it to emit. If we weren't using the block test, this part would have had us writing emit later, expect, emits later, or emit in order, or stuff like that. There's longer stuff that you have to write. But in this case, we just put in the list of things that you were expecting to be emitted. So in this case, we're expecting that first of all, it emits a creating user event state rather, creating user state, and finally, after it creates the state, it creates the user, it emits a user created state, and it passes in nothing because it's going to be empty. So we can just make this constant over here, remove this constant, remove unnecessary const keyword, and then finally, personally, you can skip this part, but personally, in order to make everything better, I prefer to do this, verify. Yeah, it's giving us the qubit. I don't think I need it. So we want to verify that the dependency, remember verifications are always for the dependency. We want to verify that the dependency CreateUser got called with the CreateUserParams that we passed in when we called this basically. And how do we know that it got called with exactly this CreateUserParams? Let me see how the empty looks like. So the empty is empty.created@. So instead of doing this, create cubit.createUser created@. So inside of CreateUser, it will create. Where is it? It will create a CreateUserParams with these things, with these values passed in here. So in this case, this test would fail. This test would fail. Where is it? Where is my test? This test would fail because the instance of the CreateUserParams is using CreateUser.empty, which is using empty.created@. However, the actual params that will be used for the CreateUser inside of the block would be this one that's not using empty dots CreateUser, it's rather using the CreateUser that was passed in to the CreateUser, and in our test we're passing in just a CreateUser with no empty dots, empty dot whatever. So if we want this test to pass, or if we just want to make sure that this passes, one thing we could do would be to change this and just create this from scratch and use CreateUser in there and use name in there and use avatar in there to create this constructor, or we could just simply use the CreateUserParams dot CreateUser and so on. So let's go ahead and use the second style. I hope you understand what I said. CreateUserParams dot name, and finally see CreateUserParams dot avatar. So you can see, and then finally we want to verify. Sorry, over here we want to verify that this gets called of that. And finally, we want to verify no more interactions with the CreateUser. Great. So this is our group. Let me go ahead and run the entire test. Let's see if that works. Yes, that passes. So let's go ahead and write another test for when there's a failure. So for that part, let's go ahead and copy this because this is long. And I'm going to paste that in here, BLoC test, and we can create the next test. And this time it should emit creating user, and finally it should emit authentication error when unsuccessful. So for the build, I don't want to copy that because it's different. So we're going to do whatever we do, and finally we're going to return the cubit. But then when CreateUser gets called of anything at all, but then answer with an invocation that we're never going to use, with async and a left server failure, where I'm just going to save this server failure up top because I think someone else will also use this. T server failure. It's API failure rather. API failure. API failure. I'm going to give it a message that says message status code that says 400. Okay. So when that happens, give it the T API failure. I'm going to close that out and cut that part. Yes. So that's our stub. After stubbing, we actually want to exit the build, which is over here. Where is my build? This is the build. We exit the build, and then we act. How are we going to act? We take that cubit. Why do I keep doing that? Cubit. And we say cubit.createUser. And we pass in t CreateUserParams.createUser, and we come here and do the same thing, CreateUserParams, CreateUserParams.name. No, not over here. We also t CreateUserParams.avatar, comma, close, also a comma rather, comma that out, and then we go ahead and we expect that we get a creating user, and we also expect that we get an authentication error with the message, which is the T server failure, API failure rather, dot error message. So we want to make sure that this is the same. And how do we make sure? Because these are equatable. All right, they have equation, so we can make sure that its message is the same. Excuse me. Its message is the same as that message up there. Finally, we can verify. Let me go ahead and copy these over. And that's our verification. Let me run the entire test. Everything passes. So our cubit CreateUser works properly. Let's go ahead and do the same thing for getUser, group, getUsers. And we have the, oh, why am I saying const? We have a block test. I've copied over my block test. Let me copy this over. Of our little block test. And we're gonna have the block test again later. But for now, let's go ahead and do this one. So what are we doing? Should emit getting users, and finally should emit users loaded when successful. And its build should, oh come on. We return the cubit after we do everything. But then when getUsers gets called, then answer with an asynchronous invocation, which is a write empty list of users. And then we return the cubit. We could go ahead and act and say that cubit, where the cubit dot get users gets called. Don't do that. And we can expect that we get two states. And the two states would be getting users at first. And finally, when it's completed, we want users loaded with an empty list of users. Because this is what's going to happen. And then we verify. We have two verifications, so let's go ahead and make that a curly brace. We verify that get users got called with nothing dot called once. And we also verify no more interactions with get users at that point. Let's go ahead and do something for the second person. Let's copy the build over. But first of all, let's do the should emit getting users authentication error when on successful. We have our builds. What did I copy? Oh, I copied the entire thing. So over here we have a left rather. Serve API failure. Return the cubit. And then we act by saying that cubit dot get users. And we expect constant getting users loaded. No, I'm just copying what I have up top. No, No, I want authentication error. Oh my days, I'm getting dizzy. Authentication error. And the message should be the TAPI failure.error message. So we don't want this to be constant. Only you can be constant, because you're a constant friend. Expect, and we finally verify, and our verification will be this. Let's run this test. Hopefully I haven't made any mistakes while I'm copy pasting. Yes, so every test has passed. And that is it. That is the test for our cubit or our block, whichever one you choose to test or to use. So close. Finally, we get to build out the UI. So now, after writing, remember you start out from your domain, then you build your data, because the data depend on the domain. So you start from domain, then you build. The domain is independent of everyone. It doesn't even depend on Flutter. It doesn't depend on framework. So like I said, domain will only contain raw Dart code, and it doesn't depend on anything at all. The data, however, cannot exist without the domain. The presentation then depends on mostly the views will depend on the app logic, which will be in the cubit or a block, and those ones will also depend on the domain. So that's how it all works. And see how crazy this is, because the domain will in turn be calling the data even though it does not depend on the data. How is it going to do that? Well, let's see how it's going to do that. So before we actually go ahead and build out the UI, let's go ahead and do the dependency injection. Because in the UI, we would need a cubit. So if we create a cubit and we go ahead and say cubit, for example, in our test, in our cubit test, we needed the cubit, and when we created that cubit up top in here, we had to pass in the CreateUser, the getUsers, and inside of the CreateUsers and getUsers, their use cases, we will have to also give them the repository. The repository also. So let's go ahead and see how that works. So for that, for dependency injection, we are going to be using the package called getIt. So add that to your dependency, Flutter pop add getIt, and Flutter pop get. And while that's added, let's go ahead and continue. So in here, inside of core, we create a new Dart file in a folder called services, and we can call that an injection container. Now, inside of our injection container, we will have to initialize the getIt service locator. So we're just going to call that SL. It will be equal to getIt.instance. Let's go ahead and import getIt. So this is how this is going to work. So let's go ahead. So first of all, create a future void. We call that init, or whatever you want to call that. And we go ahead and make it async. And then we start. So this is where you initialize every dependency. If you had more than one block, you will create all of them here. But we have only one cubit or block or whatever here. So we're going to create that in here. And then later on, whenever we need it, we can say SL, find me that block, and it finds it for you. So this is it. So let's go ahead and do that. So what cubit do we have? We have the authentic. So we start with sl.register. So when you're registering the application logic, the base, the first thingy, you register factory. All right. However, when you're registering dependency, you register lazy singleton. So remember, register factory is for the top. And what is at the top? It's the cubit. In this case, the authentication cubit. We initialize authentication cubit, right? What is your problem? Yeah, whatever. We initialize authentication cubit and we import it. Import that. We invoke it. Now it asks us for two things. create user, and it asks us for get users, the use cases. Now these are dependencies. You do not initialize them in here. You don't go get users and you initialize them here. No. Now this is where we inject. How do we inject? We invoke the service locator. So we say use the service locator and find me where I've initialized that use case. So we go ahead and also do the same for this person. Find me where I've initialized that dependency. We close it and we can go to the next one and say sl.register lazy singleton. Then we start registering our dependencies. What is the next dependency we want to register? This case it will be the create user. So let's go ahead and do that. So for the create user, whenever it looks for the create user, it will check in every singleton, every lazy singleton that you've created, and try finding the create user. In this case, this is the create user. The create user wants a repository. Let's go ahead and use a service locator to find the repository, and we close that up. Let's go ahead and do the register singleton again, and do the same thing for get users. But see, we're using this over and over, SL. We can just change this to use a cascade operator. That's what we call it in Dart. So instead of initializing or using this instance over and over and over again, we can just use it once and use double dots to access its value more than once. So we want to access SL dot register factory. We use dots. After that, we want to access the same SL dot register lazy singleton, and we also want to access the same SL dot register lazy singleton again, this time for get users, and it will take SL service locator as its dependency, and we also need to register this. Remember, now we've created these two dependencies. What about their dependency? They depend on a repository. Now this is where it gets crazy. So far we've gone from the presentation layer into the domain layer, because the use cases live in the domain layer. Now the use cases in the domain layer depend. Remember, the domain layer does not depend on anyone, but somehow it still depends on the data. Watch how this happens. This is loose coupling at its best. So the domain layer actually depends on the authentication repository. The authentication repository, the contract of it, lives inside of the same domain layer, right? But now watch, inside of the data layer, we have an implementation for that contract that implements that contract that lives in the domain. So in the domain, the use cases are actually depending on an auth repository which lives. So this domain layer actually lives and survives without any other outside factors. It does not need this to function. I can delete the data in the presentation and there will be no red squiggly lines inside of the domain. But once I delete the domain, there will be red squiggly lines in the data and in the presentation. So now let's see. The domain use cases need an auth repository which lives inside of the domain. Now when we're injecting dependencies, we actually will not give it the auth repository. So let's go ahead and register a dependency for it. We will not be giving it an authentication repository because this is an abstract class. You can see it's an abstract class. We can't instantiate this. You can see that little sign over there tells us it's abstract. We can't. Abstract classes can't be instantiated. Right there. There you go. Call that error. So what do? We go ahead and say whenever someone is looking for an authentication, whenever anyone's looking for an authentication repository, go ahead and give them the authentication repository implementation rod. And this one's also looking for a dependency, but we'll give that later. So for now, let's give it the S service locator and tell it code that. Right, so let's understand this for a bit. So the use case lives in the domain. The use case needs a repository to function. But then when we're injecting, how do we connect that data layer to the domain? how do we rather connect the domain to the data without actually connecting the domain to the data? We'll create a contract, and that contract will define the auth repository. But then when we're using the use case, we ask for that contract. However, when we're actually injecting that dependency in our inversion, we rather pass in the implementation of that contract which lives in the data layer. So now we're depending on the data layer without actually depending on the data layer. Isn't that crazy? It's crazy, right? I know. Sounds pretty cool. So let's go ahead and continue. After that, we go ahead and register. Remember, this person needs the data source. So now we register the data source, and it will be the... So now we also have a contract for the data source. So whenever someone's looking for the authentication remote data source, we want to give them the remote data src implementation. I think that's what I called it. Yes, auth remote data src implementation. So whenever they look for that, we want to give them this rather. And this one, should you be a constant, this person also wants a client. So for that client, we will also give them an SL. Oh my, that's a lot of dependencies. Now, after we pass that, I'm so sorry for how messy this looks. We can close this up and format that, and it should look prettier, but we're not done. We still need to inject the client. Remember, it depends on the client. So let's go ahead and do for the client as well. So we can go ahead and finally register lazy singleton for the client. And what client? So whenever someone looks for a client, we don't need to explicitly state HTTP client. You can go ahead and do that, but it's not necessary, because we don't have two versions of it. So the reason why I did this was because we had the contracts, and people would usually look for that. We usually depend on the raw contract. For example, entities. All of our modules were depending on the entity. However, in the remote data source, we actually went ahead and created and used the actual implementations of those entities. So in the same sense, that's what we're doing here. But the HTTP client does not have that type of principle going on for it. So let's go ahead and just instantiate http.client, and for that we need to import http as http. Now we can close this. However, since this is empty, so as you can see, everything is using the service locator until we get to the final thing. So the final thing is the actual external dependencies. So our external dependencies, we can instantiate them on their own. Like we can instantiate them without service locators. Alright, so the last thing is the outside world. We can instantiate them without the service locator. So for this, we can actually just go ahead and say client.new. Dartz has this. It's called a tear off. Instead of actually just going ahead and invoking this is also just going to create a new instance of this. Every class has that new inside of it, so we can just go ahead and remove that invocation and say .new. It will still do the same thing. So this is it. So we can split this into different parts. So first of all, this is our application logic. And these are our use cases. After the use cases, we have our repositories, and then we finally have our data sources, and then we finally have our external dependencies from the outside world. So this is how you can structure your dependency injection. This is how it usually goes. So from the start, we start with a register factory, and the rest of them we register them lazily whenever we need them. So this is our injection completed. Now you want to call this injection whenever your application starts, which is in the main.dart. So in the main, you actually want to do await init. And since we're awaiting something, let's mark this as async. Import init from injection container. Delete this and do a package import. I prefer to do package imports. We chain this to a future void. And remember, in Flutter, every time you're awaiting something in the main function, you want to do widgets flutter binding.ensure initialize. So that's it. Time to create the UI and start the application. So let's go ahead and start that. In our source presentation, we create the views. Dart file, we create views. Home screen.dart. We start off by saying, first of all, in our main, what is our home? The home should rather be, I'm actually just going to theme this out. Theme data. Should I go ahead and start my emulator? Go ahead and start this. Let's minimize that, that's too much. I'm gonna put that right here. No, that's too small. Let's wait for it to start off. So let's code boot this. Let's give that a bit. Main.dart. While that starts, let's go ahead and create the home. So the home will simply be the home screen.dart. So let's go ahead and import material. STLess home screen. Go ahead and go into main and say home screen should be our main. So now, when using BLoC, after creating your BLoC, so we're going to be using the BLoC in the home screen. You have to inject the BLoC into the widget tree. How do you do that? You go one parent up and inject it. So we're in the home screen, we're going to be using it here. So I'm going to go one parent up, which will be my material app, and I'm going to inject my BLoC over here. So I'll wrap that with BLoC provider. These snippets come from the plugin that I've shown you. I think that's where it comes from. I'm not sure. I think that's where it comes from. So we have a BLoC provider. We're simply going to inject our cubit rather. So what is the cubit? It's the authentication cubit. But remember that if we did this, it would want to give us to create the user, and the CreateUser would ask us for the repository, and the repository would ask us for so forth and so on. But we've already done that while injecting dependency. So simply what we're going to do is call the service locator and then tell it what we're looking for, the type of what we're looking for. So SL, and we're looking for the authentication cubit, and we invoke that. Alright, so that will give us what we're looking for. Flutter BLoC, you can see that from the Flutter BLoC package. So we've injected our authentication cubit down to the widget tree, so we can use it everywhere in the material app. If you wanted it to be only specific to the home screen, then you can come and wrap the home screen directly. You can come and wrap the home screen directly with it, and maybe wrap it with a builder in order to create a separate context for it. But we're not doing that in this application. We'll see that when we're creating the actual application. So we've injected our BLoC into the my pixels crashing. We've injected that into the widget tree. Let's go ahead and start building out the UI. So first things first, let's create a scaffold. Not me putting a comma. And in this body, let's have a center, a list view rather. Right, and then we have also body center. Inside the outside the body, we have the floating action button, and in here we have a fab floating action button. In its child, is it the child? In its onPressed first, so let's give it that first. We will add a user. Its child will be an icon, icons.add. Change it to a constant. We can make it extended actually, extended, and we can simply say this should be the icon, and after the icon we have a label, and it will say text add user. What is this going to do? It's going to call the block and use the block.cubit and use the cubit.addUser. How are we going to do that? In order to access the cubit in an onPressed in a function, you usually want to do context.read rather. Alright, context.read. Context.read what? Read the authentication cubit. This is how we do. We'll get that later. Authentication cubit dot, let me import block. Come on. What's a block import? So we can say dot create user. And we can create the user by giving it the creator that, which will be datetime.now. What format does it expect the creator that to be in? Let's see. Creator that. We're just going to convert our datetime object to a string, and let's see how that works for it. Why is my pixel crashing? I'm going to stop that and restart. Alright, so that's loaded a little bit, but we're going to take datetime.now.toString, send it to the server. It crashed again. This is why I dislike emulators. I'm going to use my physical device for this. So let me go ahead and delete this emulator. Thank you. I really dislike them. So, for our name, we're just going to, should we generate a random name? How do we get a name? What name should we use? Well, let's create a text field rather. When we click on that, let's show dialog. Its context will be the context. Its builder will simply be a context. And we should return a add user dialog. I'm going to create that later. We want to wait for this. Right. Then in here, we actually want to get the data from the server. So once this screen starts, we actually want to call the server and say, look server, get me the users. So how are we going to do that? We need the block for that. We need a way to do that. So I want to do that in the init state. So once this thingy gets started, so let's go ahead and create a function that would do that. get users. No, we don't need async. We can just say context.read. And we can say authentication cubit. And we can say dot get users. Now that will start the process of going between the layers and getting the users, and finally the block emitting that state to us. So let's go ahead and call that in our init state. Get users, and we can do the, no, let's first do the super init state, and then we can get users. Now what this means is once this screen, once this widget gets built, starts getting built, once it completes the init state, it will get the users. It will call the block and ask it to get the users. Now we have to start listening to the block over here. So let's go ahead and wrap the entire page with a block consumer. So we have different types of UI stuff that we can use for our block. We have the block builder, consumer, and listener. Now the builder is what we use when we're listening for a state and we want to update the UI based on the state of the block. The listener is what we use when we don't want to update the UI, but we want to run a function. We want to carry out an action based on the state of a block. You don't want to do that in a builder. You don't want to carry out a function while your page is building. Dart will throw an error, Flutter will throw an error. Then the consumer is if you want to have both functionality, right? So let's go ahead and see if inside of this place we wanted to have a state to say if the state is loading. So for example in here we can say that the body, right, so state, if the state is getting users, yeah, we want to return a constant. Center child will be a circular progress indicator. Else we want to return this. Okay, so this is how this would work in a builder. However, what if when there's an error we want to show a snack bar? You don't want to do that in here. If state is error state, no, you want to do that in a listener. So in your listener you can go ahead and say if state is authentication error, then do what? Then go ahead and show a snack bar. So scaffold messenger dot snap. So if it's either an authentication error or if it's just an authentication error, because both adding and getting users both show the error through this person. So scaffold messenger dot off context dot show snack bar, and we show a snack bar with its content being the state dot message, because the authentication error has that little thingy in it. It has the message inside of it. So let's go ahead and add the authentication cubit, and over here we have the authentication state, so that it knows that we're talking about the auth cubit and the auth state. So wrap it in a text widget, change it over here. This is a simple snack bar. Let's go ahead and add more checks. So if state is, if we've successfully added a user, if its state is user created, if we've added a new user, then we want to refresh the screen, right? We want to call get users again and fetch every user again from the server. So we want to call get users again. So when we're getting users, what do we want to do? When we're getting users, we want to show a circular progress indicator. So this is how it would work. If we added the user, it will start getting users again, meaning that inside the block will actually change the state to getting users, and the UI will change to be a circular progress indicator. So these work hand in hand. When it completely gets the user, it will show us the list view builder with the children. So over here, we actually want to do this. Else if state is no, I actually want to do something different. Wait. If the state is users loaded, we actually want to do this. We actually want to show the center. Else, this time we're checking if the state is, oh my, that's a long check. If we keep this going, we would have to consider every possibility, because when we hit the add user dialog, when they add that user, then the state will change into adding user, and so forth and so on. And remember that I told you that the reason why I split the loading state into getting users and adding and creating users is because we want to show a message. So let's go ahead and create this as a separate widget for showing so new Dart file, not in the views, still inside of the presentation. We want a new Dart file in widgets. We create a widgets folder and we create, let's call it a loading column. So we can have import material, stateless widget, loading column, and we can return, instead of a circular progress indicator, we can return a column with its children being a circular progress indicator. Remove this. Right, and then under we have size box of height 10, let's say 10. And then finally we have a text widget. I think we would have to add the constant over here and remove it from the rest of them. A text will have the loading message. Let's add the message and add a dot to the message. And we take the message from the constructor message. What is the problem? Yeah, it can't be a constant. So we have to add constant to the rest of view. And that's our loading column. So if there's a loading state, if it's getting users, then we want to have a loading column with the message being getting users. Fetching users. Else state is not getting users, creating user. We can have a loading column. This is dirty UI. You can make this nicer. Creating user. Else, if the state is users loaded, do this. So we have getting users, creating users, users loaded, and we also have user added. So when it's user added, we don't have to worry, because user added is being handled here, where it will simply change the state again to loading users. So at that point, we can assume that we already have the solid users loaded over here. However, else we just want to show, should we just show a size box dot shrink? Let's do it that way. Yeah, that's better. So we're basically handling every single case. So let's go ahead and create the add user dialog as well. Material, stateless add user dialog. So it goes ahead and calls that. Let's save this. This person returns material. Let's remove you. Child will be a centered container. It will have child to be column. Its children will be 3 text fields. Decoration will be outlined. Input decoration. And then we have the label to be username, whatever. Username. Wrap that in a text widget. Or just change it to label text. Yes. We will have the same text field twice. So this time it will rather be, we need username created at. No, we also don't even need this. So we only need the username and that's it. Boom, 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 boom. Add my container back. We need padding. Const edge insets dot all. We need 20. And we finally have a decoration. Box decoration. Border radius will be border radius dot circular 20. And we have a colors dot white. We add a constant. I think that's enough. So over here we will take the final text editing controller, name controller. And we will pass that name controller to this person. No, controller. Right, that's it. Invalid constant value. So we can close this much. We can save the name controller up here. Nice. You can't be constant because of that. We still save you that way. No, we can't. Now, that should handle that. So when that's done, once the user's completed, then we need a button over here. So elevated button that will say, is it label or something? Or child. Text widget that says CreateUser. And on pressed, we could either do this here or on the other screen, but this tutorial is not about building this app, so we're just going to do whatever. So on pressed of this, we want to collect final name is equal to name controller dot text dot trim, and then we want to call the context dot read authentication cubit dot create user, and we can pass in the creator that to be date time dot now, the name to be the name. Yeah, we already did that, sorry. And the avatar, let me go and find some avatar link. Do they have any avatar links here that I can just steal? No, I'm gonna go find one. I found an avatar URL which they use when we try to get the data from here. You can see the data that we auto generated. They have some avatars. So let me just go ahead and copy this one. Lucille Dorley. I'm going to cancel. I've stolen that avatar. So over here we simply save that final avatar will be equal to that. Save that bit. But change this to a constant. Cut this part out. Nice. We can do this. Datetime.now .toString. The name, the avatar will simply be that avatar. So we call the context.createUser, and back in the home screen it will reflect over here that we're creating a user. We're creating user, and it will start that loading indicator that says CreateUser. Simple. So now in the list view builder, when we're sure that the users are loaded, we can take the state's user. So now the item count will be what? It will be the state, which in this case is a users loaded, and users loaded has users. So dot length dot users, and then we have the item builder, which will be the context and the index, and we can return a list tile whose leading is going to be an image.network, and we can pass in the let's get our user extracted by doing final user will be equal to users at the index. No, states.users at the index. With that, we can go ahead and user.avatar. Title will be text with the user.name. Finally, the subtitle will be a text with the user.creator that. The sublists, substring rather, 0 to 10. I think 10's, we have 2022, blah, 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 blah. Up to 10. And that's it. Finally, this will build us everything. It will build everything out for us. I don't think we need anything else, so I'm going to start the application. Hopefully nothing goes wrong. Let's go ahead and run. 404 error, not found. So we've got an error, not found. Let's go ahead and let me pack this to the side. Put it up this way. So we got a 404 not found error. Let's try that again and see what's happened. When it's loading, that's not pretty. That's not a pretty loader. Go ahead and even main axis alignment. Center. On the cross axis, why aren't you centered? me go ahead and wrap the entire thing in center itself and restart again. 404 error, not found. I think something's wrong with my endpoint. Let me go ahead and print the URL. Where's my data source? Getting users, get user. Let's see what it prints out for us. So you're telling me that when I copy this and go to my browser, that it will actually error out. Is that what you're telling me? Not found. Why? Why? Test API. Users. Oh, it's not user, it's users. Users, my bad. So we can just come back up here and see users. Right, sorry, users. So restart. Let's get our users. This time should work. We already have 2 users, Lucille Dawley and William Howie, PhD. So we can go ahead and add a user. Oh my, that's ugly. That's very ugly. So the username will be John MacArthur. Create a user. No. We've actually messed this up. After they hit that create user, we actually want to pop. We want to start this and then we pop the context. So where is it? Add user dialog. We need to pop this context. So first of all, we added a material. We made it this. We made padding 20. Could we remove the material? This would still work. Yeah, it needs material. So it won't work without material. Let's go back there and see, make sure that we have 3 users. Did it work? Yeah, we have 3 users now, so the add actually works, but our UI is not nice as we want it to be. So centered container, adding everything, box constraints, main axis size dot minimum. Yes, and transparency. Is it behavior or type? Yes. What type are you expecting? Material type dot transparency. Yes, that's what we're looking for. And then the container will also have a margin. At constant edge insets dot symmetric horizontal. We can have 20. Now, after the user does this, we actually want to pop the context. Alright, so I've cleared the database. Let me go ahead and restart this. Let's see. It should be empty because there's no users yet. Right, and then we can add a user. John MacArthur. We can create user. Creating user. We can see that message is different from when we're getting users. And now it never stops creating user. Oh, it actually completes it. But it's generating random user data. Oh my days. It's not using our data. Yeah, that's all great. It's still, I think that's how this thingy works. It generates with the random data. Let me see. Alright. Something's actually wrong with mine. So no. This should actually generate my user perfectly. I've flared out the server. I think I figured out why. it wasn't recognizing my data and using its own dummy data to create my user. It was, let me see, it was, I think, the headers, right? It was actually sending this without, I was sending this without headers, so I thought, why not? So we need to tell it content type, which will be application JSON, I think. Probably application JSON. Let's try that again. Mac Arthur John. It's rather a slash, sorry. Reload, add a user, create user. Yes, so that works now. We could remove the avatar and they will generate automatically an avatar for us, I think. I don't know how this works. Let's see. We can also go ahead and do username random. Create user. Would that work? Yes. It creates a random one for us. So that's that, folks. That's how everything works. Bootbot. The home screen works now. The add user dialog works. Everything's connected. And this was a simple one feature project with clean architecture. Now let's go ahead and dive into the main project. See you guys on the flip side.